demo again and give you guys the chance to do the labs for that. Afterwards, after that one, I will show you guys the fuzzing that did not work yesterday. I found out there was one little thing that I did wrong there. But if you follow the README and the way I did it yesterday, right, I moved over the SO library that I got out of that Signal application. I moved it into that same folder. And I used the same README files commands, but then replaced that SO library over there and my harness, of course. So it was quite simple to do. You can just copy and paste everything and it should work. Yesterday, because it was a long day, I started typing stuff myself. I made a little mistake over there. But I would like to give the word first to Praveen, and then you guys can start right away with the libfuzzer example. Are there any questions or any thing you would like to say before we start? Anyone? No? Okay, then let's start with Praveen's class from yesterday with the Corellium thing. Praveen, can you take over the...
Sure, thank you. Hi everyone, good morning to all. So today we'll let's start the Corellium lab exercise. So let me pull out my PPT. So
by 1 second, Praveen, is everyone up and running at the moment, by the way? Is your virtual machine running? Do we have people who are having issues or anything? You can contact me in the meanwhile while Praveen speaks.
So I hope everyone virtual machine is up and running. Then please log into your Corellium and download the OVPN file. I think I have already downloaded it actually. It's here in my VM. 1 minute. VM. First, let me clear the clear, and so you have to run your OpenVM with a sudo permission because it creates a tunnel interface. So that's the reason. Now now I connected to the Corellium device. Let me also do a ADB connect. Yes, I have connected to the Corellium device now. So yesterday we left on the lab part. So we'll continue with the lab part. So in the lab, first we have to compile our vulnerable function with fuzzer, with fuzzing enable, fuzzer enable to sanitize to instrument our targeted library. So let me know right here. I think this we're going to do a cross compile. We're going to do a cross compile. Oh.
By the way, is there someone in this class that misses this libfuzzer on device folder in the fuzzing directory?
Yeah, please go to desktop example fuzzing and libfuzzer devices.
Check if you have this directory. If you don't have it, I'm going to share a link where you can download the whole directory in one go.
I think Matthew misses what.
All right, I'm going to share a link so you can download it.
So I'll compile the library. Not get this error.
I think it should work without the part, right?
Yes, but I have have worked something else with yesterday, so that's the reason.
Okay, yeah, for everyone, you don't have to add the whole full path. You can just use this command.
Yesterday I was working with something else, so I
Yeah.
think I changed my all my image scripts were changed, file scripts were changed. So we're going to compile it. You don't need to give a path. You can directly access the CLang actually, CLang compiler. So first we'll compile it. Yes, I think we got a lot of chat. My Corellium credentials are not working. I think Andy, I will help you on that. Once I'm done, I'll help you on that. Andy and Ashley, I will help you once
Yeah,
I'm done.
I will also help. But for you, Darius, you can just use one of them. It doesn't matter. You will be connected to the network.
So here, so
I mean, open
now-
VPN file, Darius, I guess.
So now you can see the lib test hello of the file is created. So now we're going to link with this. I will link with us, link with object file with our harness. So, so now we have compiled the harness. This. So if you see, it is an ARM ArcTix 64. So that now it is the harness is ready to move to the device. Cross compiled it and it's ready to move to the device. So I'm going to move to the location, data, local. We do an ADB share. Questions popping up. So I have moved already the libc++ share.so file because this file is needed. Please move the file. It will be available on your same libfuzzer on device directory. So please push this file too. I do it once again. This library is not available on the device, so please move it. LD underscore break path, the current directory, and run our harness. So here you can see it. Your application is getting crashed. The ASAN popped up. So you can see that it found it first, and because I given as a character size is 7, so ASAN triggered up when it found the outerbound read. So to analyze more about the crash, also you can go back later, but we have to find exact length of the string which create the crash. So in libfuzzer, there are multiple ways to provide the inputs actually. So sorry, not multiple way. Now we're not provided any input to the libfuzzer. Libfuzzer mutated by itself. So, and also when it mutates, it has maximum length of default length is it's for 4096 bytes. So you can find somewhere here, I think. So here the larger input is not greater than larger than 4096 bytes. So for when we provide an input, what will happen if you give a default? It will not mutate more than 4096 bytes. So in that perspective, we can give a maximum length. So I'll show you up. So in like especially on libfuzzer, they say giving input as a corpus. I have already created a file. Let me create some example input. And so it found it actually. So now we have provided input to our oh sorry, max length is not used. Let me check. I think I given something wrong. It's a max len, it's not length. Shit. Then right.
Praveen, I think there's a typo. It's MAR.
Oh, sorry, max, sorry. Then. So you can define the length actually and mention the corpus directory. It will take it. Will start take input from your sorry, your fuzzer will take input from input and it will start mutated what the input we have been providing to the fuzzer. So next one is like still we do not get the exact length. What we can do is whatever we run, whenever we run a fuzzer, sorry. So if you run the fuzzer, still ASAN will pop up the crash. So to avoid the crash, to reach our exact crash length, so what you can do is you can do a ignore crashes. Crashes equal to 1. For ignore crashes, we need a fork server. To enabling fork server, if you have to give the value, you can give multiple fork servers too. So what will happen now? Now this fuzzer will start ignoring the crash and will start fuzzing actually. Till we cancel. Till we give the control C actually. So now we'll analyze the crashes. So you can see it created a lot of crash files. So I think this size is will help us actually. So let me copy. Cat. So we have some size. First, with the length. So what we'll do, we'll provide this crash input to the fuzzer. So how are we going to analyze the crash? Where the crash, which function the crash exactly happened? Because normally, if you enable with your ASAN, what will happen is like, I won't know what there are a few questions. So what will happen actually? When you enable with ASAN, ASAN will try to find the exact symbols according to the offsets. Currently, what the problem is like, we are getting this ASAN crash symbolizer error actually. So I have problem with ASAN symbolizer. So so what you can do is we can to analyze this crash. This is the exact function path you get the crash. This offset is an exact function. Sorry, this is an exact offset where your application get crashed. So we can analyze it in a multiple way. One of the ways we can use GDB, or LLVM also provide one more tool called LLVM symbolizer. So LLVM symbolizer is already available on your machine, like on your VM. You can use --- object equal to point your harness here, harness, and copy the offset. So we can find here the vulnerable function is your pass txt. In pass txt, the line number 15 :7 is a vulnerable function. So what you can do is like nano lib test hello. See, so the crash happens at string copy. So this is a vulnerable function. This is one of this is another way where we can use LLVM core tool to analyze the crashes. If you have if you have a source code and if you compile with your compile with LLVM for LLVM CLang, so obviously this tool will help you out when you get the crash and the address annotator shows up the back trace where the symbol is not resolved. It's not resolving properly, or due to some ASAN error, or sometimes usually it should show the exact crash function, but in our scenario it doesn't show it up. It doesn't show in the function. So here you can see the Stack Overflow, but still you could not able to resolve the function, but it directly lies on your ASAN. ASAN SO file throws up this backtrace. So this is about the lab. You can do the lab. If any question, please ping me. So I'm ready to help some people on the credential part. Umid, can you take over the?
Yes.
Do you have any questions?
Let's provide the credentials, Praveen, and then I will give everyone around 10 minutes to do the labs, and in between we will solve the credential issue.
Please ping me on Slack so that I will reset your credentials. Please ping me anyone has the access to Corellium in Slack.
So what we did actually also yesterday, right? We had two different ways of fuzzing, and we showed actually the emulated fuzzing. We used the emulator first of all to emulate, but also that enabled us to instrument a closed source binary. Because if you don't have the source, it's not that easy to add that instrumentation. And whenever you have the source, then you might want to look at libfuzzer, because with libfuzzer it will be faster in some cases. And yeah, we are showing two different solutions where you can use that. And in the libfuzzer version, that Praveen showed, that is a strategy that you will use if you see a dependency where the source code is available on the internet, for example. If you can find the source, for example, just as an example, you download one app and you analyze it, you go into the lib folders and you notice that they are using libxml2 library. And they do that maybe to process incoming SOAP messages, just as an example. That would mean that you can actually start doing analysis on libxml, just downloading the source and then use to compile it. You can compile it and run it. So you can do it also on your own system, right? For example, on your laptop with libfuzzer. But there's also a way to do cross-compiling and fuzz it like Praveen showed on the device itself.
I hope everyone can log in now to the Corellium. I have shared the URL.
Yes, the sudo that you see there, it's a non-capital sudo. So, Zoom did that. By the way, sorry. Praveen, you were speaking. Sorry,
I got a chat. So please check the compiler harness check the file with harness, and it should be AR64 ARM on your VM. So if it is not AR64, please recompile. So it should be like this: file harness. Please move to the file and give an execute CMO, give a permission, execute permission, and try to run it. If it is AR64 ARM, definitely it should run in the device. On the device. On. And it looks, error looks like
Praveen, can you maybe provide the lab slides? From which slide
Sure.
to what? So the lab time is over. Do you guys want to continue or continue or take a bit more time for this lab? Please give it a react on the chat if you want. Yes, let's continue this lab. Yeah, okay, then we'll wait for a little bit more. That means then you are not connected at the moment. Is your SoCal running? On your base machine, the SoCal.
to compile.
Okay, I see that there are a few issues over here. Andy, you have an issue with the emulator running, but you can do this on the lab that we are doing right now is on Corellium, right? But if your VM is not responding on anything, the Android emulator that we started up yesterday, you need to do cold boot on.
Please run your VPN on your Corellium device. Sorry, not Corellium, your Ubuntu, not on your base machine.
Okay, Praveen, can you have a look at why the machine of Andy is not responding? You can see that there, right?
Sure, Ramat.
Is it responding, or I can also? And let's see what role does Pro play in on the fuzzing on the device. Is Corellium needed today? No, for the rest of the day we won't use Corellium, and there is a reason why we don't use Corellium the whole day. We wanted to use Corellium actually to show x80 64-bit exploitation instead of the 32-bit. But the issue was that when we did the debugging, it was quite slow. Even if we made it with the root file system on our local system, so that it doesn't have to pull those files constantly, it was slow, and we had less time to contact Corellium that they do something to make it faster. But therefore, we also decided to create this emulator that you're using, so that anyone who wants to play around with this configuration that we gave you, or you want to redo the labs and stuff, you will have the same device and everything already on your machine, so you don't have to use Corellium. But if you are serious in doing real research, then Corellium is a good option actually. And the question that that's for you, Matt, so we don't use it later. And so no worries about that. Where can we find all the comments for the Corellium lab? In the slides of yesterday. So I sent the new slides for today already, but you can use the slides of yesterday. And if I'm correct, Andy replied also, and it's saying 104, starting from slide 104. Ah, cool. But Corellium is very good if you are doing research on iOS, because it provides you to use different OS versions, and it's already rooted, so you don't have that headache what we had in the past, right, with finding rooted devices, or because it's very difficult sometimes, right? Now it's not that difficult anymore for a lot of devices because we have Checkmate exploit, so it's quite easy. But it still to be able and have the freedom to create a machine, disable it, open multiple machines. It's very useful if you do research on mobile using Corellium. And what role does Corellium play on the device fuzzing? We used actually Corellium because it is a 64-bit machine, and the fuzzing examples we wanted to keep them 64-bit. Not really, actually. It's I think it's 50 cents per hour per core or per 2 cores, if I remember it correctly. If you forget to turn them off, then it's quite expensive, yes. And that happens. I can tell you that happens because sometimes you're busy and you will forget to turn it off. Wake up the day after and realize, oh no, I forgot to turn them off. No, you don't worry, we will turn them off for you. So there's no issue. You guys can just take your time and play around with it. That's no problem. I also had the same issue with AWS, by the way. I don't know if you guys ever had that, but finding sometimes things back and turning them off in AWS, it's like going and searching through everything to turn it off. So guys, shall we continue? Can you raise your hand if you're done with this part? And we will actually look quickly also at the fuzzing that I wanted to show yesterday, which did not work in the end. Yeah, I'll just wait until more hands will be raised. Please keep your hands raised so that we can see that the lab is done. Do not lower it yet. We will lower them for you. So it gives an indication who's ready. Would you guys like to do another fuzzing lab? The one that I showed yesterday, that you can do it. In the end, I ask you guys to fuzz the Signals mobile coin library that we found. You guys can do that. I will again explain quickly and then show that it works for me, that you guys can try it out yourself. It should be very easy to do it because it's just moving the SO file, SO library into the fuzzing ARM64 fuzzing directory, changing the harness, and you should be good to go actually. We can try that out after this. So please raise your hand if you're done. All right, guys, I think it's a good idea to continue right now. We have a lot of things to cover. So let me turn on my camera. Just say hi to everyone. Okay. Now, I showed yesterday that we were able to do some fuzzing because I showed an example where we did all the steps, where I showed all the steps. I actually asked you guys to do it in the beginning or at the end to see if anyone was able to do that. And now, yesterday, I showed the same example. Yeah, it does. Okay, 1 second, because I watched the message that came. So this is my screen, right? What we did yesterday. One of you asked, okay, can you show the whole how we would do that, right? On how we would do all the steps. So what we did, and this is actually the slides of yesterday, right? In the example folders, I went to apps and I run ADB APK tool against this signal app. So you can do that as also APK tool, dump as in the slides, and then pass in signal. .apk. So you can, it's already exists, it says for me, right? But if you guys run it, it will give you this directory. In that directory, again, there is a lot of stuff right now, but we are focusing on this lib folder. And in the lib folder, you can see there is this ARM64v8 thing. Since we have configured our fuzzer to be able to fuzz ARM64v8 things, you should be easily able to harness those. Then what I did is open one of those libraries in libmobilecoin, right? I opened that in Ghidra, and I started looking at the export as we discussed earlier. And I also said that fuzzing those JNI parameters can be sometimes a difficult thing. Oh, sorry, this is something else. But we looked at those Java calls, and they had weird, some of them have difficult parameters to create if you do this emulated fuzzing as I showed yesterday. You can do it, of course, there are ways to do it, but that will make it very slow. And a better strategy would be to choose one of those sub-functions that you see here below that is somewhere getting called, and that's branching into multiple other functions. Because anyway, so after loading this in, I found one of the exports, for example, such as this one. I found one. I will show you guys in a minute which one, but it's in my harness. We can actually open it, no problem, but it will take some time again to load. So I'll skip that part if you don't mind. But what I did after that, I moved the libcoin into the fuzzing folder. And I suggest you do that too, because it will save you a lot of time. In the fuzzing folder, we had the ARM64 fuzzing folder. There are already some of those dependencies that library will need. I moved the libcoin SO in that same folder to make it a bit easier for myself and as an example for you. When you open the harness that I created, obviously you need to change the harness, right? Because we're gonna harness another function. We harnessed in that SO library, the mobile lib mobile coin. There was this function in there which is exported. You can connect with it or do the function call if you link your harness with it. I did that actually by using this external. I will send this in the group to make it a little bit easier for you guys to go over the lab so that we don't lose too much time, right? Let's see, where is the okay. So you can use this in a minute in your harness, right, to make it easier. I'll send it also in the chat. And what we are doing over here, we are saying we use an external function, which is written in C, and that there we use the function signature to prototype it so that C knows how to connect with it, right? And then we prepared our fuzzer. We are just using the same harness, which reads 64 bytes reads 64 bytes from a file that we can pass in as the argument. And then we'll do the function call. So if you run this, right, and I made it easy, right, because you can use this README file. I'm going to show you how you guys can do it. So you copy libmobilecoin, you unzip first in the directory, in the examples directory, in the apps folder, Signal, or any other one that you would like to do. So feel free to play around with it, but maybe you will not get the lab done. That's another thing. But do not open it in Ghidra right now. It will take some time. Just use APK tool D to dump it. In this folder, you will have the libmobilecoin folder. You can move it to this ARM64 fuzzing folder by copying it into there, and then use the README file to follow the instructions. This was not part of the original labs. We added it extra in there, but I think it's a good example. So it's quite simple. You copy this thing, but you modify in here which library you're linking with, right? And there was this libmobilecoin, and you don't use the lib. You use always the name like this when you link to it. And we give the directory where that library is, and we can use dot because that's the current directory that we are in. Now, we use our cross compiler to compile it. There's no error. You can now set your QEMU again with the correct values, with the root file pointing to your root file system, what we did earlier. Now you can use LD library path to set the library path within the emulator, so that within the emulator, when the binary when your harness get executed, it will know where to search for those libraries that it is depending on. Now that is done, then you can run AFL QEMU trace. Here you need to give the full path, so you can do desktop and then pass it in like that. You should be able to. Sorry, AFL /. So you can see your harness worked actually, no problem at all. Now you can, in this part, we are showing if you face an issue, you can copy those files in there. You don't have to do that. We did that already for you, but that isn't. We are showing that sometimes you will see that when you test your harness, remember we are testing our harness using AFL QEMU trace to test if the harness works actually, because if our harness crashes, that means the bug is not in the function that we call, but it is in our harness. And to test those things out, you can use AFL QEMU trace and later replace AFL QEMU trace with AFL fuzz. Now, yesterday, what was going wrong, that I made a typo over here and the libraries were not getting instrumented. That's why we did not get more code paths, because AFL did not get any feedback from the library itself that we were doing. It only instrumented our own harness, and that's not what we want. We want him to instrument the SO library that we are linking to. Now, we can test it out, right? I'm going to use the command so that we don't make any typo anymore. You can change this to desktop because we need to point it out to where AFL is. Plus. And using the Q option, we are saying use the emulator. Instrumented, this is a black box instrumentation that you use. AFL ins lib variable we are setting because we tell AFL to also instrument the SO libraries. And that makes sense, right? Because we are targeting that SO library or that function that is in that SO library. So it needs to instrument that as well. Then we passed in an AFL in, and with AFL out, in AFL in, we created that directory ourselves. It's already in your working directory, and it contains already an input file, which is simple some AAA in there. You can see the output over here, right? But then you can specify an out folder. You can choose any name there because it will create that directory. And those minus mean after this, my normal command or my binary comes and the normal parameters that I have to feed into it. And this one was a special one because with this one, AFL knows this is the file input that I will mutate and send into the harness. Now, or the application that you are fuzzing. So when you run this, you see right away that total paths are growing, and that's a good sign, right? Because that is exactly what we want. That is the situation that you're hoping for, that you will reach many code paths, and the more code paths you reach, the better it is, because your input is reaching more and more code paths. Now, this is the example that I'm showing. Unfortunately, we don't have those slides for it, but I think it's a good exercise for you guys to try out. Use ADB APK tool that you learned yesterday to dump the Signal or any other app that you see in the example folder. I would stay with the Signal one and use the libmobile coin the way I did it, because it will take a bit of time for Ghidra to load your, if you wanted to do reversing right now, it will take some time, right? So just follow along and do this. Is it understandable? Just ask me any question in between. If you're doing this and you're facing any trouble, just let me know. I will just right away help or answer through the Zoom call, so that everyone can finish this lab. Do we all understand what to do, or would you like me to repeat some parts? Don't be shy, guys. You can just speak, it's no problem. Lowering the hands right here. Ask again if you're done. I'm setting a timer, and when you're done, just let me know by raising your hands. If you want me to send commands also, I can send them, it's no problem. For example, this one was not, you needed to add the full path to it. I'll send those in the chat. Right. Oh, sorry, that is not the correct command. Sorry. Where's the correct one? So I sent the command to test your harness. I'll send one of those in the chat of Zoom. can you share the complete harness you used in Signal? I added a function pointer and invoked it, but I'm getting a compilation error. What is your error that you're getting? Can you share the error? So yeah, I'll also, the only thing that I did in my harness is I added this part to it and just changed the function for. Sending it in the Slack channel, the full, I think it has to do with the import of the shared library. Yes, that is possible. So this is the harness that I use. I just sent you guys over the Slack channel. You can also send it in Zoom if you guys want. This is the whole harness itself. Then, this is a harness that we use. And let's see. That's someone else. Yeah, if you want to compile, you just need to make sure that that you move libmobilecoin into the same folder, right? In the ARM64 fuzzy. Look, I did that already. That's why it works for me. And doing the compilation, compiling the harness, you just need to make sure that you use this command over here, compile it. And note that the small L that you see over here is saying, hey, I'm using libmobilecoin, but you can remove that. This is how it works, right? When you link to it, they all have lib in front of it, but you remove the lib from it and also the .so of that file, then it will be able to link to it. With the capital L, we are saying, you know, our file, when you link to it, this is the name of it, but to look for the file, you need to use the capital L to pass in the path. That's why I'm using dot, because I'm in the directory where I'm compiling, and the libmobilecoin is there. And when you're done with that, you should be able to run the fuzz command or test it first. I sent both commands in the both chats. With this one, you can test it, and with the other one, the fuzz one, this is all already in the slides. Let me send the last command also, so that it will run for you guys. When you have compiled it, you should be able to use this command to execute. Anyone facing issues? Also, if you're done, just raise your hand again. Wow, Matthew, nice. Does it fuzz for you now? We should be seeing a lot of code paths coming. And did you find anything? Praveen asked me to let it run, actually. But I said, no, I will just kill it, because the problem is that. So did you have any crashes, by the way? That would be interesting. I think this stuff has been, I hit 5, yeah, but no crashes. Yeah, you know why? I noticed that this is written in Rust, because Android nowadays allows you also to write the SO libraries in Rust. And like I said, Android is going to move little by little all these components that they have, even in the kernel, to Rust. So that means less bugs. The attack factor is going to shrink, right? The memory corruption bugs will be less, but I'll bet you there will be still memory corruption issues. But yeah, it will make it a bit safer, actually. I actually saw it by looking in the on their GitHub. I tried to find if there is. Sorry, by the way, I think I made a mistake. Now I'm making a mistake. Sorry, the code itself that that is written by let's see, because maybe I'm making a mistake. But what I saw in how I knew is there was in here a Rust reference to Rust. And also when you go to their GitHub, mobile coin. Yeah, so this part, but this is not that one. So when I came to the Signal pages, I noticed that Signal, yeah, mobile coin Signal, and I saw that most of the code that they have written is in, this is in Swift, lib mobile coin. So, anyways, when I searched for it on the internet, I was able to find references that they were using Rust. And when I opened it later in Kidra, I noticed that there was a reference to Rust. I don't know if this library itself, but a lot of parts of Signal have been written in Rust as well. So, and did you guys see the Pawnee Awards? Especially this one.
No.
It is, I think he's going to speak tomorrow. So this is a very cool talk if you are at Black Hat or you want to join the Black Hat briefings. This is a very nice one. One chip stack buffer overflow to rule them all. It's for the Galaxy S20, and so it's very cool. I'm going to join it to see if what type of research they have done or what they have done exactly. So if everything goes well, right, you should have your fuzzer running. And this is an example that you can actually harness all those exports that you see there or the sub functions. If you get a bit more advanced, you can do even more advanced stuff, right? You can redirect the call. For example, some functions are not exported, right? So you cannot directly do the call. But what you can do is some tricky things to to set the hook, for example, and let that when this function gets hit, for example, or redirect the execution to a function during the execution. But that's a bit too much for this part of the fuzzing. But we regularly do that kind of stuff, making sure that we redirect into an internal function by first executing, intercepting and stopping the application quickly, and then redirecting it to a function which is internally. That helps to execute those internal functions as well, if there is no export. You can do pretty crazy stuff, right? It's all development things. So if you can develop and you will be able to write better harnesses. Yeah, so fortunately we have American fuzzy lobs and libfuzzer, but in the past you would have to do a lot of things self, like creating something that is creating mutations and then opening another application, then fuzz it, make sure that you have something that registers the crashes, and then try to automate as much as you can so that every single time it crashes, that it registers open. For example, we used to do that on Windows, and that you have the Windows in Windows the bang exploitable running against the crash that happens. So you can see if it's exploitable, yes or no. But that's for Windows, right? We have a lot of things to cover, so I suggest we start now because this is still later. Any questions for this lab, or you would like to have a bit more time to finish this lab? I would like to communicate with you guys to make sure that everyone can do the labs and we are not skipping anyone.
So if you find any bug later, please let me know, okay? It would be very cool to see that anyone have found something. It will take some time. I suggest you go and look at some games, online games, because they just from, for example, those famous games, not one of those easy games. For example, from EA or something, those will have a lot of code in there that you can look for, right? Hi, Matt. Welcome back. What happened? Did you lose connectivity or something? Or all right, guys. Let's continue with the next lab. If you have any questions later on, you can just contact me, or we can have a chat later about this after the training. Let's now continue with today, because today is going to be a quite busy day, I can tell you guys. Make sure that your machine is up and running. I saw that one person had a problem. I forget who it was. I think Ashley, right? Does it work for you now? Oh no, sorry, that was about the downloading.
Yes, I'm all good now.
Okay, cool. Then we can continue. Lowering the hands. Okay. Let's close this down. I sent the slides, by the way, to you guys at if you want me to send it also in the, I think I send it also in the Zoom call, right? In the Zoom chat. No, I haven't. So let me send it to you guys there as well. The file. So that you have it. Some of you have Zoom open, another one. Okay, for today, since we know how to look for vulnerabilities, today we will focus on the Android userland exploitation, and we will first look at how the lab setup looks like and the tools that you will use for that, because without having the required knowledge about the tool sets that we are going to use, it will be very difficult to execute the rest of the lab. So we will do an introduction in those labs. You can play around with them. We'll give you some labs for that actually, and then you can actually do some of yourself in there as well. We'll discuss the memory leaks and then move over exploiting 3 different type of exploitations. And later we will do an introduction into Android userland heap attacks. That will be an introduction, mostly theoretical stuff. Let's move on to the next one. What we will discuss today is the in the toolset introduction into GDB basics. You will learn why we do remote debugging and how you do that. We did it already a little bit, so you will get the chance to open it yourself and do it yourself again, just to get an answer, because we didn't explain why you were doing that. Now, there is also this green arrow that you saw within the debugger. Some of you have noticed it, right? We said it turned green in the lab verification manual. And that's the GEF tool, which is our exploitation toolkit that we will use within our debugger. Then we will use dumping memory to create manual ROP chains to actually show you guys that it is also possible to dump all those gadgets yourself and then go and search through them. You don't need GEF or Roper for that. And then we'll show that how Roper works, and you will use that later. So first of all, there are 2 ways to do debugging: is the local debugging and a remote debugging, right? Locally, you do that on a binary that is running on your laptop, for example, and remotely you will do it on a device or an embedded device, or most of the time, or sometimes you will do it against another machine to do kernel debugging. And so for those type of stuff, we use remote debugging. And yeah, so you're debugging not the system, and we use GDB server for that. We're going to look at that in more detail. So there are a few commands. We cannot go over every command of GDB, right? But there are a few that are important for us during this class. For example, break. With break, you will be able to set a breakpoint at a certain position. You saw those assembly code, right? And we also saw that our debugger hit some, for example, PC was pointing to a piece of code that was going to be executed. We can force actually the debugger to set breakpoints at certain locations, certain addresses. When those get hit, if the execution hits there, the debugger will stop and pause the application and give the debugger access to us, so we can analyze, we can see the registers, etc. And that is essential, especially when you're building exploits. Your ninja skills in the GDB are very important. And we can use, after setting a break, continue to continue the process, right? So whenever it hits you're done with your analysis, you type in continue or C. We'll look at that in a minute. Also, one important command that we regularly use is backtrace to see how did we get here. The backtrace will show the functions that get called and how did we end in this current situation, which functions get called. You can print, right? You will look at how to print, for example, an address or the value that is in that address. With the X, we can examine, and you can use multiple different formats for examining a piece of memory. We use here the register to examine 100 bytes in hex from SP. So with that, we go to the examine. There's info shared, info symbols, which will show us some information about a symbol, or give us the symbol back if we provide an address to it, for example. You are gonna do the labs for that, and you can do it yourself. Later, we will look at how you can get info about functions and use VMMap. So how do we do how do we do remote debugging? It's quite simple. You open a connection to your device, you get into root shell, right? And then we can run this GDB server first. You can see I'm starting up the application using am_start_com.example. These commands are quite explicit, right? You can do a lot of stuff in 1 or 2 lines. I added in the slides a bit explicit so that you see what is happening. First, we start the application. You will see that the application got started. Second, we do a PS, process list, do a grep on the output and search for our, as we did also with the package name, right? But now we are searching for the package name that is in the process list. That will give us the process ID, which is over here. And with that, we can ask GDB to connect, to open a port, listen on a port, which is 5045, and use attach, give the PID to it, and that will attach the debugger to the running process. You can attach the debugger to almost everything, right? If you are root, you will be attached to debugger even to the Bluetooth or any other part of this system, no problem, unless it's the kernel. That should also be possible if you do enable. But anyways, that's not about that part. But you can do remote debugging like this. In your cases, guys, you can see I'm going in the examples to CD data local TMP and then execute the GDB server, which is there. But you can also use GDB server anywhere because it's on the device. Therefore, you don't need this // but if you follow the examples, everything should work perfect. Now we open the port here on the device, right? We need to make sure that we can reach it through ADB. And how do we do that? We forward the port first. We say ADB forward TCP 5045, and that will open the port locally on our loopback on the port 5045, but redirected to the device, right? And since the debugger is running there, that will attach the debugger. In the debugger, we set the sysroot. I explained the sysroot already a little bit. The sysroot contains all the files that are needed when this debugger loads, right?
If you do not set the sysroot, I'll show you guys. Then you can see how painful that part is. If you do not set it, what ADB will do, it will start up. Let's see if it is running. No. AM start. Content example. My native dot activity. So I'll start the application. Okay, that one is running. Now we can say ADB shell AM. I'm doing now the shorter version, just to quickly show you guys. ID. Let's see. This way. CDB server 5045 PID of open example.
I think you need the attach in it.
Ah, yes, sorry. Thank you very much. By the way, I'm fresh up today, so no worries. I hope no hanging and making that mistake yesterday in the end. Com.exam open my native like this. You know what? Let me just go quickly here and show. CDB server 5045. Oh yeah, sorry, I have to get the process ID. Get the process ID. GDB server.
GDB servers in data local temp, not.
Yeah, but that's a indeed then, but that's what I actually said. It is also in your environment variable, so you can just use it anywhere without the dot slash. So if you don't have to go per se to that directly. So if you don't go to the directory, you can use it like this. Just GDB server anywhere from the file system. Make sure you're root though, that's important. So we do GDB server and then attach. Here we can use the PID of com. Now we got the patch. Now we can show the painful part. So, oh yeah, the ADB forward, right? Do not forget that. Look, if you do not run the ADB forward, you can do get remote whatever you want, but there's, of course, it won't attach to it, right? There is no port open. So what we do is ADB forward, TCP 5045, TCP 5045, that will forward the port, right? And now you can see what is happening. You see it's starting to pull all those files from the device to make sure that it knows where to set the debugging points, etc. Right? Because it's going to parse it and load it into the memory into our local machine. If you do it locally, of course, there's no need for that because it knows where to search for those files. But remotely, it will start pulling all those files from the machine, from your remote machine, and this will take quite some time to load. Now it's quite fast, I see, but normally this will take some time. If you do this right now on, yeah, we did this actually on Chrome, so it took a bit of time. So that's why we are doing this locally. But look, now it loaded like that, right? So your debugger is attached. If you have to do this constantly, then we will do it constantly, and you will see that it will be very irritating to do that. So therefore, we created this root file system on the desktop
which has already all those files in there, you see, containing all the files that if needed, especially the lib folder, right, that contains all those libs. And we also added the data/app in there because this will be pulled as well from the device. Now we created that already. If you now attach your debugger in a proper way with the sysroot, you won't have that issue anymore. See where are the slides? So to come back to the story, this is why we set the sysroot to make it faster, right? And then you will see it will load very quickly without any issue. You will see some warnings, but those warnings are not important. You will see in a minute also in my slides. So when you run this, I first want to ask you guys to do this part. Make sure that you can attach your debugger. First of all, make sure that your application is running. You can do that with am-start and giving the package name to it. I'll send it in the chat for you guys, and I will also send you the lab part to you. This is the maps. This is the map. And you can do ADB. So before you do the exercise, make sure that your application is running, and you can do that with this. Also in the slides, it shows it as well. If you follow the slides, execute these commands, and the next one here, and you get this message in front of you, that means your debugger is attached, and this is what we need. So please do this, and when you're done, raise your hand again. I'm going to give you guys time to attach your debugger. In the meantime, if you have any issues, just raise. Yes, of course. I see one guy is ready. Andy, good. More. I guess debuggers are not a secret for most. But guys, take your time to do it. I'm going to set a timer. We're going to do this as 5 minutes, so that we do not lose too much time for the next labs. We have a lot of things to cover. So if I'm correct, you should be greeted with this message. I will start it up again for myself because so when I set the sysroot, I use tab, right? Because it's easy. So you don't have to type the whole thing. Just do tab home, fuzzing, GDB or desktop, GDB 7, and then we can do gef remote 5045. Now it won't take that long to load, and it is loaded right now. I'll give the guys the chance to also come to this view, so that everyone can follow with the rest of it. And actually, in 4 minutes, we have a break. So I suggest the ones that are ready to go already for a break. And we have a break schedule the same as yesterday. I will send it in the chat to you guys so that you get it. And we have 2 times listed next to each other because we are in another time zone, in the Dutch time zone. We are in the Netherlands at the moment. Oh, I see. I missed something. Yeah, the ARM emulator has been rough for me too. It's working now. I'm afraid to touch it. Okay, let me see what's saying. Challenge with these labs is use of ARM emulator. Mine is broken all day, sadly, trying to repair though. Could you please repeat these steps? Which steps, Ismail, did you? Because sorry, I didn't see those chats. I see now. My emulator is working now, crossing my fingers. Yes, I'm crossing them too for you. The last one, you mean here that I'm executing or doing the fuzzing labs? Because I got some questions about fuzzing. Oh, sorry, this one was sent to the fuzzing, yes, sure. The last command that I execute, but you can use the readme file. Readme over here, that gives the whole command, but you just need to search for it. Inst. This is the commands. Yes, it is. I think Mac. Oh, you know, it depends. We did this course with internally with multiple people, and a lot of Windows machines, also Linux machines. There was no. We did not have much issues. Also, with the classes that we had in those last couple of days. Emulator is slow booting. Yes, true. It is slow. I know, but you know, if we would have taught you how to do exploiting these mobile phones on x86, you know, if you spin up an x86 emulator, it will be extremely fast, right? But the problem is it won't be realistic, and the problem is, you know, you won't touching any ARM to host machine. Yeah, so what I recommend is actually, to be honest, I don't have a choice, but if I would choose right now, again, because I have two MacBooks over here, I would not go for the MacBook, to be honest. I would go for a nice Linux setup. And yeah, if you do this stuff in your own time, right, I suggest you get a phone that you can root and start doing this stuff on a phone. You know, if we ever going to be doing this stuff live, then we will definitely do it with mobile phones. And we will come with rooted mobile phones that you can use during the course. Or if Corellium allows to do a bit faster debugging, then we can do it over Corellium. I know some of my colleagues work with Corellium for iOS, and there it works pretty fine. So Corellium should be fine for your research. Yeah, GDB server is located on the VM itself. There is one on the /data. You can use just GDB server everywhere, so it doesn't matter. So if you run GDB server, that was the timer for the lab. Yeah, look, Kellen, I'm just using GDB server anywhere, doesn't matter, because it's in my path environment for it. It's a bit confusing, you know, because in the labs we asked to push it onto the device, etc. But there's a reason. We wanted to make sure that people can actually push and etc. So if there was any issue, we would have been figuring that out before the lab started. Okay, it's a break time. Let's take a break and come back because we're going to dive into a lot of stuff. Let's come back in 15 minutes. All right, guys, see you in 15 minutes. Thank you very much. See you.
Okay, guys, I hope you're back. I see a few hands raised. I'm going to lower them and ask everyone again to raise if they are back. Are you guys back? Please raise your hand if you're back. Okay, most people are back. Let's wait a little bit more. Guys, if you hear something with my dog here that is making some noise, he's enjoying his free time here. Okay, I'm going to share my screen and show you guys. Let's continue with what we are doing. So we just did attach our debugger to it, and if I'm correct, your debugger is still attached, so leave it attached. Do not touch it. We're going to continue with that. So how does it look when you what do you see when GEF is running? First of all, on top, you will see the registers. As you remember, we discussed them earlier. Now you can analyze them. You can see those bits, the CSRP bits that are set on or off. You can see here the 0 and the carry flag are on, and this is not running in temp mode at the moment. Now, we also discussed the LR and the PC register. You can see them. You can see PC is pointing to an address, and we can see that is also the current next to be executed instruction line. You can see that by seeing this arrow. The arrow will point to that, and the address is pointing to PC. LR points to when this returns. You can see BXLS into LR or branch to another address that will eventually come back to ePOL wait when it is done. We learned that yesterday. Another thing is what we learned previously is the stack, right? The piece of memory that was important. And as you can see here, this is the stack and the data that is on the stack. This is the address of the stack. Where the address of the stack itself, you can see SP, which is pointing to that address, and SP is always pointing to the top. You can see here. The breakpoints we just discussed, if you hit your breakpoint, the application will stop and show you this screen, and you will see your breakpoint being hit using this arrow. If you have any questions about this, please feel free to open your microphone or chat. Use the chat or just ask me questions if you have any questions. Yeah, anyone? I heard the microphone.
How do we see that again?
This one, right? The screen.
Yes.
Yeah, you're gonna see them in a minute. So they are not. We will come there, but I'm just explaining what you are going to see in a minute, so that you know what are those things that you are seeing on your screen. You can also see the list of threads, because this is a multi-threaded application. So there are multiple threads running. And within those threads, you can see there's one thread that is called our thread. And in there, our overflows or that kind of stuff will happen here. You'll see that in a minute. And here we see a trace. This is also the same as backtrace. So that you know, if you see trace, you will see. If you hit your breakpoint, you will see this is your breakpoint, but you will also see how did the application come to this point. And that's very useful in most cases for us. For some of you, this stuff might be not new, right? But I'm pretty sure during the exploitation, you will be having fun. So we discussed about break. How do you set a breakpoint? You can use break against an address, right? Or you can set it against a symbol, for example, to a function by using the symbol name for it. If you do not have the symbols, you will have to set it against the address. You will set breakpoint star and then the address. When you're done with setting your breakpoint, the application is still pausing, right? So it's not continuing. Whatever you do, the application is hanging, right? It looks like it's hanging. We can see that over here. Oh, we can see that. if you try to do anything on the set, now it is, it's not really, nah, of course, no, but it's not attached for me, but when I attach the debugger to it, you'll see nothing will work in the app. So it looks like the app doesn't work, but when the debugger is attached, when the debugger hits a breakpoint, you can also press C to continue, and that will continue the application. It says it doesn't respond. Oh, now I closed it. Actually, that was stupid to do. But anyways, you can continue the process. You don't have to touch the user interface. And these are the screens that we just discussed, but you will do that in a minute, so don't worry. And like I said, you can type backtrace, and that will automatically show you how you came to this part. I'm going to show it in the screen in a minute. And we have the print function, so you can print. You can use print against the symbol, and that will give you, or the function, and it will give you the address of that function. And that's very useful for us because we will need some addresses of the functions to do calculation when we do ASLR bypass. Also, the examine command that we can use, we can say examine 100 bytes, hexadecimal string, or an instruction, for example. Now, you can use it against a register, or you can use it against an address. So you can see that here we are printing, examining 30 instructions on a certain address. You can see it will start printing all those instructions from that place. You can do examine 10 bytes, for example, against the address, and it will start printing the addresses or the values that are on that on SP. Now, there are also other useful commands that we all will use in the next coming hours. For example, info shared library, that will show information about the shared libraries that are loaded in this application, and we can see we can see the list of the shared libraries that are loaded and that are used within this package or application that is running. When you do info symbols, and this will be useful for us, sometimes when you leak an address, you want to know where, in which part that belongs, right? So you can use info symbols, and that will give you the library in where that is being used. And with info functions, you can get list of functions or information about the function, but you can use the star again to get a list of functions, for example. Do not use info functions without anything giving here, because that will spit a lot of data and will take some time to stop it. One which is very important for us, and we will use that in our next exercises a lot, is VMMap. Because if you run VMMap without anything, that will again give you the sort of view that you saw with info shared library. But in here, we see also the permissions of those pages, right? And that's very important for us because we want to know which part are executable and which one is read-writable, so that we don't get any issue if we write anywhere some data. And for example, if we change the permission somewhere, to check if it is executable, yes or no. Now I have some exercises for you. One second, I'm going to send it to you. Yep, it's here. I'm going to show it first in the screen, so just wait before you execute. If you are, you can also execute along the way with me. That's also good. It's also fine. From slide 10 to slide 11 will be the exercise. Let's do this. Let me follow also with you guys. So make sure, if I'm correct, your debugger is already attached. In my case, I closed it, right? So I will start up a new application. I will start up my application again. For you guys, it's already started. If I'm correct, you have the debugger already attached and you should be able to execute those commands that you see in your slides. So go ahead if you already would like to execute them. I'm going to do it now on the screen to show it. So I'll quit this session. So you guys have a fresh session already running. So you can put a break, right, on a command, you can use tab again, right? Tab is your friend in these cases. So you type in Java underscore and then tab, double time tab. And if you type com, you will get this. If you double tap it, you will see all those functions. I'll put it on leak memory right now. And it set a breakpoint for me. You can also do info breakpoints to see where the breakpoints are. You can set multiple ones. You can also delete those by giving the number to it. If I delete it, it will be deleting the breakpoint for me. You now do info breakpoints. You see there are no breakpoints. Now I'll put a break as in the slides and press continue. Okay. Now the application is continuing. I'm just showing examples that now you could connect again to the application. That's not in your slides. The idea is that you just learn how to continue. And so if the application continues and you want to, again, access it without putting a breakpoint, you can press Ctrl+C, and that should bring you back, pause the application and put a software breakpoint itself. And you should see this screen. So after putting the breakpoint and pressing continue that you see on slide 7 or slide 10, sorry, we have that a command break and continue. When the application continues and you want to come back to your debugging, you press Ctrl+C and you will see this view. We discussed about those parts, right, just minutes ago, all these registers. No worries, we're going to do exercises where you will modify those stuff, etc. But for now, it's important that everyone knows when we say, hey, continue the process, that you know you need to press C to continue the process. If I ask, do a backtrace, that everyone knows that what we are talking about. I'll execute backtrace as well. And as you see, this is the same output that you see here, but with a little bit more detail when you do backtrace. Let's see which libraries they are part of. Slide 11, we have the examine /100, and you can play around with it yourself by saying X, print that on SP, the register SP, you'll see it print the value of SP. If you say, you know what, I want to print the strings that are over there, it should print the printable characters actually for you. You can also use this against an address. If you have an address, for example, here, let's take this address, and you use the star for that, for being a pointer. And when you do that, it will start printing from that address 100 bytes of strings. We also saw instruction. For that, you need to point it to a part that is executable. But info registers can be used to show the registers manually. You can also do the shortcut for it by typing IR. And for everything, there is a shortcut. For example, for break, you can use B and then do your breakpoint. You can also do it in this way, break. D, for example, for delete. And that will delete the breakpoints. So please try it. And then the info shared library will show you all the libraries. Symbol can be used against an address, which we will do later in another exercise. But one thing which is very important, and that is VM-map. And VM-map will show the mapping into the map in memory. It will show you which parts are executable and which are not.
And this is very important for us, especially if we are going to change the permissions of some pages during our exploitation. Connected to the process, but no capability to debug. Okay. Does anyone has trouble with tab completion? When I try to make breakpoint, I get no symbol table is loaded. Did you guys run the update script that we sent to you earlier in the lab verification manual? Because if you haven't done that, today nothing will work properly. So the steps that we will show, you will have to modify some of the values that are in that. That's why we ask everyone to run that, because that will make sure that we have all the same. And that is because, look, we need to verify this, because or else for some that have not correctly. So you should be able to do this, right? I'm going to send it in the. So run that one, and then that will show you this, and you should see symbols, and especially this one. If you see this one, then we are all correct in the same application. Does that work for you guys? Oh, okay. Type it in. I'll also send it into the batch 2 channel, so that you maybe can copy it. But yeah, like I said, if you cannot do the tab, then there's clearly something wrong. Then the new application, this doesn't contain the symbols. This has Java. If you do Java_com tab, you should get this. No, you don't have the same addresses because ASLR is running. But it should get this symbol for you. No symbol table is loading. Yeah, you need to, Praveen, can you maybe help Andy to verify that the new app is running?
Sure.
So that we make sure that anyone else having this issue?
May I know who all have that issue? Actually?
Andy has the issue because it doesn't load the symbols, and that is typically because the new app is not installed in there. Yeah, this is important. We need to make sure that everyone can do the disas command that I sent you. Look, you can already see if you have the symbols, right? By typing Java_com and pressing tab, which will give you directly this thing. And when you do disas on the leak memory, and that was also part of the verification that we sent. So then you should see this line with SNPrintf in there. The symbols. If you cannot even do this command, then there is something wrong. Oh, what should we do to update? Let me send a line to you guys, which is in here. If you run this, it will reinstall the correct app as well. I'm sending it to both, and it should be in the lab verification manual as well. And this will take a little bit of time to run. So you just have to wait, and when it's done, it will automatically attach the debugger to the process. But also, I don't know if some of you are in a network where you don't have internet, but make sure that you have connection, that you can, for example, ping Google and get a response back, because if that doesn't work, then the updating won't work as well. And there is a reason. I explained it in the beginning as well. The problem is that we noticed that if you build it yourself on your machine and press the play button, yeah, then we'll wait a little bit until everyone has this, or else we cannot continue. You will be able to continue. You can even
use a device to do it if you have a device. But the problem is, you know, during exploitation, the versions that you run on your phone, etc., will change the offsets that we will use during calculation of ASLR, etc. And that's typically the normal case when you build an exploit. It has to be for a version of the phone because libraries have more data in it, etc. And that will change the locations in the memory, right? And for us, it's important to know that we are all on the same version. I'm going to lower the hands and then see. So. Then in the meantime, guys, the other ones, please finish the labs that we have. And no worries, we're gonna use those commands later a lot. So no worries that you have not touched them right now, all of them, because no worries, you're gonna be using the debugger the whole day today. So no worries. Take a couple of more minutes, like 4 minutes. I think then by that time, the installation should be quite far. If I'm correct, also, if you have the correct app installed, it will look like this. The other one looks very weird with this weird button over here, etc. The correct app looks like this. And on so if you see this later running, then you have definitely the correct one running. Can the guys who can do this and were successfully able to this last comment raise their hands? Anyone else who was successful? That's weird, Andy, because if the new app is installed, you have the symbols in there, and it should be possible to do this. Praveen, can you give support to Andy for that? Because
I'm looking on the remote.
okay. What is the issue? It doesn't show the symbols. It gives the same error. And
no symbol is loaded actually.
But can you verify that the update script has run successfully?
Yes, I'm checking on that. I'm checking the output on.
Okay, in the meantime, we will continue it. I'm pretty sure, but still I get no executable file now. On what? On what are you getting no executable file? So if you can run the update script, Andy, and show a screenshot to Praveen how the output looks, then we will be able to debug and find out what's going wrong with the update script. Because okay, cool. Then you know what? Let's focus on the slides for now, because we will have more time to go into it. And if in the worst case, we will in the break help you to resolve that for sure. Because this is just a simple program. You just need to have the correct binary that we all have running. So within the, I'm going to continue the slides for now. We can do this lab for sure. You don't need that. For this one, we need the debugger. Sorry, for the next one, we don't. So what we can do within
GDB, you can also dump ROP gadgets. And what are ROP gadgets? ROP gadgets are actually little pieces of code that we can reuse later. Little pieces of code everywhere within the binary that we will search for. And those things are called gadgets that we will use to bypass some of the mitigations, and specifically the not writable or the non-executable stack to make the stack executable or disable protections, etc. Also to do other stuff, right? Because we will use the gadgets in our ROP chains. And I will explain what the ROP chains are. We are using them to create to chain multiple little pieces of executable memory with each other. And that will achieve a certain result, because we will manipulate the application to do that for us, and that will disable the protection of the application. But first of all, to be able to do that, you need to know how to dump those instructions that you can search for. You can do that in GDB by setting logging on, using this command, set logging on gdb.txt, and use info shared library. First you use info shared library, and then, set logging on gdb.txt, then use info shared library to look for libc, get the address of libc, and start using the examine command that we had. Examine 30,000 instructions and pass the address of libc to it. For you guys, the address of libc will be different than mine, right? Because there's ASLR running and everyone will have different addresses. So therefore, after executing set logging on gdb.txt, you can use info shared library to get the address of libc that you see here, which you will use in here in this placeholder that will spit a lot of data on the screen. Now, what that does, it prints out every instruction, right? We discussed that earlier, but why is that useful? Because that will create a text file for us containing all the instructions from in that binary. Now, what we can do after that is do a grab on it and grab for pop instructions, and we will see a list of pop instructions ourselves. And this is useful because now you can do this manually without using Wropper, for example. And this is a technique I think it can be useful, so therefore we added it in here as well to get an understanding that you can dump those stuff yourself as well. Now I have labs for it, so you can do this yourself. I hope in the meantime Andy was able also to get it up and running. I'll send you guys this labs, and this is the lab for the slide numbers for the labs. And here we have the dumping ROP from 13 to 16. So I can do it again on the screen. We can also do it in GAF, by the way, to dump the, because there's a wrapper. Hey, this is not okay. We didn't have any. I see that more people have issue as Andy has with no seeing the symbol. But can you guys do something for me? Are you able to do VM map, for example, within? Is your debugger attached to the running process, and are you able to do VM map?
Most of the people have this issue with run the update script. You have to check this is root.
What? Sorry?
Everyone has that issue. Most of the people have that issue actually. So after running the update script.
After running the update script.
Yeah.
Okay, that's weird because we tested it out also in the other classes. We run it all together. Let's do something because look, guys, I'm going to show it again. We have the same configuration. There's nothing different. I had to run the last line again and pull the folder off the phone. It seems to work for me. Yes, that's the manual way to do it. To pull
the last few
That's,
lines.
yeah, that's exactly what I did. I opened the script and just reran the last few lines by hand, deleted the folder with the symbols and then ADB pull. And I seem to be able to tab complete and follow along.
Just you mean that from the update script you did this?
Yeah. I opened the update script and just looked at the last couple things that it runs. And then I just did those like one by one, pasting them in the terminal, and it seems to work for me. I have symbols.
Okay, cool. So in this folder, right, you should have that APK file then, because it will pull it in. Let's do it all together before we cannot, or else we will not be able to follow the labs. I would find it very sad if we cannot do that. Won't be nice. So I will execute it myself again and run it. I will kill my debugging session just to be sure. So this is the update script. Let's run it. Take a bit of time. And that's why in the beginning of the course, right, I'm pretty sure you guys run it, and but there has been something going wrong. I'm getting this success, right? I'm performing an install, and that should indicate that the new app is installing. And the last few lines you said, right? So more update.sh. Which one?
So the RMRF, like home desktop. Yeah, so starting there, I ran that one by one, every line after
Yeah,
this.
you know what? I'm going to send it also to everyone as you did, the same way you did it, so that so guys, if you have run the, we will do the same step as Lindsay did. So go to your temp folder by doing cd tmp just to try to solve it. I'm sending it into the batch thing, to the batch channel. Run this command after it. I'm going to do it on the screen. Then do it manually. It should not differ actually, because it will be executing the same way, right?
I was also the one who was having weird issues installing the app in the first place, though. So, yeah, I'm not exactly a clean test case here.
But it works now, right, for you? So that's actually
It does. I had to run that script a few times and then run the last few bits, so it seems to work, but
well, to be honest, guys, we didn't have any issue the last time with putting this in. We did it in the beginning, right? And we did not have an issue, or maybe people had issues and did not tell about it. You know, that is possible. That is, of course, possible. No. No. And then finally run the last commands. Pasting them in so you can just copy them in and execute it. Or you can open the file yourself and then copy it in and execute. But I'm going to show you guys how it looks for me when I have executed it. Look, it says this might be also a problem with some of you then. What happens here? Or it crashed or something.
Omit, I can install the app on the emulated device and clear the system root from the VM and then make the directory again. But when I try to do ADB pull from the emulated device to get the sysroot back onto the VM, it says that that location doesn't exist.
Yes, because first you need to do ADB uninstall, remove the old one. As you can do ADB uninstall com.example, type it in there, and then install that package. Because that's why we do in the script an uninstall. If you don't do that, it will create a second folder with -2, and it makes it difficult to make sure that everyone has the correct, the same directory in their devices. Because if you reinstall it, for example, look, one thing I quickly want to say, I run the script again after it failed, right? Now I'm pretty sure it is being able. Oh.
Okay, yeah, uninstalling the app and then reinstalling allows me
That
to
worked, right?
Yeah.
Because it will, and that is exactly what the script also does. It uninstalls it, installs it back. Because if you install it 2 times, it will create in the, I will show it actually, but it will create in the /app /data/app folder the same package name, but then with a -2 folder. Because you reinstall the new version of the app and it creates another directory, and to be able to make sure that everyone has the same configuration, with the script uninstalls and installs it back. Praveen, can you give me also an update if things are running?
I'm checking, Umut.
But for me, I set the sysroot now, and I'm running the same script.
It works from my side.
So I'm also doing here, and if I do now this as Java com and do tab, I'm getting this. Can you maybe verify, maybe with someone who has a problem, if in your temp folder this app I've got mine to work. How did you get it working, Matt? How did you get it working? Yes, I killed the app. So you killed it first and then run the restart the app. It was still running. And you are okay. Cool. So that means kill everything first before you run the script. Didn't set, yeah, look, if you do not set the sysroot, you won't have this issue. But so if you want to continue without setting everything, then you can do that indeed without setting. Yeah, you just have to wait. But the problem is we're going to kill the application many times and reattach the debugger. Like, I think at least 50 times you will, that's a bit too exaggerated, but you will kill it many times and restart it. Especially when the debugging stuff do not go well, you need to restart the app and start sending your payload again. And it's constantly debugging, etc. And that will take you some time if for every restarting the app, you need to reload it. How do we update them? Yeah, first, so if you run the update script, you should have this new app debug.apk on your temp folder. First, you can do, but the script is doing all of this stuff. So I wonder what is going on here. Because we can do it manually, that's no problem, but this is the computer who is doing exactly what we are doing. So uninstall com.example.mynative test. So we first uninstall the app manually. That takes some time, and then we can use it
Removed it. Now I will install the new one. After running the script, you will have in your temp folder a new app called app-debug.apk. Then you can run adb install app debug.apk. That will install the app. Reinstall.
-RT.
Yeah, so -R. Yeah, you need to do ADB forward on the other in the other terminal, Andy. So you go into another terminal, you do ADB forward TCP 5045 TCP 5045, and that should forward the port, and then you can do gaf remote in the debugger again. Now the install has been complete for me. Now I can start the app manually. AM start or ADB shell AM start com.example then my native test /dot. Awesome, but can I ask you, Andy, are you setting the sysroot or not? Oh, you set it. Oh, cool. Oh, you did it manually now, all the stuff. Okay, so I will start it up here. Yes. Yes, indeed. You can use it that way. And now it started up for me. I can go back to my application, right? Or ADB shell. AM start com, or it started already. GDB server 5045 attach. And I'm just going to do it quickly to show that it, like this. Oh, it's already attached somewhere. This got killed. No, attached to it. And if you now go to your GDB, then this should happen. You should see no error over here. If you see here, like for example, saying symbols cannot, for this one is not a problem, but if there are other ones, then it will cause an issue. So now I can actually do this. So I did the steps manually that you saw there as well. And you should be able to do this. If not, we have a little issue, because then you will not be able to follow the labs properly. I just need to check. Who has still issue? Can you raise your hand? I'm going to wait 1 second. I'm going to lower the hands first. Who has an issue right now still? Satya, you still have an issue? What is Ashley also? Oh, quite some people have issue. And what is the issue? Can you open your microphone and tell me what the issue is? What do you?
Yes, I was having the same issue as Andy was, and I'm currently trying to go through and manually run it.
Interesting. There is something that is going on, because the update script should run. Is your maybe the app is running, or that is causing a problem, or because I haven't seen this.
Or still GDB is attached to the old.
Yeah, make sure you quit everything, right? You the debugging, the debugger, etc. before you start running the update script, and run the update script 2 times if necessary. But
So after running the update script, it does open a GDB session, right?
yes,
So should we close that?
no, you
Or
don't
should-
have to close it. You can keep that on and then open, because it does it auto. If look in the verification script that we sent you guys, the lab verification manual, we did on purpose set the debugging there for you. Look, I'm going to run it again just to show the example how it looks like, yeah, so that we all are on the same level. Let's see. So.
Yeah, I was able to do the like run the script and get a GDB
Yeah.
session up during the lab verification, but for some reason now it's just not working.
It's interesting. Look, I have it now also. I killed everything, right? It's not running. So let's see if this part is successful for me, no problem. Make sure you kill everything before we can. But yeah, if that worked, why didn't we see the symbol? That's the interesting part, because the symbols, what we are checking in the lab verification manual is that you get the correct one there. That is a bit surprising me. There is obviously something going wrong, but that's why I'm checking what is going wrong so that we can solve it for everyone. Do Gef remote after it starts the GDB, yes. So if that will happen for me now, look, everything goes smoothly. So if everything is well, now it's ADB is already running, and it did not kill it because it was not running for me. Now you can do here, set sysroot. It already did the sysroot here. Now you can do 5045, and it should do it. And you should now in this, after running the script, run gef remote 5045. That should show you the debugger. Then you can do the tab thing. But remember, you need to type in underscore com and then press tab. So type in underscore and then com and then press tab. That should make the thing fill in. If this doesn't work, then we need to do it without the sysroot. Can you guys verify, Shatia and Ashley, that this works?
So when you say get this remove the sysroot, is it just removing sysroot out of that command?
Yeah, so you don't have to run the sysroot here. When you run the script and the debugger is attached, it already sets the sysroot for you, so you don't have to do that. The only thing you need to do after the script is done and this debugger opens for you, type in gef remote 5045. But make sure that you have, like in my examples, and you need to do ADB forward TCP 5045 so that it's this, even this is not needed. Just let's keep it simple. If you run the update script, everything should be ready and you should be able to do gef remote 50, run this command, and everything should turn green and attach the debugger. And when that is done, just first, let me wait until you guys have that part done. What we can do is, look, what we can do is go to the next exercise right now, because that is the wrapper one. And then in the meantime, please run the update script. If it is done, let me know, then we can continue. For Ashley and Satya, if you have it running, or else we're gonna do it without the sysroot, okay? But still, the offsets will not be the same if you do not have the correct app installed.
Any issues?
Will you guys verify me, Ashley and Satya, that after running Gav and you come here, when it is done, right, the script, it will show you this red thing, and then you do Gav remote 5045. You should get this green part.
Yeah, I got that earlier. Now I had closed all the GDB session and I'm just trying to reinstall the app. So I guess it should work this time.
Okay, cool. And for you, Ashley, how is it going? Do you have
Yes,
any-
so I ran the remote command and then I ran the disassemble command, which before I wasn't being able to tab over for the Java COM. I wasn't able to tab over, but this time I was, but I'm still getting a no symbol table loaded,
Where
which
do
is
you see that?
interesting.
Here? Do you see that
No, I'm
here?
still getting the no symbol table loaded. Like when I ran,
I lost you. So when you do this,
yes, sorry.
and you do tab, you will get the no symbol. No, this doesn't fill in the whole thing automatically for you.
It does fill it, but then I'm still getting the no symbol table loaded, which is interesting.
Yeah, interesting indeed. So when you do this and do disas, you will get a disas from it on the leak memory. So you can again use tab. It will tab autofill it for you.
Oh, I
Then-
just had the leak memory omitted, so now it's
Okay.
running. We're good.
Yeah, okay, and also this part, you see this symbol, after you do disas, you will see somewhere a line that says snprintf at
Yes.
plot.
Yes, I see it.
Also, all these little things, all these symbols are shown, right?
Correct.
Okay, awesome, then you're correct, good to go to run. Anyone else have an issue? Because I would feel
Thank
bad.
you.
I'm sorry for the guys that you had to wait for the other ones, but we are in a group, right? Let's make sure that everyone can follow the labs. Satya, is it when you are ready, just let me know. We can verify with you as well. Let me continue with the next lab, right? So that other people can execute the other lab as well. We will do an introduction. We will do this lab over again. The other one, it's also a manual lab, so you won't need it later, but GDB should work properly for everyone. So first of all, what is Ropper? Ropper is a tool that allows us to dump ROP gadgets. We discussed about the ROP gadgets a little bit. We will go into more detail into the ROP gadgets. You will use them, create them, etc. We are dumping so-called gadgets. These are little pieces of executable memory, little pieces of code that tie together called a ROP chain. And what Ropper does, it allows you to assemble and disassemble also parts of the application, but you can also do one inline assembly and disassembly, that kind of stuff it supports as well. It supports many other cool stuff actually, because I had it open here. When we go to, I closed it. I'll give that open in a second for you guys, but let's continue first the slide. Yeah. So we have the supported architectures. It supports many architecture, as you see here. We are interested in ARM, but it can also switch between ARM and dump mode. So it can interpret as ARM or dump the lines of code that he says, and dump you the gadget for those. How do you dump such a gadget? As you remember, the first arguments that we push into, that we need to set when we call a function, we will need to set the first 4 parameters in the registers. Now, in a typical Stack Overflow in the past, when you overwritten the stack, you would have control over the stack and ultimately control over the parameters that you pushed into a function. This is different on ARM and on the new x86-64 machines, right? Because they expect them to be in registers. Therefore, we can use those little pop instructions that will set those values for us, because and then chain them together. Now we will search. You can use Dropper and the -f against a library. In this case, we are running it against libc, because we will need to find. We will use the gadgets that are in libc, since we will leak some address of libc later. But for now, just understand that with Dropper, you can do little pieces of useful code that can be chained together to achieve a certain end result. Okay. We will search for some gadgets that pop into R0, for example, if we want to set R0. You can see here there's a pop R0, and it pops also the PC. So we can pop the value. Since we overwritten the stack later, you will see we can use this gadget. You can use this gadget to create one execution, and then we can combine multiple ones together to achieve the end result. Now, I want to ask you guys to do this. You don't need any GDB for that. And don't worry if you are not able to. I'm pretty sure I will be able to solve the issues for some of you in a couple of minutes if you still have issues. For now, let's go to the slides. Now, look in my slides, you can see desktop GDB root, GDB sys root for ARMv7. There's a system folder called lib. You can go there, and then you can run Dropper -f to libc. That will dump all the gadgets for you. So we'll send the slides to you. It's slide 17 and 18. So lab. This is the lab. If you guys can execute it, I will do it also on the screen. I go to my desktop, the GDB root file system that we have pulled from the system earlier. And in there, we have a system folder, which is also on the device, right? We pulled everything from the device. And there's a lib folder. In that lib folder, I will go into that lib folder and then use Dropper against libc.so. And you will right away note you will be seeing those nice pop instructions and many other ones that are very useful during exploitation, for example. Some instructions will be used for other purposes, but for us right now, the pops are the interesting ones. We will focus on them later. Give it a try, run this command. Make sure that you are able to run this, because we're going to use Dropper in a couple of minutes. And there should be no problem in running Dropper. I'm pretty sure of that. Give it a try. I'll give you guys 5 minutes to do this. It should be easy to execute this. So go to your desktop's GDB sysroot ARMv7 folder. And there you have a system/lib. Execute Dropper. If you want to know more about Dropper, you can do -1 help, of course, and get more instructions. You can also do search. You can do pop R0. But for now, you don't have to do the search thing, so just execute a normal. Oh, sorry, the F is missing. F libc. Now you can also use search to search for specific execution. Just search for pop. Hold on. You'll see all pop instructions. And this is a very handy tool. You will, if you write exploits, this will be useful. Like I said, you can also do it manually, as I've shown earlier on the screen. And again, why do we do this? These little pieces of code, and this is just an introduction into the tool. You're going to use it in real life example, right? But you just have to know that with Dropper, we will dump pieces of code that are useful during exploit development that can be chained together to achieve a certain goal, most of the time to disable protection or execute arbitrary code. But before you can execute arbitrary code on a modern system, especially on this type of mobile devices, you would need to disable some protection. So there are ways that they protect, right? Some applications are compiled with control flow integrity. Control flow integrity is more, it's a new protection, right? And for that, you will need to do jump-oriented programming. So ROP stands for return-oriented programming because every little piece of gadget is returning back into PC or LR. And that means we can chain them together to execute. For example, you can execute this one, then branch with LR into this address that will execute this part, then branch with that one in here, for example, and execute all those. That will set all the values to something that we want, for example. For the ones who are very interested in exploiting and do bypassing very new, like literally all the new stuff, like control flow integrity, this is the new book that you're looking for. I'll send the link in the Zoom chat. The continuous arm race, it contains multiple papers published by Ahmad Reza. And we had, in the last session, we had someone that worked together with him. It's pretty cool because he recognized some of the papers as well. Pretty cool book. I'll send the link in the chat. So you guys able to dump the gadgets? Yes, it worked for me. Awesome. Let's go to the documentation of Ropper. When you go there, you have very nice documentation. But for us, yeah, we will use those dumping of the gadgets. So that's the most important one. But there is also another one, for example, shellcode that will create shellcode for you. Within GAF, actually. Sorry, we'll do that later when needed. Yeah. So sorry, I jumped into another thing. Meantime, sorry. Okay, cool. Then let's continue because we have a lot of stuff to cover. Andy, does it work for you now? Everything? Do you see the symbols? Awesome. Yes. Without the sysroot, right? For Matt, for everyone works. Is there still anyone having an issue? I did set the sysroot. Okay, cool. Awesome. We can all do that tab, right? We can see it, but make sure you type in Java with a capital J and then underscore com and then press the tab. You should see it filling up automatically. Anyways, that's not that important right now. If you guys are able to do that, let me also give you the chance to do the previous lab. I'll send again. Tabbing is available and sprintf were there. Perfect. That's the perfect thing that we need. So you can follow the labs as we will be able to do it. So we had this previous lab, right? Please execute that for the guys who haven't done it. So that was dumping ROP gadgets manually. I can show it because I didn't do that one. Show it on the screen. I have the debugger attached over here. You see, right? And I showed that you can do info in the slides, info, shared libraries. There is this libc, and we want to dump the gadgets that are in libc as Ropper is doing, but we will do it now ourselves. Set logging on, and then you can choose whatever file you want, right? I will tell gdb.txt. I'm probably in the wrong folder while debugging. Set logging on tmp/txt. Okay, now it is writing it out to gdb.txt. And as we said, you do x/I and then 30,000 or less or more, but I would do more, right? 30,000 of them and give the address, the start address of libc. When you do that, it will spit a lot of instructions because it will go over them and will start spitting them on the screen. Just give it a moment. And now I press Ctrl+Shift+T to open a new tab. It will bring me to the root folder. That's why we could not get the, that's why we got the permission denied, right? Now in the temp folder, there should be GDB file. If you do more on GDB and do a grep on it, you can use grep to find those instructions yourself manually. So that is the lab for that part. Give it a quick try because a lot of people have done it already. In the meantime, I'm gonna continue with the slides if you guys are okay with that. Because in the rest of the class, you will use Robot, you won't do it manually. So what did we learn? We learned about Geth. We solved some issues altogether. I'm very happy that we are all on the same point. But we did also run Geth. We run Ropper. We are able to dump gadgets. We know now what gadgets are. These are little pieces of code that we will reuse to bypass mitigations, exploit mitigations. Any questions till now about the stuff that we discussed? You would like to know more about something, also about the ROP, maybe. It's no problem. Ask me anything. If not, we're going to continue with the next part. So first,
Sorry, Amit,
yeah?
sorry.
Yeah.
Where does the gdb.txt file live when you copy the logging to that from the GDB?
In the current folder that you are in.
Okay.
So in my case, I typed in explicitly where to write it. But if you don't do it like this, it will write it into the folder that you started GDB in.
Okay.
So if, yeah, that's it. So you can explicitly give it to it. And it will do it. But in my case, it gave me permission denied, right? Because I started up in the root file system, and you cannot write that. Now it gives that I'm already working. I'm getting permission denied because I'm in the root file system. You can see, and in the root file system, you're not allowed to write, right? As a normal user, as root you can. Yeah, so ROP is to bypass ASLR. No, ROP is to bypass the data execution prevention, what they call in Windows, right? In Windows, they call it data execution prevention. And on Unix type of system, we call that the W-NOT or write not executable protection. Or not bypassing the non-executable stack or non-executable pages. Because every place that you overwrite, that you are able to overwrite, is also not executable. That's what I showed. But you will see also, I'm going to explain more in detail. Every page will either be, look, if we do VM map, right, we see the mapping of the memory, and we can see the protection also. You can see that the lib stage fright HTTP support, for example, has a certain part which is read and executable. That's the text segment that we discussed during the assembly lesson. Then you have here a part which is read, and this is not mutable, and this contains those non-mutable data. And here we have the read-write, which is the memory, that is the heap section that we will be able to write. But since it's writable, it's never executable, and therefore it's a protection that we because in a buffer overflow, right, you're typically overwriting a piece of memory somewhere, and the idea is that the attacker will not be able to execute anything which he has written there. Yeah, I can tell you that it's not. You will be able to bypass it. Right? Okay, that's clear, right? Let's continue then. You're welcome. And yeah, it is very important to do memory leaks. You will see without memory leaks, most of the time it will be very hard to exploit. You saw the Awaking exploit, or the Awaking article that I showed you guys in the beginning. There they used a second application that was already installed on the device to exploit the bug, to be able to exploit it. In real world situation, if that won't happen, right? You won't have an app that is specifically giving you a leak, or it is vulnerable, then it is, but the chances are very low that you will hit something like that. But You will also learn that leaking during debugging is very important because we need to catch the state of that moment that we leak memory, because the memory is constantly changing and writing by the processor, etc. And we need to make sure that at the moment that we are leaking, we need to see in the debugger how the memory layout is being looked at. Because if we are going during our exploit, say, leak certain address or the position at a certain memory page, then we need to make sure that that page is exactly the same at the moment that we do the leak. Sometimes you can create that situation by sending a lot of data, maybe, and making sure that parts of memory are aligned. Okay, but you can also use it for other things. We'll use it to bypass ASLR in the end. Now, there are things that you would like to do. It is, for example, in our example, you will use, we will leak the stack address itself to make sure that we have a pointer to the addresses of the stack, so that we can move around through the stack in our exploit code, that you easily can move around through the whole memory of the stack. Because if you have a stack overflow, you might want to reach some part and reference some part of that stack memory that you have overwritten. This is the same for leaking the heap addresses. If you have a heap overflow, you might want to leak the address of the heap itself so that you can move around through the heap and maybe leak something else which is on the heap. For example, you leak another pointer which is in another library instead of libc, for example, because that can be useful. Of course, leaking addresses are always useful. If you are able to leak and you see an address which contains multiple Fs in there, then you are I can guarantee you that you leaked a kernel address, and that leaking of a kernel address will directly enable you to bypass KASLR, and that is the kernel ASLR. Today, of course, you won't be bypassing kernel ASLR. That would have been even worse with the configuration and everything. But maybe in the next session, we will be doing in the advanced version, right? Of course, while you leak data, we leak addresses, etc., but you can also leak sensitive data, right? If you can leak a certain page of memory, that is a vulnerability in itself. For example, think about a vulnerability where you can leak a piece of memory constantly from the remote target. There is this, I don't know if some of you have heard about blind ROP. Did anyone heard about that? Don't be shy, just open your microphone, speak. The blind ROP is a quite advanced technique. That is where the attacker never has the binary in his hand and he's not able to do debugging or anything. So what they will do in such case, I'm talking they because I never did that, but it is obvious, right? If I get that situation, I will be doing the same for sure. But what you do is leak constantly pieces of memory and also instructions, and with that you're leaking pages. Instead of using GDB to dump gadgets, we can use the leak to dump the gadgets for us, prepare our exploit dynamically, and then send the payload to our target with a dynamically created ROP chain. It's very handy if you are going to attack some piece of software that's running somewhere, but you don't have any way of getting that piece of binary in your hand to do debugging, etc. And that's an advanced way to exploit, to do exploitation. But in the end, the ultimate goal is to bypass ASLR, and ASLR stands for Address Space Layout Randomization. As you noted that the addresses are always different at another system. The idea behind that is that if the attacker is able to exploit something, you will see an attacker will need an address, for example, of a function that he wants to execute on the target system. In most of the cases, system function will be executed because that allows the attacker to do arbitrary command execution. But to be able to do that, you need to know the address of a system. In the past, every system had the same address, right? There was no problem. If you run Windows 10, Windows 98, and I developed an exploit with correct offsets and the addresses, I could guarantee that that worked on your machine as well, as long as we are on the same version of Windows. right? Because every version, every update will change those binaries that are loaded into memory, will change them in size, and that will automatically change the offsets of all the other parts as well. And that will change the offsets. That's why in the past, when you had exploits, you had to give the target, right? I don't know if some of you have ever run exploits, but you had to give targets, and for every target, they set different offsets because the offsets change. Now, the info leak bugs, there are several ways that info leak bugs can happen. One of the famous one is the format string bug. I don't know if you guys have seen in the last couple of weeks, there was something interesting going on with Zimperian, iOS, Wi-Fi, format string. That should bring us quickly there. I don't have the link here, but there is a Zimperium. Yeah. So this blog post, this is just recently happened. There was a format string bug in the Wi-Fi SSID when iPhone started looking for the SSIDs, right, for to connect with, and you set your to %s, your name to %s, and an iPhone tries to connect with it, it will actually crash the iPhone. But it allows also code execution, because format strings are very dangerous, format string bugs. And they still happen everywhere, because people think that those things do not exist. We are talking about the most secure device in the world, almost one of the most secure devices, right? And it contained the format string bug. It doesn't surprise me, actually, but a lot of people usually say, you know, format string bugs do not exist that much and this and this. But I don't believe that, because there are many, many cases where that still happens. Of course, during a heap overflow, when you can override a piece of heap, there are objects over there. If you are able to override an object and you still hold a pointer to that object, you can now manipulate the object itself and abuse with the heap overflow to leak for you. The same counts for use after free, because I will explain later what the use after free is and how that looks. But in general, the concept is the same. You override a piece of memory which you have control over, and you are able to leak a piece of memory. And with the type confusion is almost the same as with use after free. The technical thing that happens there is almost the same. You know, the attack itself will look a bit differently, but in general, with the type confusion, you are also confusing the pointer that you have, right? If you control that, you can do a lot of cool stuff like leaking and arbitrarily read-write primitives you can create with it. Yes, Sabia, you raise your hand. Yeah, Sabia, did you raise your hand? We are all in still, right? Nothing is going. Lower the hand.
I guess it was from before. Yeah, I didn't raise my hand now.
No, it's cool, no problem. I thought that's, yeah. After saying that, I realized, oh shit, that was true. But yeah, in general, also stupid code, right? Look at Heartbleed, for example. That was typical case of a piece of stupid bug in there, and you don't have to have format string, etc. If you just print out the buffer, which is a certain size, and you print more than that, for example, yeah, of course, obviously you're going to leak more data from the memory, and that will cause many different issues. You will see how to abuse those. Right away, it will break ASLR, I can tell you that, because that is what attack the most of the time wants. And most of the time, that is also the point where an exploit will break or work. So you can find during your fuzzing campaign maybe a lot of cool bugs, but if you cannot combine them together to achieve ultimate goal to execute code, yeah, then there's no point, right? You can have many overrides the memory corruptions as you want, but if you cannot leak one piece of memory, you will not be able to calculate the target's memory, for example. So format string bugs, and we will discuss format string bugs a little bit more in detail, because in the vulnerable application you will abuse that. And the attacker in this case controls the format string specifier. And that is the part will look into that. But that will allow us to leak and write data. So you have a read-write primitive already with one bug. And that's pretty cool, right? Because with that, you will be able to do code execution against your target. How does that look? How does a simple example look? You have the printf, right? The printf family, which is doing the. Matthew is coming back. Matthew, are you back again? Something is going wrong with your Zoom, I see. Can you hear us, Matt? Oh no. Okay, but if you have any questions, should be good for a bit. If you have any issues, Matthew, and you don't hear a part, I will be available later as well. You can ask me any questions. Also, guys, for every one of you, after the class, feel free to contact me. I'm more than happy to answer or even work on a problem together. I really love to do this stuff, so I'm more than willing to help or work together on some problem. Now, how does a vulnerable part look like, right? We have here the printf, and now here you can see this is using the argument that can come from a user. This is a very simple explanation, right? I hope you guys get it so that you understand why this is vulnerable. Now, when you look here below, this part is not vulnerable. Does anyone know why this will cause a vulnerability? It says it, right? The attacker controls the format string specifier. So what will happen? Yes, indeed, format string is not defined. And the thing, what these commands do, right? Within the format string, these are the format string specifiers. They will operate on the stack. So if you place here more %s, that will operate on the stack, whatever is on the stack, for example. If you use %x, it will get the first thing that is pointing on the stack and leak that. And just print it out, because printf is used to print, right? So it will print it. If you use want to use %s, it will print a string value of that of that whole part. So you can leak in once a lot of data. You can also use n to write. We'll not discuss the write, but use the leaking part to achieve the whole goal that we want to do. Because to be honest, I can tell you, format string code execution will get quite complex in the end. You know, because you have to find the correct offset, overwrite a piece of memory, and with it gets more complicated. If this is the first time you're going to do this stuff, I believe that will be very very difficult to do. Now, we're going to do this all together, and there's one thing very important to do, as I also explained, and that is leaking during the debugging itself. And why do we do that? Is to capture the exact moment and the memory layout at that moment. And if I'm correct, during an execution of any binary, if it reaches some sort of state, on my machine, it will most probably on your machine also the same. It's very static, right? It will in the end, for example, if it reaches smprintf, we will know that the stack frame looks in a certain way. That's obvious because the function will be executed. Now, you can do it very simply. Make sure, okay, I'm actually telling this, emphasizing this, make sure you start a new application. If it's running already, and this is what we will do the whole time, please pay attention. If this part, you need to make sure that it runs. So I'm going to send a short command to you guys. Instead of doing kill, you can do it. If you have a shell already on your device, on your emulator, you can use kill PID of component example my native test. So like this, then it should kill the process. So I will send this command so that everyone can speed up with executing. Make sure you kill the app first before we continue. So kill it, and then later when you are going to do these exercises, because it doesn't say kill the application, that's why I send it to you guys. Before you start this exercise, kill the app first, and then you can use the AM start to start it up again. You will attach the debugger. You just learned how to do that, right? You will attach the debugger. You open another terminal. You attach again. So here we set up the listener, attach it to the process. Then in our other terminal, we will connect to the GDB server and get into our debugging session. You will press continue so that the application continues the execution. Very important, press continue. If you do not continue, your application hangs, right? Then you will ask me a question. Hey, why is it not running? It's should we end the current debugging session? Yeah, you can. I think it's good that you just kill it and start a new session, but you will get the chance to do everything. Now you can use the kill command that I sent. Kill everything, shut down your debugging session. And the reason why I say that is that we make sure that everyone is in the same state while we continue, because it's going to get quite complex, okay? Now, when you press C, it will continue the application. As you already learned with the %x, you can leak data. If you send 1% x, that will leak 4 bytes from the stack. And that's very useful. Now we can leak data from the stack, and the data stack contains a lot of interesting data in there. That contains function pointers, local variables. A lot of stuff is on the stack, and the stack is quite long, so you can go and use the stack to leak arbitrary data. Make sure that you do ADB forward. And look, I'm explaining the slides now, and we will do it together. You do ADB forward in another terminal after you set the debugging, right? So we attach the debugger. We come to the another terminal to make sure that we forward the app's running port. Then use multiple X's to leak a lot of data. But this data is the data that is on the stack. And when you get those 4 bytes out of there, you can go back to your screen. I'm going to show it. You can go back to your debugger, press Ctrl+C, get this address, add a 0x in front of it, and use that address. When you print it out, VMMap will show you which SO library's address you just leaked. Is that clear for everyone? Or do you have a question? So we're going to leak an address. We're going to attach the debugger, attach the debugger, make sure that the port is open, that we can connect with our app, then connect with NC, use multiple %x's to leak multiple data from the running target, use that address, and then go back to our debugger, press Ctrl+C, and that will allow us to examine with VMMap which part this address is belonging to. Now I have labs for that. Let me send it to you guys. Leaking memory. 23. I'll send it to both. 23, 24, and we can do the same. Chat soon. No, you don't get the exact address. Oh, like that you mean? Yeah. Oh, okay. First, sorry, was someone speaking?
Yeah, I was just gonna clarify. I just followed along with you there with the bunch of %x's to leak the address, and it's the exact same as yours.
Yes,
So I was just wondering why that is.
Yeah. So you mean for the libart, right? This address is.
Yes. Yeah.
There's probably there's no randomization on that part. That's the problem. So sometimes you can compile a library without the ASLR enabled. So that is possible. You can disable it for one part. So we have the exact number, right? The exact values.
Yeah.
Are you sure about that? Because the first few bytes might, or a few bytes are different, most probably. The end part is the same.
Yes,
correct?
actually, I just looked at the last
It's fully
couple. Yeah, no,
same,
you're
right?
right. The first few are different.
Yeah, that's.
Okay, okay.
Yeah, no problem. I also get the first same bytes, yes. So it will, and that is how ASLR works. The first few bytes are changing and the rest is the same. And it makes sense, right? Because the first few bytes are I'll explain later, but because if I explain now, you won't.
What chunk of
So-
memory it's in, and then the last bit is the
Yeah,
offset?
last bit is the
Yeah,
offset indeed. So it
okay,
makes
I
sense.
see.
Yeah.
That's cool. Okay.
Yeah, that's
anyways.
cool, right? And that is also what we will abuse, because if we leak one address, we can now calculate the base address, come to the base, we will hold a variable, right, in our exploit code, and we can now move around through the whole memory and execute anything we want. Yeah. That's why we do this. Guys, give it a try. Leak something. Let me show it also in this on the screen. So we killed it. Now I will start up the application again. AM start.
Hi, Umit. When I try to kill the PID of the com.example.mynative test, it doesn't actually kill that app. Is
Are you
there
root?
something?
Are you root?
Yeah,
You can
I
see
am.
that.
Yeah, I put the output in the chat here, but
Yeah, I saw. I just saw it, but there is one running, right? Just 1 second. The process is actually running, but ptrace is. Let me try it here as well. The same command as you are running to see what we see here.
I think it's the kill, because if I kill the process ID explicitly, it still does not. And
Does not kill it. Do you have
Yeah.
the debugger attached to it?
yeah,
Not
yes.
matter. It should not matter actually. Just can you kill the debugger and then try it?
Yeah.
Maybe that is causing it, but normally it will kill it actually. But it can happen, right? I don't know.
Okay.
Sometimes we have weird behavior in systems, right? I don't know
So
if
if
you
I-
guys. Yeah.
If I detach the debugger and then try to kill that process, it actually says no such process. So it's already been
Yeah, it
killed.
got killed. Yeah.
Okay.
Oh, that's why you got the ptrace STDO. That's why I wanted to see. Oh, yeah, I have it here too. This is actually mistaken. I have my debugger attached. That's why you see the ptrace. Because look, when you can build your own debugger yourself, and you can with ptrace, right? I don't know if you guys know ptrace. Ptrace is a yes, it's different. Yeah, and that's the case, right? Your ASLR is different. So the address that you leak, right, in the slides. So let me again highlight it to everyone. This address and any address that you will see on the slides will be different on your system or my system. That's why following the steps in the slides, if you follow the steps, those addresses do not matter, because we don't care, because we're going to dynamically calculate those addresses in the end. What we are worried about is, can we leak an address? It doesn't matter. We just need to find out which address belongs to what. So if I'm correct, when you guys do the VM map, you should see libart, right? That means we are leaking the same address. We are leaking the same position in libart. Let me show this on the screen. Now the debugger is running, right? The debugger is running. Let me also check this. I got in the meantime. Okay, we have the debugger running. We can continue the process. Of course, mine got killed because I also killed it, right? So. Oh, sorry, multiple things open. Let me close this. Close Windows. So we have here the debugger attached. If this is still attached, not okay. Because I killed it when busy with Andy. When Andy asked the question. Within GDB, how do I pause the execution? You press Ctrl+C. Matt, When you press Ctrl C, you will be able to pause it. So now it is already running for me. It says now let's run our debugger. Touch our debugger quit. Oh no. I killed it by accident. So I think most of you are done, right? Would you like me to show it still on the screen? Please raise your hand if you would like me to see that I'm doing it on the screen, or else we will continue because we lost some time in between. And you mean show it on the screen, right, Andy? Okay, cool. Let's do that. So the app is running right now. Let's attach the debugger quickly to it and not kill it again like I did just minutes ago. So I attach the debugger, come back to my debugger. We attach the debugger on purpose so that we can examine the address that we leaked, right? I set the sysroot again. Now I will, in the next execution, I will set it in one line so that you guys don't have to see typing the whole time. It's like this. Then we set the sysroot. Let's do get remote. 5045. Now the application runs, and we are just interested in leaking, just using the application itself. I will press continue. Now it continues. This is the first part of the exercise that you saw. I will open another terminal and do ADB forward, TCP 6000 and TCP 6000. Now that will forward the running app is the listening port. You know, the app is listening on a port, and we are forwarding it to ourselves so that we can access it through this VM. Now that is done. Now we should be able to connect to it by using our own local IP address on the port 6000. You should be getting greeted by welcome to DAM exploitable Android app, and send a series of %x's. You can also send other stuff. If you're interested, just play and do it yourself and see what happens. Look, guys, you can see mine are also different. Only the first 2 bytes are the same, right? So B2, 4B, you get 8 characters you pull out of it because 2 of them are 1 byte. And we need 4 bytes, and therefore 8 characters. You can copy this. Now go back to your debugger, press Ctrl C. Now it will give you the debugger back again. You will be able now to examine the current situation. Now you can look, if you now send anything, right? You can try whatever you want, but the application is now is not hanging. There's nothing going on. You just telling the application through the operating system saying, hey, pause this stuff. I'm going to examine what's going on. Now, and that's exactly what we will do. I will use this address. And like I said, we need to add 0x in front of it so that, and all of you should be able to see this. I hope this works for you guys. And we have 7 minutes to go before we go to lunch. So I suggest we continue and then go to lunch and come back for more stuff. So we went over this part. We can use this same technique to leak the stack address, leak heap addresses, data in memory, so that we can leak private keys. We can even leak chats, you know, that are in the memory, because at this stage we will be able to do a lot of stuff. We can leak a lot of data from arbitrary places, not arbitrary in this case, arbitrary on the stack, arbitrary positions on the stack. This will allow sometimes, you know, these leaking of info leaks can also allow you to leak files, etc., that are loaded into memory. Now to the real world, how do we abuse this to to do info leak, or how do we abuse an info leak to bypass ASLR, right? It's quite simple, actually. It looks very advanced and etc. when people speak about it, but it's not. It's not that fancy or anything else. The problem here is that the positions within the libraries are not random. Just minutes ago, I think someone Matt, or I think Matt asked, hey, how is it with the ASLR or the offsets? We discussed about the offsets. So those offsets are always the same. If you have a blob of data or the libc, for example, all these addresses, all these positions. So for example, you have function A, function B, function 3, a lot of those functions, they will be all placed in the fixed position, right? Or if you don't have that, it will be very difficult for a system to execute. So those libraries, so if you have libc, the base address till the end will be the same depending on the version of libc that you are using, of course, right? Because I discussed if you have more code in there, it will affect the offset. The base address is important for us, and we can get the base address, right? You already saw that when you do VM map, it spit out the start and the end address. The start is that address and the end is that part. So if, for example, we leak this address, you can see it here, right? We leaked this address. We should be able to calculate the base from this. Even if I calculate it right now, because I will find the offset, I'm pretty sure it will be the same as you. That is the problem why we can bypass ASLR. We find the offset of the image base itself, and we can calculate the base address. So how do we do that? First, we leak an address, and then you subtract the image base from it, right? And that will give you the offset. For example, we leak this address, copy it in here, get our calculator. In these cases, our calculator is our friend. Oh no. It started weird. When you do this, it starts something else. But anyways, let's start the calculator. So this is that address that we saw on my slides, the leaked address that we just leaked. Doesn't matter what address, as long as you leak something and this is the address, you check which the library it was, as you did with the previous exercise. Then you get the base of that. You can subtract from it. Oh no. Where is my screen? So this was the address we leaked. Minus the image base where we are leaking the address from. It's a simple calculation. No, you gotta be kidding. I did copy. Control V, that should give you an offset, right? Now, since we know this offset, we can always calculate back to the base, right? Because now, if you have this, and you subtract it from this value, that should bring you back to the base again. And that's exactly what we are doing, and we will then bypass ASLR. Now, here you see it. You can get the offset. This is a very simplified explanation. So you see the image base, the difference. When you calculate, you will get the offset, and that's your offset. And the offset is very important. With that, you can now, when you have an address, for example, we leak this address, we subtract the base, the offset again, that will bring us to the base. And from there, you can now, from the base, if here system address was, as you see here, and we want to calculate the address of system function, and we know the distance from the base is located here, we can add the offset to libc base that we calculated dynamically and get always to any function that we want. Is this understandable? Do you want to know more about it? Please ask me any questions. I'm more than willing to answer any question. Maybe I should have said I won't answer any question after the call.
Amit, is there a, has anybody made like a plugin or a script for GDB that would automatically calculate the offset for you? That seems like something that would be a repeated step.
Yes, it is. No, I'm not aware of it. I'm just doing it manually, to be honest. But if you find one, please let me know, okay?
Okay.
I'm doing this manual because there must be a way to do it, but I'm not using anything like that. And probably not, and a lot of people that I know don't use it. We just calculate it manually because it's quite simple, you know. It's very simple to do it. I'm pretty sure NSA has one to calculate those addresses very easily. But no, we don't have it. But if I mean, it's a simple thing, so it should be. You should be able to create a script. It's Python, right? You just subtract it from it. You can give it a command to calculate. Maybe Geth has a functionality to do that. It's nothing more than this address minus the other address. Maybe Pound Tools. I don't know if you guys know Pound Tools or PoundLib. So PoundLib is a tool. The system always adds that offset for that version of libc. Yes, for that version of libc. For that version, indeed, if you have a different version, and there is also a nice trick, right? Because there is, I don't know it from my head right now. I don't have a link also that will require me to search. I don't want to search in front of you, but there is someone has published an online application where you can pass in an address and it will calculate, it will show you which version that libc is. So if you have to do that remotely against a target, you can leak addresses, get the version, and dynamically calculate which libc that is, and dynamically build the exploit and send it, because our exploits are most of the case dynamic, right? In the past, years ago, I think 10 years ago, when I was a kid and doing this stuff, it was not dynamic. We just create one static exploit, send it, it would always work. Fortunately, for some people, that day is over. Or else, NSO would have a very nice, very easy job to do. But anyways, with PoundLib, actually, I think Christopher, I don't know who asked it just minutes ago. I keep forgetting the names, but PoundLib has a lot of functionality. For example, here the Rob, and I saw him memleak helper. So yeah, there is a tool, there is a way to do it. I don't use it, you know. I don't use all this functionality in there. Okay, so feel free to use PoundLib if you would like to. Most I see people use this during what is it called? During CTFs. Okay, guys, let's quit. This was the part about leaking ASLR. I hope the theoretical part of this is understandable, because we're going to put everything into action. In the next steps, we're going to do everything we learned. Every tool and everything will be used to fully build the exploit. We have multiple exploits to build, so that will take some time to build. Yeah, it's lunchtime right now, so let's take 1 hour break and come back and start doing the full-blown exploit there. I hope you guys like it till so far, because I cannot see the reactions on your faces and stuff. It's kind of difficult for me to guess what's going on. You guys like it till so far?
Yeah, this is great, Amit. Thank you.
Cool. Awesome. Thank you very much, guys. Okay, then let's do a break and come back, and we'll discuss afterwards. Thanks. So in 1 hour we come back.
Welcome back, everyone. I hope you had a great dinner, or a nice dinner. First, before we continue, are you guys back? Can you raise your hand again? So if you're back, please raise your hand, so that we know that you're back. Cool, more and more people are coming back. Let's give it a couple of minutes. Then I can actually explain what we, in the meantime, Praveen actually did some, Praveen actually figured out why some of you were not able to run the script. It turns out, I'm going to show it on the screen, because please correct us if we are wrong, but I believe that some of you have run the AVD, your VM, by pressing this play button. Am I correct? Some of you who had the issue have used this play button to start up their Android emulator. Correct? Can one of you reply? So for example, when you started up your Android, you wanted to start up this emulator, you most probably used Android Studio's play button. When you do that, in the first explanation, we say press the play button because then it will install this app, but every single time now, when you start up, you don't need this anymore, okay? So what we usually do is go to Tools, AVD Manager, and boot up our machine from here with cold boot. And then after that, you can just shut down the whole Android project. There's no need for that anymore. And that is what we identified as being the issue that caused this problem. That the installation script did not run, because what happened is that ADB was attached from Android Studio, and that prevented you to install it in the proper way. And every single time someone presses play, it will install the previous app again, and that caused the problem. So that is now, we figured that out. Actually, Praveen figured it out, so thank you very much, Praveen, you're amazing. And another thing that I wanted to tell you guys is, before we continue, as you saw, there was a memory leak, right? And we fuzzed actually yesterday a binary in the ARM64 folder. And that was actually the library that is used in this application. You know, the libnative library that we fuzzed was actually the library that we are exploiting right now. And can anyone tell me, based on what you have learned, how you would have been? For example, we fuzzed with AFL, we found the crash, but it did not show us that there was a memory leak. Do you know how we would have also identified memory leaks during the fuzzing? Does anyone know that? Let's see if someone still remembers. Don't be scared to answer. It doesn't matter if you don't have it correct. You know, we are here to learn. It's all okay. Could you check return calls from returns from calls? When do you mean that, Matthew? During the fuzzing? Yeah, but there is an easier way. There's an easier way, right? Praveen actually explained that you can use ASAN, address sanitizers. If we would have enabled in AFL the address sanitizer, eventually AFL would mutate the data, right? And he would definitely hit the %x. The %x, he would hit that 100% sure, no doubt about that, because it's doing bit flipping on every input that he sees. And with bit flipping, you will eventually hit the characters, etc. And then it will identify that the memory leaked. But using ASAN in AFL will make your fuzzing again slower. That's the trade-off that you pay for. But anyways, the way I just wanted to explain to you guys how we got here in the first place, right? We are exploiting a vulnerability that we earlier identified by doing fuzzing, by pulling the binary, and we identified the vulnerability. Now we are exploiting it. You learned in the previous lesson, you learned that it was possible to leak a piece of memory and then calculate the theory behind the calculating and bypassing ASLR. Now, in this section, we're going to do a lot of hands-on, continuously hands-on. So please pay attention, because if you miss a step in between, it will still not be a big problem because we created the cheat, so you can actually cheat in between if it's necessary. So I created the slides also in a way that they are interactive. So if you just press through the slides, you will see moving elements that will show almost the same thing that I do on the screen. So that afterwards, when you follow the slides, you will be following the whole exercise as well. So what do we discuss today? We will discuss the non-executable stack on ARM and how to bypass those. One person came. Hi, welcome, Matt. We'll discuss the non-executable stack and how to bypass it, and then we'll bypass ASLR with the info leaks that we have. We'll do the calculations ourselves and then start building up our exploit little by little. Little by little, we will add elements to it. Then you will learn, as we discussed earlier, that you sometimes can jump into a function that will execute something within the binary that is useful for us. For example, just something from out of my mind. If you want to send a file back to yourself that is on the device of the victim, for example, you might want to call send message with your parameters in there. Then it will send a message, or send file, for example. That will include the file in there and send it back to you as an attacker because you control the parameters of the function, right? Obviously, it will be visible for the victim, right? But since we are not working for intelligence services, we are just testing it out, so it's all okay. Then you will learn about drop chain, real practical learning it, and then we'll do the full blown exploiting with return to libc. And later in the end, you will be also building a new exploit where you will be executing shellcode, not only return to libc, which will do pretty much the same thing. And I think doing the return to libc is more easier also and better in most cases. But in the end, if you execute shellcode, you will do pretty much the same stuff. Let's do a little bit of introduction into buffer overflows for some who this stuff is new. Memory corruption is just overflowing data, right? Nothing but a piece of memory that gets overwritten over a place that should not be overwritten. Because when you create a char variable, for example, that will reserve a space in the memory, and if you copy something, that will cause a buffer overflow. We also have other types of buffer overflows where you can overwrite only 1 byte, and that's what you call an off by 1. That sometimes happens in loops because they will count 1 more, right? Because when you, that has to do with the arrays, right? The arrays start with a 0, and sometimes when you do a loop over it, you will write 1 byte out of it. You'll think like, what is 1 byte, right? But the problem with 1 byte sometimes can be that you will overwrite the 0 byte at the end of a string. And the way the computer is interpreting the strings is by checking the 0 byte at the end, and there he knows there the string ends. And what will happen if you remove that 0? It will start printing anything that comes after it until it hits 0. So sometimes those off by 1 can be turned into memory leaks as well. Or also bypass if statements, for example. Some value that is being checked in an if statement. Integer overflows that will be caused by an integer that when you increase an integer, there's a limit, right? Till what the integer can, I think 65,000 something from my head. But when you go over that value, it will go into the minus value. And what will happen if this value was being used to allocate a piece of memory and you were able to modify that and overflow it, for example, the memory allocation will not be this size, for example, but will be in minus, so it will be nothing. And when a mem copy happens, it will again create the buffer overflow. Therefore, integer overflows are very important. And the normal one, the stack overflow, that is, we will overwrite the stack data. And as you know, on the stack, we have the LR, and automatically the LR, when we overwrite the LR register, we will be able to control the PC register, which is the next to be executed, next to be going to be execution. I say it every time, not correct, but when you control PC, you will be able to change the execution flow of the application itself. How does it look in code? This is a simplified version so that you can have a better understanding. So here we see on the left side in the bold, a programmer has created a buffer that contains 10 bytes in there, with containing 10 characters. You see the representation in the memory, just a simple representation. Now, when we go to the second one, we see that the buffer 2 has been filled in with the Bs. Obviously, when you copy too much 15 Cs, for example, into buffer 1, that will override buffer 2. If buffer 2 now was being used to execute, if buffer 2 normal contains a parameter that will be executed as a command execution, you will modify the command execution and get into the system. This happens on IoT devices a lot. And with that, you can most of the time get root privileges on your device that you're exploiting, for example. And it can happen everywhere, actually, not only on IoT, but it happens quite a lot on IoT devices. We do a lot of those hardware tests, and I can tell you it's pretty much everywhere. We discussed that this application, when we looked at the crash analysis, we saw that there was a stack overflow. But how does that look, right? When you look at the stack overflows, our goal is to overwrite our goal, and what happens actually is that we are overwriting stack data, and with that we control the LR register. But how is that happening? You remember, right? In the beginning, the stack pointer was pointing below, and the frame pointer will also point below here. When the function, before the function enters, when you enter a function, you saw that there was a push R7 and push LR. At that moment, those are being saved on the register. For example, the LR register's value will be saved on the stack, because whenever this subroutine that you called, if he wants to make a branch to something else, then again the same routine will happen, right? Because if you keep saving in PC or in LR where you have to go back, you can only enter one function. And this is the reason why they save it on the stack, because then you can return back easily. Please ask me any question. If you have any question or you don't understand one part, I'm more than happy to explain whatever is needed. So the link registers are saved, right? And as I'm here explaining again what those do. Because in the end, you will see we will branch into using BL or BLX, or we pop them into PC. But for now, just understand that our CP function that we fuzzed earlier contained the char pointer, which was doing, this is again a little bit of a simplified version, but if you look at the code, you will see it's almost like this. It had a piece of local variable in the function. You can see the stack frame is here. This local variable has been saved over here. In this case, the stack pointer should be pointing here, but it made the image a bit too much. But the link register is also saved on the thing. When you do a buff, this is user controlled, right? The user controls this. He can send data into the CP function. It will control the stack data. Makes sense, right? We are now overwriting a piece of memory called the stack. And therefore, we control also whatever was on LR. And that will pop PC return to callee. And with that, we control the value of PC, which is 42, 42, 42. That is the hexadecimal representation of the capital B character. How does that look? Why does this happen in the first place, right? We discussed about how the stack works and etc. But within a function call, every single time when you branch into a function, right? What it does, it will push the R7. R7 is nothing but the pointer. I discussed the stack pointer, right? Which points to the top of the stack. We have also a register called R7 or R11, depending on thumb mode or ARM mode. This R7 or R11 will be pushed also on the stack. Why we do that, why that happens is you're saving the previous frame pointer of the, look, every single time where you execute, if this is the stack, for example, if you look at the camera, if this is the stack, you have a frame pointer for every single function. But we have only one frame pointer and one stack pointer, so we have to move them up and down, and that is exactly what is happening. And this is called a function prologue, okay? Every single time when a function enters, it will save the base pointer and the LR register, which was set by the processor before we enter this function, so that we know how to come back. Then we will move our SP into the SP value into R7, gradually moving the below to the top of the stack. We'll create them, and then subtracting from the stack the amount of data that we are going to save. So it will move it up and create on top of the stack a new stack frame. And that will be used by the application. Then within that stack frame itself, right, we saw that in the previous picture as well, all these local variables will be saved. When the function returns, what it will do, and pay attention here, because here we pushed LR on the stack. When we return, we subtract it back from the stack, right? We make the stack again small, return it to its previous point where before we entered the function, and then pop the base pointer back. So we will create a base pointer and gradually popping LR into PC, and that will return back to the original function that called this function. But as you can see, since LR is on the stack pushed and later being popped off from the stack, that will allow us to control the stack value. So for people who come from the x86 64 world where where the return value is just saved as a value on the stack, here it looks a bit different, right? It's being pushed and then later popped into PC. Sometimes you also have a different epilogue. This is, by the way, called an epilogue, and that's the end of a function. So every single function will start with a prologue and end with an epilogue. Does that make sense to you, guys? Okay. Now let's discuss about the non-executable stack. We discussed about that some pages are read and writable, but never write and executable together. So executing shellcode on the stack is not possible. Although that's what we think, right? That should not be possible. But it is possible. You will learn later that we will be able to do that. Because we will use normal operations, normal stack operations that normally also happen. So the application or the mitigations that they created for that will not be applicable, because you can still call functions, right? This is how a normal computer operates. So if we use normal functionality, then we will be able to bypass some stuff. And we will use ROP gadgets to execute multiple little gadgets that do stuff for us, but eventually disabling a lot of stuff for us. Now we're going to get into the hands-on, and this is very important that you do the steps as I show, okay? Because I told you guys, we want to leak the memory. We're going to leak memory, but we're going to see which part of the memory we are going to leak. And I'm going to explain you how you can calculate those. First, we're going to do a very simple calculation, and after that, I'll explain how you would calculate it in a formula. Because as you remember, the format string bug is printing 4 bytes at every %x that you do, right? So we have to do some calculation then. So since we can write data, we can also pass the address of system as PC value. But first, let's do the leak memory. No worries, don't do anything yet. I'm gonna discuss the slides and give you the slide numbers to execute before. First, I will also show it before you do it, so you see how it's supposed to happen. Again, before we start this exercise, you're going to restart your app by killing it and starting up again. Why are we doing that? Is to make sure that our memory is at the same, the memory is the same, right, for everyone. There is a way to optimize this and make sure that whenever you run the exploit, but it makes it unnecessarily complicated to show it for you guys. If someone is very good at this already, I highly motivate you to write your exploit right now and show me at the end a very nice exploit, the one that you have created yourself. I highly motivate you to do that. I would be very, very nice to see that actually. Also, so you put a breakpoint, you disassemble. We know that leak memory is the function that is somewhere leaking memory. And if we look at this function, we see here that one of the family functions of printf that is called snprintf. And snprintf is printing, doing format string, printing into a buffer. So what we will do is put a breakpoint on sfprintf. Now you understand why we were constantly asking, do you see snprintf? Do you see snprintf? But that was also to verify if you have the symbols or not. But you see the address over here, and as you remember, you can put a breakpoint by putting an asterisk character in front of it, and it will put a breakpoint. You should see breakpoint 1 at that address. Now we put a breakpoint, and do not forget to press continue. I'm saying this again, press continue after putting the breakpoint. Now your application will start up again. You will send 1% X. Not more, only 1% X. We just want to examine the memory when this function gets hit. When the function gets hit, right, when our breakpoint gets hit, you will see the situation that I explained before, that your breakpoint will hit the exact function that you put your breakpoint on. And that's perfect, because now we can examine the memory and see how the stack looks. And note that the stack address here, this is the stack address, and note the first 3 bytes of those stack address. We are looking for that because that's important. We need to find this address somewhere on the stack, so we can run VM map later against it. How do we do that? How do we leak then a part of the address? It's quite simple, right? You use x/100. Do not, I forgot to change it, but you need to do 100, not 1000. If you do, you can do 1000, it will print more, but spare yourself the effort by scrolling, etc. Do 100, that's enough. I will show it in the screen, no worries. When we look at the stack over here, we see a bunch of stuff happening here, right? A lot of addresses. And you can already note that there are a few addresses that belong in the range of the stack, right? Because they start with 8E5, 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 a lot of them. But I can tell you already that not all of them will work because they will change. They will actually change. Some of them are changing. They are not static always. We are looking for one position at one location, which is never changing. The value is always that stack address. We identified one. You can do that yourself, right? Well, when you are building your own exploit, yeah, you will do a lot of effort with finding those positions because you will observe it constantly, see which value is not changing, and use those ones. It makes sense that those are not, some of them are not changing because the stack frames that have been created on top of each other have. Because when you look at backtrace, you saw multiple functions were hit, right? Multiple functions led to come to the current state that we are in. Therefore, you will have multiple stack frames that have the same data in there. We can observe by counting 1, 2, 3, 4, 5, 6, 7, 8, and blah, 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 blah. That will reach the position 5 and 25 over here. So if you send %25, it should print this, right? So that's not entirely true. You need to add +1 to it. If you do that, so first of all, you will examine the stack, find the address. After that, you will check if that address is really the stack address itself, and especially our threads stack, right? You can see the thread number here. Now, when you do that, a run VM map against it, you'll see, hey, this address belongs in the range of our stack. That's perfect. Now, you can now restart your application. And as I said, you need to add +1 to it, and it will leak that exact position for you. But make sure that you again freshly start up the application so that the memory state is the same. So you send the %x and you will see it will leak always that value. You can verify it again if that's still the stack address, and you should be good to go. Now, this is a lab exercise. I'm going to show it on the screen before you guys do it. So please wait before you do it so it's clear, because there are some little things that can go wrong. Let's see, because I'm also going to send you the lab. So wait with executing this lab, okay? I'm going to show it on the screen, because after that you will be able to do it. But it will be 46 to 57 to execute. Let me move this over to here to follow the exact steps. Let's go to my application. You saw my application is running, right? Still the debugger is attached to it, so we're going to kill that. You can do that already if you want, right? And attach a fresh debugger, but pay attention first. I think that's better. So I will kill it with kill PID off. So I guess you guys have this command already. If you don't have it, here you go. You will receive it again. Callan, are you still here or did you leave already? So I killed the application. I send it also to you guys in the chat to kill it, right? So that you know. Oh, it's still here. Yeah, no problem. You know, Callan, you can contact me after the class any other day, right? Just contact me and I'm more than happy to go with you over some of those slides and explain it to you personally. No problem. So if you have to leave, don't worry, we can have a chat later. And, yeah, no problem. Now we'll start killing the app reboot again. You gotta be kidding me. But okay, I'm gonna explain it. So in the meantime, your app should be, your VM or your emulator should be started up again. So we start up the app again. It will be a fresh starting up. You can see it here, it will boot up. Yep. Now we boot it up. We attach our debugger to it. We can go back to our debugger. Now I will use the same command to speed it up a little bit. I'm going to send you guys this to the chat. So no worries, I'm going to send this command also to you guys in the chat, so it will speed up your starting. So you don't have to set the sysroot every single time. It will set it before you start. So that's the set sysroot is this thing. Let me, before I send it, let me test it out. 045. And my debugger is now attached. Here I'm sending it into Zoom, that command, and I'll send it also in the batch 2. So this is how you will attach the debugger, setting the sysroot before you. So every single time now you need to set it, you can just move your cursor up and down. But anyways, so now I said also in my slides, we need to put a breakpoint somewhere, right, at the exact leaking function. And we know that that happens at java_com, and I'm using tab. It will bring me here, and then leak memory. We will do this as and find the sprintf over there. We know that this is causing the leak. So before he even leaks, we want to investigate the memory, the exact memory state. We'll do x 100, not 1000 as in the slides. Remember, x, and we'll use this, and we'll add the address of. Oh no, sorry. We'll break. Sorry, we'll break at that function over here, right? To the breakpoint. Now I press continue. Which one? This one? This is the plot address. That's a jump into, that is jumping into SMPrintf eventually. So you have a GOT and a plot table, which contains all those functions, addresses called trampolines that will jump into this function eventually. There's a trick to abuse this, but that's not part for today. You know, we are already a bit behind schedule, so we can discuss it later if you want that. So this is the plot address actually. But when you do, I will come back to that later, yeah, if you don't mind. We can do it later together and show it to you. Yeah? But here, continue the process again. Now, if everything is correct, you already forwarded the port already, so you don't have to do the port forwarding again, right? But now we can connect to the app, and what you will do is send 1% X, only one. You note there's nothing coming back because why? Our breakpoint hit, right? That's exactly what we want. And now you can see my stack address is totally different than yours and the one that we saw on the picture. So the attacker can never guess the address of the stack itself. That's what we are aiming for right now. Now we will dump the value and 100 bytes, 100 addresses of the stack. And we can use the $SP. You can use or even PC or I'm just saying when you examine, you can use registers by putting a $sign in front of it. But for now, we are examining the stack itself. That is exactly this part, right? All these data, you will see them in a minute. Note this value, right? When we examine the stack, note, you see that value, right? It's just the data on the stack. Now, as we discussed earlier, at the 25th position, we can see this value. You can do a VM map against it to check if it's part of the stack. It is. So that's perfect. That's the one that we need. Now, here it comes. I'm going to show you something else. When you have done this, you are ready for the next exercise. Now, first of all, you guys can do that, but there's in the example folder, there's this exploitation folder. When you go there, there's a skeleton exploit. We call that skeleton because it contains the first one. You'll see it contains this, but to verify that 26 is the correct the correct value, you can press again 24 or continue, and you can see it will start leaking an address. In this case, it didn't show the correct one. After the breakpoint is hit, the debugger is still continuing. Did you attach it to the correct process? The debugger is still continuing. But continuing with what? Did you press enter by accident? You can try it again, just setting the breakpoint again. So I'm gonna. No worries, I'm going to help you in a minute. So what I will do is again restart the application because we want to test out if it's true what we tested. I now don't attach a debugger to it because we're going to test if it's true. We don't need the debugger anymore to verify, right, if we were correct. Now come here, connect to it, send the %X, $26 $X. So we tell the format string specifier, sorry, this is not correct, 26%, $26 $X. So we can control the position that we are printing out. And this is how format string works. So there are many functionalities in format string, right? So you can use a lot of those. If you're creative, you might find another one as well. But if we leak this, we should get that address. And this looks quite similar to that address, I guess, right? So this is the exercise. Give it a try. I'm going to put 10 minutes on this lab. And then after that, we're going to continue with the second one. So go ahead, try it out. Ask me any question in between and give it a try.
Amit, where is the 25 coming from? Because if I look at just the VM, the X dump of the stack pointer, and I identify a value that looks like an address within the stack, there are other addresses that also look like they're in the stack.
Indeed.
Is there just any of those? Is there a reason it's specifically the 25th?
Yeah, so I explained earlier that some of those values, although they look now that they have the address, as you noted before, these two were also having the address of the stack, but note, now they don't. Because they will change. Some of those values are changing, but this one doesn't change. We examined it many times by running and checking which one is not changing, which is always static at that location. And that is the one that
it's just a brute force evaluation. It's not, there wasn't some deterministic way to say it's going to be that position.
No, because it's, you just examine the memory and see if there's a place there. Most probably you will be able to do it in a more deterministic way as well. But this is the easy explanation for it. You know, you search for an address that is in the range of it. You can
so not shown here was you iterating %X, 2%X, 3%X over and over until you saw.
No, you don't have to do that, because what you do is set the breakpoint. That's exactly what I'm showing. You set the breakpoint. When you hit your breakpoint, at that moment, you can just dump the whole stack. You don't have to send all those percentages, right? You just find out which one is, for example, this one or another one, right? And you start running your exploit a couple of times and you see, hey, weird enough, it started changing this address that we leaked, but what we thought it was always the same is changing. Then we know our exploit broke, so we need to find another address that is static. And you can do that by restarting the application and see, hey, is that position changing, yes or no? You can also, indeed, you could by sending the whole time data and determine it as well, but not really. I think this is the best way to examine it and find a way, find a fixed location.
Okay, thanks.
Any other questions? Is everyone able to do it? Facing any issues? So Andy, did it work for you, or are you still busy?
No, it did work. I was trying to figure out what the insight you have to say this is the address that I am going to use, not a different one that looks like it's also on the stack. It's because it stays consistent over multiple invocations. Okay.
Yes, indeed. Yeah, and that is the reason why we chose this one. If I run it now again, you will see some will also stay. You know, there are more addresses that are in those ranges and they stay. And we chose this one actually because there are a few more ones. Like for example, here's one. I don't know of all of which one of them are changing or not, but I know these first ones changed already. You can see those. Because if we look at previous one, I think I had another previous one right here. Or not? No, but I think earlier I did one. Yeah, here. But if you do it, you will see it yourself. It will start. Some of those addresses change actually, and that is causing the problem there. But you know, there are values there that should not change, right? Because if it's a stack frame there and there are local variables over there, if one of those points to the stack address, for example, of course they won't change because it's static there. Because the stack frame always contains the local variables. If there's a pointer there that points to the stack, that will never change. It's always there. Because it's a local variable within that stack frame itself. That is, you could determine it that way actually, because you know that at that time the stack frame is that you can examine which values are put on the stack, and which one of them are part of that stack frame actually. Matthew, you're done, right? If you're done, raise your hand, please. Sorry, I forgot to say that. Awesome, you guys are done. Nice, fast. Okay, then let's continue with the next one. Or just let's give it a couple of minutes, you know, because some of you are very fast and some might not. It would be not nice for them if you don't. We have 4 minutes for them to do. Unless a lot of people are. Please raise your hand if you're done so that we can see. Yeah, what you need to do, Lindsay, I think what is important that you do when you start up your VM, that you do the cold boot starting. So you can do Android Studio, right? When Android Studio is open, do the cold boot, not there is in the AVD manager. I'm going to show it on the screen so you can see it, and that will, yeah, that helps. Yeah, you want to dump the value at the stack. 1 second, Matt, I'm gonna look at that in a minute. So when your Android Studio runs, right, you can go to Tools and to your AVD Manager. Mine is running off on the screen, so it's here. Now you can press AVD Manager. Let's just start this up. You have this arrow over here. There is this cold boot. When you do cold boot, it will wipe this all parts out of it. It will be small again and boot up quicker. And then after that, you can just shut down your Android Studio. You don't need to run it. Is there, so Matt asked, is there a way to dump the value of the stack address we found? How do you want to dump it? Because we do that, right? In the by using NC. All right, so.
Yeah, I was curious, you know, if it's like a string or, you know, a pointer value or.
Yeah, okay, let me show you that, okay? Because we're gonna come there, but let's do something to show you something in between while the others are busy. So let me attach a debugger against to it. Now I'm using up and down with my cursor, right? Some of you might not use Linux that much, but that's why I send this code so you can easily now use this one without setting get root, the sysroot manually. We'll set the debugger again to it. Now let's examine the stack, right? This is Matt, this is what you asked. So x/sp, for example, and you would like to know that when you get this address, right? That is there.
Yes.
And what is in that address, right? But note that
yes.
The address that you leaked is the stack address itself. So whatever you print over there is just somewhere here printing those parts. So it ends at 140, right? And if you scroll down, 140 is somewhere here. If you print it out, it will print all those values. So how do you print them? You can use X, again, examine. You can print how much you want to print. Use the X or the S. Then you can use, if you want to print only that part, you can use S and use that address with a pointer then you should print it. Now, in this case, there is nothing pointing at that address. Let's see if I can find something with this would print. Not access there. I will show it in a minute when we attach the debugger back again against it. BE, for example, this looks like a stack address, right? You can see it is the stack address. That is the exact example that you have. Because now you can see it points to 0 because we can go to this. Matt, when you print this address, and you want to print the value which is in there as string, you want to print it, we can check E8, E88, which is below, points to a null. That's why it is saying it is null. There's nothing there to print. And if you print it as without the pointer, you'll see there's nothing in there, right? Because it points to 0. If you, for example, get this address and you want to print the string that is at, for example, here we know this address, or for example, if you would print this address, that will give you this value. Test it out. You can, you're just printing what this address is pointing to. This is as a string, but it's non-printable. We'll print it as an X. You'll get the first byte printed. So P88, you can see it printed the first byte of it. Remember, it's a little endian. I will come there, but this is a little endian system. So if you print 4, then you should get the whole string. No, guys. But no worries, Matt. You're gonna dump a lot of values. No, don't worry about that part. You will be coming there. I think I have a message. Okay, let's continue with the slides because we have less time. When we go back to our slides, if you have executed everything, you will know that you can now examine the stack and leak values, right? Now we have the stack address and we created, when you go to your code later, you will see that we added that part for you so that there is one example on how to write it. Now, we would like also to bypass ASLR, totally ASLR, because leaking the stack value will not allow us to bypass ASLR, only ASLR for the stack randomization, right? Because the stack randomizes also, but the libraries that we are going to use to do certain actions with, especially libc, which contains all those syscall, the wrappers around the syscalls, we need to have to bypass the randomization for libc. How do you do that? It's quite the same process, right? But the only thing that we do right now is we need to get the base address first, right? So you can run vmmap libc in your current session that you have. It will give you the top one is the base address. So you will see a list. The top one there is the start, and that is the base address, which is in red. That's the executable part. And that will give us the base. You can now restart the app again, right? That's why I said we will restart the app multiple times. Here I'm showing that I will kill it, start the app again, attach the debugger. Again, the sysroot thing, everything is still the same. Debugging the same, the printf, because now we're gonna do again the leaking. Again, send the %x, it's the same process, but now we're going to print more data on the stack because we want to examine larger pieces of memory to see if there is a libc address somewhere. So you use the examine /400xsp, and that will give you a list, right, with a lot of a lot of data. When you press Ctrl-Shift-F, you can search for the first 3 bytes that you got earlier when you do VM map. So I'll come back. So the first 3 bytes, you can also see that here when you run VM map. When we run liep, let me go back because now it's a bit. When we run VM map libc, right? We got the image base, and the image base started with 3 bytes, for example, here, or 4 or 2, you know, depending on how you want to search. But those will be the indicator for us after printing. We can now, as with what we did with the stack, we can now search for those 3 bytes. And we already identified for you which one doesn't change, right? Or else it will be too long for the course, you know, to search for them yourself. But basically you will search and see which one is changing and which one not. There will be multiple hits, right? When you search, and 1 or 2 of them will never change. Just keep that in mind. That's just trial, just testing it out, testing your expert. So I did that here. You can see I searched for the first 3 digits that we see over there, and I hit here one over there. Okay. Yeah, I saw the chat, that's right. But you see the first 3 bytes, when you search for it, you get that address, right? You check again if it really belongs to libc. When you do that, you will see, hey, that's a real libc address. Now, what do we do with that libc address? It will be very difficult to one by one to count everything, right? It's quite difficult if you have to go through 400 pieces of them to find the exact one. When I was 13 years old, I would probably have done that. But now what you will do is use the lead stack position, right? In this case, 34. Why I'm putting here 34 and highlighting this address is because if you get this address that is here, because this is the visual one that we can see, but we want to leak this address, you need to add +4 +4 +4, which is 12, right? That is C in hexadecimal. So if you add +C to this address, you will get 534 ending, right? Because that's basic calculation. When you do that, you can now get the stack top as using with the formula that you see here. You can now use the stack top, and that will give you a value, right? Now you can divide that value by 4 and adding +2 to it, and that will give you an hexadecimal value, which is when you convert that value again to decimal, that will give you 329. That's the formula that we use while we print this to find the exact position. And why do we do the divided by 4? You know that printf is doing the %x, right? And we add the +2 to it because we that is the offset that you will need to add to it to exactly come to that location. That's what we figured out. Now, when you set the %trend, when you combine those two that you found out, and when you set the %26 and then later $329.x, that should leak exactly that value. Now you can check that, right, if that's true or not, and start building up the exploit. And this part, you're going to do all by yourself. I'm going to show it on the screen again. Feel free to follow along already, or wait until I'm done and I will give you the time afterwards. Are you guys done already with that part? So we are dividing by 4, right? So when you look at this, when we use %x in our leaking, right? When you use %x, that will leak 4 bytes. And here the addresses on the stack are calculated by 1 byte. So you need to divide them by 4 so that you get the position, the exact position. Does that make sense? Okay. And then you add +2 because that is a fixed value that you need to add to it to reach the exact position. Then if you combine that, you can test it out yourself, and that will print out $329 Now, after that, please modify your exploit, right? So this part is there, and that's in your example exploit on the desktop. You have the example folder, there's the exploitation, there's this file, the Python script called exploit leak. You can add this part to it, and it does nothing more than send $329 as you would do through your capture that value that we receive as a variable, right? Because now we can do calculations in our exploit, and that's what we do during exploit dev, right? You can print it out as a debugging thing to the user, to the operator who is doing this. Yeah, I'm going to send you guys the lab numbers that you can execute. And CFS is from lab. Those are the ones that you need to do. I'll also send it in the Slack group for the ones that have Slack open. Yeah. Okay, give it a try. I'm going to do it on the screen, or you wait until I do it and then you can do it. It's quite simple to do this one. It's the same process as you did before. First, make sure you start up a fresh application. So I'll kill it again, restart it up. Attach the debugger to it. You can use this command again that will set the sysroot directly. Gef root, gef remote 5045. Put a breakpoint at that location. It did not change, right? So you could use the same breakpoint, but just do it as an exercise. You know, if you have not much experience in GDB, I highly advise you to do that, because moving around in GDB, that's the, you know, that is the skill set that you need if you write exploits. So this is the address that we want to put a break on. You add the asterisk in front of it. That will set the break. Now I'm continuing the process back again. Connect back. %x. That will hit my breakpoint again. If you put the breakpoint there, it should definitely hit your breakpoint. Make sure you put it at the correct place. Then when it hit the breakpoint, we're going to examine the stack with 400x and on the SP. I will use Ctrl-Shift of first vmmap libc.so. That gives me the first 3 bytes of it. Then we copy that. Ctrl-Shift-F and paste that in here. Start searching upwards. Please do upwards. And then there's the last one before it goes away. And you see that now it moved. You go back. That's the last one that we know that won't change during this whole exploitation. So this is the one you need. And you can see the address here, right? But it ends here to 528. This is the one that we are searching for. Then, after that, you can do the calculation. So, can I remove the breakpoints? Yes, you do delete breakpoints, and that will delete everything. So you can do this, right? Info breakpoints, that will show you all the breakpoints. Then you can delete also, like with delete 1, or use delete breakpoints, and that will remove all breakpoints. So I can do that, delete breakpoints, and when you do info breakpoints, you see there are not one of them. Now, as I said to you guys, this address here, this is the stack address, but that points to this 4 bytes. If you want to add, if you want to go here, you need to add +4 to it. If you want to get to this address, you need to add 8 to it, right? So 4, 4, 4. If you do that, that's in hexadecimal values, that's C. So if we come in here in my calculator, do a +0xc, that should bring me to this value, which is exactly the same as in the slides. Now I know the value. My slides are also showing afterwards how do we calculate it. And that's quite simple, right? You subtract, we again need the distance between those two. Now I lost mine. So it's this address. We got the address, right, by adding +C to it, that is this address. Now you do subtract the stack top, the stack top from it. And the stack top is nothing but the top address that you see here. If you subtract that, that will get the distance between those two, right? And give you the amount of bytes, the distance of the amount of bytes that you see there. In my formula, you see that you divide it by 4 + 2, that will give you this value converted to decimal, and you should get 329. This is how you build Blackmagic. But in the end, you will have a piece of you know the value, then you can go to your nano exploit and start adding the code. But there is also, you can copy paste it in. It is very important that you understand how we came here. So you can copy everything in, but you won't learn anything. I suggest you don't have to type it in, but you do the calculations and the debugging and stuff yourself. That's important. So for building the exploit, in the end, you can just copy it in, there's no problem. So here I have it here, right? So I'll copy it in here. Control. And then paste it in and remove those spaces. Save it. Now, to test it out, I'll kill the application. Run it again and see if everything works fine. Then you can run your exploit to verify. And correct. You should see those nice values on the screen, which are the exact values that we search for. Verify it, right? Check it here. If I'm correct, and we search for those. This was the value we wanted to print. When we come back, we can see that's the exact value that we printed out. Now we leaked 2 addresses and we are not done yet. We only leaked addresses. And after that we need to do our calculations. Just give it a try. If you have any questions in between, I'm here to help. Raveen can help. We are here to help you. Please ask me any question that you would like to know. I'll try to answer it. I also don't know everything, right? I'll try to answer everything that I can answer. So in the end, you will have your exploit built that leads two addresses. One on this the stack address, second one is the libc address. So I did x/100. I don't see no because look, that is what I explained here. We are going to bypass address space randomization. So in your case, when you do a VM map libc.so, you should get another three values there. Your addresses look different for libc, right? Now you can use, and what we are doing right now in our code, we are making sure that every time this exploit runs and we receive that value, we will have a variable that contains that leaked address. Then we can start doing calculations, etc. And then we bypass ASLR. We not did bypass ASLR yet, right? We now only leak the addresses. We are now busy with finding the correct ones to leak, etc. That is important before you can continue. And now we can throw in all our calculations against it and bypass ASLR. But you come there. So your addresses will be different than on the slides. Remember that. These addresses, etc., will be different. In some of your cases, because the address randomization will cause that you will not be able to find that value. So you can search for B3, for example, instead of using the first 3 bytes. That should also bring you to the correct one. So for example, I can copy B3 over here. B3 is a bit too small actually, but I'll just give it a try. Yeah, it works. So this is, as you see. So just as a reminder, the last one that you see before you go up. And Andy asked, how do we know that, right? We do this by running it multiple times and checking if those values are stable or not. Some of you are developers and such. I'm pretty sure you will find a better solution to do some things dynamically, etc. But most of the time, this is debugging and finding out that because you're nothing but instead of fixing a bug, we are just abusing a bug. So if you want to fix a bug, you're also debugging and testing, debugging, testing, debugging, testing. We are doing the same, but we are doing it with another purpose to abuse it. Makes sense, right? I forgot to take the timer actually. Are you guys done? I can't see my libc address in the stack. Should I print more? No, it should, you will have the same situation as us. I can't see libc address on the stack. Matt, you said no, you're not done yet, right? That's what you're saying, no. The libc address, the stack. Yeah, so look, try to use 2 bytes. So you can use 2 bytes of this. You do VM map libc, right? So do not forget to execute this command, Shatita. You execute VM map libc.so in gef. That should give you another value than that I had. Okay, and then use those first 2 bytes. Yeah, it is different indeed. So then you'll search by doing control. And then the last one, and that is pointing at this part. So I'm pretty sure if you search for this, if you look at an address that ends here at 528, Sharita, and you check that last one of that one here, this one is a libc address. Can you confirm that with me? No, that's impossible. I think you calculated not in hex. Okay, look, I have to tell you guys, this is hex. I'm putting it, look, in your calculator, you can use basic, scientific, right? It will make it scientific. And that is also on Windows the same. And you can use programmer, and that will allow you to do calculations as a programmer. And we are looking for 16. I was using online thing. No need for that. So you can use this calculators. A calculator has the same thing on Windows. You can do that as well. No, it has Windows as it also. Later, when the class is done, you can actually calculate yourself. And let me tell you guys one thing. I don't want to confuse you, but there's not always a need to leak the address of the stack in this way. There are also other ways to leak the stack address, but let's not go into much other stuff before we finish this, or else you'll be confused if this is a new concept, new thing that you do. Yeah, there are a few more, right, that are here and there also. So we searched for it, first of all, by doing Control F1. How did you know which libs address location to use? Yes, by testing it out a couple of times, see if one got changed after a reboot of the system. We tested it out a couple of times. We used earlier another address, a couple of times another one. Later, we saw that they got changed. That made the exploit unstable. And if you're going to write exploits in real world, right? Look, let's face it, right? Who builds an exploit? I mean, or you build an exploit because you do a pen test, etc. But I don't think you're going to build exploits for mobile phones, right? To do a pen test on. It's not a company that you're doing pen test on. Or you do this during a research to create a proof of concept, or you're doing this because you built it for a target, and then you need to have a stable exploit that always works. And you don't want this exploit to be crashed while you crash the process of someone else, because it will get detected. If a user sees, if a user sees that something is crashing constantly because we are sending data to it and make it crash by accident, and then we do another attempt, it crashes again. Someone, most of the time, those exploits are used against people, right? That do criminal activity, maybe. And yeah, if they see such a thing, they will be suspicious for sure. And by the way, I'm not building exploits for any purpose of that, right? Let me put that up front. We don't build exploits for such things. If you guys are ready, please raise your hands. We have still some work to do. Cool. More people done? Okay. Let's take one more minute and then continue. How did we know? Did it answer it for you, Kellen? Sure. Sharida, in the end, you can also use the piece of code that we added in there. so that we can continue and you can just add that and you can do the calculations later, because the slides are, as you saw, they explain the exact steps. And you can contact me afterwards any time. So please, all of you, open your exploit that you see here, add the piece of code, and that should be done there already. Okay, then we can continue. You can verify it later by running your exploit. Note those end values, they are all the same with us, but in front there is this randomization in it. Anyone knows how we could bypass this ASLR without leaking memory? Open your microphone if you would like to answer, or yeah, also in the chat, it's also okay, no problem. How would we bypass ASLR if we cannot leak a memory? Is there a possibility to do that? Okay. One way that we could do that is just brute forcing those bytes there, right? There you could do it. Also, there's another technique, but if you brute force this, then you need to make sure that the targets, most of the time this is possible at daemons, right? So daemons will restart if they crash automatically. So if you just send randomly after each other constantly, even though it crashes, it will constantly reboot. And as an attacker, you are able to guess the multiple bytes, because the randomization will only happen again if the system reboots. So you will be able to brute force this. Another way is to do a partial override, to override only little part of it. So you control these four bytes, and that's the only thing you need, right? Because now you can move around also. We don't need to know the rest of these other 4 bytes. Okay, now that we have those variables, we need to create a variable which points that brings us back to the stack pointer, to the top of the stack. How do we do that? Because we leak now an address, right? Don't get confused, because the address that you leak is some value that is somewhere here, right? But the address that we leak over here points to 140, and that is here. That's this location. So we need to find out, yeah, because here you can see it, that's that. And we need to find out the distance between those two. How do we do that? You can just subtract the both of them and get the offset. And now you can use the offset to calculate the stack top. The same technique as we used, as I discussed earlier. So now you can do that yourself. So go to your, I'm going to send again the lab part to you. And I will show it on the screen again. That's that. And on the Slack also for everyone. Okay. Here you go. So we can use it also by looking at the screen, right? You can get this value that you are printing. So first of all, look, I'm going to explain it again just to make sure that everyone understands. We leak this address, right? This address is actually at the position which points here. This is the position that we are leaking. If you get this address 140, look, this is the real. When we go over here, you can see it points 138. Again, it will leak from, we are leaking this position. If we want to get to that position, we need to subtract those values from each other and we'll get an offset. Now, if you subtract that from the leak stack address, you'll get the stack top. That's exactly what we do here. You can see here, we leak the stack top, we'll convert that into an integer, right? By saying this is a hexadecimal value. Then we minus the offset, the distance between the leak stack value that we leaked, and we'll create a new variable that's called leak stack top. Now you can print that to the user, and you guys can use the use the code and calculate it yourself also, and later use the code. So would you like me to show you on the screen how to calculate it? Or does it make sense? If it doesn't make sense, please let me know, okay? Because it's okay. Look, it's here, right? Here we have the address. Now we want to see, because this isn't just an address that we leak. And if we check here, we want to find out where this address is. Let's see, 38 starts here. And adding +4, +4, +4 will eventually get us to this address, which is this value. Now you can subtract this position, but it's simple, right? You can copy this address, subtract this address from this. That will give you the distance. I'm just showing you that this address, you're not calculating this distance, you're calculating where this address is, and that is here till here. There is the difference between those two, right? This position is something else than the value that is in there, which is actually the pointer that points to this value. But so you calculated distance between those two. How do you do that? You get your calculator again. This minus the stack top. That is also what my slides are saying. Copy that. Minus, that will get you the exact value. Now it makes sense that if you add this value to your subtract this value, so right, if I'm correct, if we get this value 2 minus 0, 128, we should get the stack top. Simple calculation. So do that, and I'm going to set a timer before I forget it again. Does this make sense? If you're confused or anything, or you have a question, please feel free to ask me questions.
So the calculations make sense, but I don't. I've forgotten why are we doing these?
Yeah, I'm going to show why are we doing this is to bypass ASLR, because look, now first of all we want to get to the stack top, because now we have an easier point to move around over the stack, right? So if later, when our shell code will start over here, for example, we can then calculate using that variable that we just created, which points to the stack top. We can say stack top plus 58 will point to the beginning of our shell code. So if we are going to redirect the execution, we can use relative calculations to move around to the location of the stack to execute it.
Oh, I see.
So later you will need to, for example, if you call system, right? If we look at the function definition of system, the libc lit system function, for example, system, libc. So when we go to system, you can see in system that it wants a pointer to the value of, it wants a pointer to the command and not the value of the command itself. It really wants a pointer to it. So it needs to point to a location where the string is saved. And that's why we will need it later. We will definitely need it. That's why we leak it right now and make sure that the renderization has been bypassed, and that's already done. But it will make more sense when we bypass ASLR for libc, which is next. Oh, I forgot to take the timer again. But are you guys done with this one?
Yeah, I had the exploit running correctly for the leak stack and the leak libc. And then when I added the calculations in, for some reason now it won't get an address for leaked libc. It'll only get the address for this stack.
I know why. Look, I'm going to show it the exploit when I run the exploit again against it. Okay, it leaked here now the correct values. If you run the exploit again, it will give you a 0 or minus. That is the situation you have right now, right?
That's correct.
Indeed. And this is, if you do it again, it will again give you a 0. And that is because, and that's also one point, we do this on purpose, right? Because it's a training. In the training, we are showing you that we want to have a correct state. Therefore, we reboot the application every single time and then shoot the exploit against it because we know it's a little bit more predictable. But in the real world situation, you would wait until a situation is there when it's more predictable, for example, or you do, if you, for example, in this case, we know that if you run the exploit a couple of times, that the libc address has been changed, but this stays always static. So we can probably find after running it a couple of times another location which is always stable, for example. But for the sake of the example right now, or else it will make it more complicated during.
Okay.
So if you kill your application, kill it, and restart it up again, and run your exploit against it, you should be able to get it takes the time to start it up. 1 second. If you now run it again, you can try it out. It should be again correct. Printed the correct values. So you have only one shot to exploit target. But there are ways to also make sure that the memory is aligned in a way that you want, right? It's spraying the stack or spraying the heap. There are many other ways to make some parts of the memory predictable in some ways. That won't be the case for the leaking the libc address, right? And please raise your hand if you're done. Am I going too fast or too slow? Just type it in the chat if you think it's slow or too fast, so I can keep that in mind while going over the slides. Take your time to do it, to understand it. Get to send you guys the link to it. And this is the book you would like to buy if you are interested in doing research in bypassing exploit mitigation. Contains every single new, not every single new thing, of course, but a lot of new techniques to bypass things that you won't see at most places. These are all based on research and papers published about that, compiled in the book. Ashley, are you still in? Oh,
Yes, I'm still here.
Okay. Yeah, I didn't see your for after exploitation. What do you mean for after exploitation? You mean post exploitation? Oh, post exploitation, yeah. So yeah, I will give you a few, for post exploitation. In the end, I'm going to share an article with you guys that explains also the post exploitation. But I also discussed not much literature I can find. A lot of resource on, it seems there's a lot of resource on exploitation, not much literature I can find. You're right. There are a few books who were really good at the time. The Shell Coders Handbook. 1 second. I don't know if you guys have ever seen this book, but this is was called the Bible of the hackers at the time that I was reading this book. But it's the Mobile Hackers Handbook, but I'm talking about the Shell Coders Handbook, which is there. Also. But keep in mind that most stuff are not relevant anymore that are in here. Of course, the basics are still relevant. And at this time, I don't know when this was, but this is quite an old book now. But at that time, it talked about all the cool bypasses and stuff. So it's very cool to read this book. If you're interested, the Shell Coders Handbook is one of my favorite books ever in exploit dev. All new stuff, though, are here. So if you are interested in new things, but yeah, somewhere you need to have the basics, and you learned some of the basics today, some of the basics and the advanced part, because the bypassing of ASLR and doing this whole dynamic exploitation is not an easy thing. Okay. I think most of us are done. Let's continue, or else we will not be able to finish it. And now we will calculate. This one is much easier to do. So this part we did. Now we will calculate the libc base. As we discussed earlier, we just subtract the values from each other. Since you have already the output, you can use this leaked libc address that you already leaked. Use the calculation here. Then use VMMap, the output from VMMap, to subtract those two from each other, and that will give you the offset. You remember we discussed the calculation in a very simplified way. If I showed you directly this way, it would have been a bit abstract a little bit. So therefore I showed the image. We're just subtracting the distance that will give the offset for us. Now, since we have the offset already, we can open our code, create another variable, which is called libc base. We use the leaked offset as a value here. We subtract it dynamically here from the leaked libc that we already received, right? And by the way, there's a little, this could have been done better, but still it doesn't matter. Yeah, you can see here, we are subtracting, we're converting the leaked libc value, which comes, because it's a string that we receive, we convert it into an integer and saying that it is a hexadecimal value, that we are converting into an integer. Then we can do calculations on it. We'll subtract leaked libc offset, which we calculated ourselves, right? We know that the distance is always static, that won't change. And therefore, when you subtract those two, you will get to the libc base, and we'll save that as a variable because now we hold the pointer to the beginning of libc. And this is also how the computer works, right? It calculates the base, and when it has the base, it can move around based on the thing. It works with offsets, computer itself. You can try this out yourself. It's quite simple. This slide shows it. I'm going to send you again the lab numbers to do this. And that's called calculating libc. So it's in the chat. It's also in the chat. So I'll show it also to you guys. It's not difficult. You already have run most of those commands in the screen. And if I'm correct, you have here an output that says leaked libc address. You can copy that address, put it into your calculator. Subtract the libc base from it to get the offset. I have run it already over here somewhere. Right, I've run a couple of times, so I can copy that over here. And that should give me the offset or the distance between those two. And that's exactly this value. And that should be the same for you. And you can see in the slides that it shows the exact, the same value, leaked libc. Okay, so I'm going to copy it in also because I saw I missed it. Does this make sense? I also missed another one. So if you want me to explain the code, then I can explain it a little bit more in detail, right? So these first two, make sure that we leak two addresses. One, we leak the leak stack address and we capture it in our code as a variable because we want to do calculations on it. Second of all, we leak the libc address. Or some libc address, it doesn't matter as long as we leak some address which is consistently leaking at that position. After that, we save that also in leak libc. Then we convert them into integers, right? By using this integer function, because they come as string, right? We receive them as strings. After that, we can do calculations because we calculated the offs or the distances between them. So to reach from the leaked stack top, from the leaked stack address to the stack top, you can subtract the distance from the leaked stack. And you do the same trick with the leaked libc address. You subtract this distance and that should bring you back to the libc base. And if everything is correct, you should have a running exploit. Remember, as we already discussed, kill the application, restart it back up again before you test it. That should give you more, that should be giving you more better results because the address of libc is changing there if you run it a couple of times. I'll test it out. And in my case, I calculated everything. And if I take this value and check over here if it's really the libc base, I think it is right. So we calculated the base. Lower the hands and then ask all of you again to do after that to do. Just let me know when you're done by raising your hands. In the meantime, I'm going to take time. Cool. I'll give you 5 minutes to calculate and add the code in there. This should be done fairly easy. It's the same calculation. So you subtract the leaked address that you leak from your output. That's the leaked libc address. You copy that, get to your calculator, and then subtract this value from the leaked address. That should give you the distance between those two. Then with that, we can subtract the distance from the leaked address, and that should bring us to the base. And that you can see in the exploit. And we do all of this just to get variables that can be used later, or to reference data that is on the stack, or to call functions that are in libc address. You're gonna need them for sure. There is no option. If you want to execute any code that is any function that's in libc, you would need to know the target's base address, or you don't exactly need the base address, right? Because if you leak an address, you can also use that point as your relative calculation, right? That's also sometimes done in ARM assembly language. They use the PC relative calculation, where they use PC value to calculate distances, for example. Sometimes I feel like ARM language is the perfect language for hackers, actually, because it looks a bit the stuff that we do. Yeah, in the end, we are just programming, right? In this case, we're just programming some malicious thing. What do you guys think about taking a small break before continuing? Like a short break, short little break to get our heads started before we continue. Cool, I see a few people. Break sounds good. Yeah, I think also will keep us better concentrated. And we are already done with calculating those addresses. That's part. And we run it, we test it out, it's done. That part is done. Oh, you mean if we can finish everything? Matt?
I was curious if you think we'll run to the end or if we'll finish early.
I think we will not have enough time to finish everything. That's what I think, to be honest. I'll try to finish it, but I'm a bit scared that we will run into some time problem. Why do you need to leave early, Matt?
Potentially. Yeah.
Yeah, no problem. But I think this part will, this part of the whole exploit, I think will be done in a couple of, I think in an hour or so we'll be done with the first exploit. And then the second one is again, will take a little bit more time.
Got it.
But also for you, Matt, if you have any questions later, you can go through the slides. If you have any questions, feel free to contact me anytime, any moment, no problem. Just keep in mind that I'm in Amsterdam, right, or in Netherlands, so I will not be able to answer it. What's the best way to contact me? I think use the Slack channel will be the quickest way. I'm on LinkedIn also. I don't use Twitter and all that stuff, just LinkedIn, because there are the recruiters, right? But I'm just using only LinkedIn here. Just contact me over here and I can send you guys my email address. I think you guys have my email address, right? Yeah, no problem. I mean, I can understand that. Since we are working at home, they always ask us to do more stuff, I noticed. I don't know if you guys have the same thing. My wife all of the sudden thinks I will do everything while I'm at home. No, it doesn't work like that. I'm still working, right?
Very true.
But I understand you, Matt, so no worries. Go ahead, do whatever is needed. And feel free to contact me. Oh yeah, we were discussing also with the previous class. We noticed that a lot of people liked the fuzzing classes a lot. We want to create afterwards one session, maybe a couple of hours to do show more examples and do fuzzing together. If you guys are interested, you will see later. We'll put you in the community chat and send the link, Zoom link, so you can join and do some fuzzing. Okay, guys, let's take a break. 10 minutes break, and we'll come back. Yeah. All right, I'll come back in 10 minutes. So I'll type it in here, 10 minutes, 10 minutes. Does anyone has a question before we continue? If you already came back, for example, and would like to know something before we continue. Also, yeah, I think someone just asked me, yeah, I heard someone. Any question?
Yeah, but I just was really still trying to catch up on when we're calculating the offset. Like the math itself makes sense, but
Mhm.
the how we know in advance which pointers to look at to because that offset should be, I mean, it's obviously consistent for the entire library, right? Every instruction in the library is going to be at the same offset from the base.
Yeah.
So is it just to calculate the base so that we can figure out other offsets within the base library?
Yeah. So look, when I will show my, we will come there in a minute, but I will show you to explain already. So now that we have the base address, right? We just, and if we want to execute any function, we just need to find. You will, for example, right? We use dropper. Let's use dropper as an example, because dropper don't values for us. I'm going to show system lib, and when we run dropper against it, against libc.so, you'll see we'll print those instructions, and I said we will use those pops right later. You see here the offset. So if you now want to execute this piece of code, you'll just add this to your variable. So for example, if this is our gadget that we would like to use in our exploit, now since I have libc base, I can do this libc base, or for example, gadget 1 is libc base plus that offset that will be now pointing to this address. And when we pass the execution later to the application, that will start executing this gadget for us. Now,
because the offset is consistent across every computer that has this particular library available.
Yeah,
the base is different on each one.
Not really. The base will also, so all those addresses will be the same, right? But the only thing that is changing is the address randomization that will change. Therefore, the offsets are always the same.
Right. The offset is the same, but the base will be different on your machine, my machine, right? Because
indeed, because those first 4 bytes will be first 2 bytes will be constantly be randomized.
Okay, thank you.
Okay, I think we can continue. Can you guys raise your hand if you're back? Cool, everyone is back. Few people do not respond anymore. I think they are busy with something else or something else, I don't know. But yeah, I'm used to it because during trainings that are online, we see this a lot actually, so no problem. Also, the people are, or recording or something else to check it later. If you record it, please do not share it with anyone. We have put a lot of effort into it. Please do not share it. And also, guys, me personally, I'm also joining a lot of trainings. Of course, there's a lot of things to learn. I'm joining trainings myself. Usually, when I join trainings, in the end of the day, there's so much information coming. It feels like, how do I remember everything? But when you are busy yourself, in the end, you will see all these puzzle pieces, at least for me, that's always the case. Later, they fall into their correct place. So you guys, your machine crashed, right? But also my VM crashed. Right? So start it up, virtual box. And while that boots up, I'll continue with the slides. Okay, we calculate the libc base, and we were able to now bypass ASLR. In the end, now we bypass ASLR because now we found the base address dynamically calculated. If I use this exploit against your VM, if this was a real phone and I use it against your phone from a distance, that would always give me the correct output, the same one. And also to your neighbor who used the same phone with the same version, etc. Right? The only thing, Andy, is that if there is a patch or an update done in that library or one of the libraries that is in front of it, that can change the offset, because it makes sense, right? There's more code add to it, and that will shift other pieces up and down.
Yep, that makes sense.
Yes, indeed. So now we exploited the memory leaks, but we never looked at how we can actually now exploit the buffer overflow. That is also in here. So we are going to exploit 2 bugs in the end to achieve full code execution. First, let's discuss the return to function one. Because if you open this library in Ghidra, in the symbol tree, you can see that there are more exports, and one of the exports specifically is there for this example that says print log. If we override PC with a function address, for example, print log, we will be able to execute that function without any problem. Even if there was a protection or anything over there, we will be able to do that. So what we haven't shown actually, but we disabled by on purpose on this one, is the stack cookie. Normally, when you override a piece of data, there will be a stack value saved. It's also on the stack, a simple value that is always at the fixed location underneath the buffers, the local variables that you override. And that is how the processor will check if something has been overwritten, yes or no. Because if the function before it ends, there's a function called stack check fail that will check if that value has been changed. As you know, we can already leak arbitrary anything on the stack. Leaking that value is a piece of cake, right? We just removed it because there are too many steps to achieve it in the end. And that's very easy to leak because now you can arbitrarily leak. You can just search for that exact position where that stack cookie is, add that piece to your code before you override. So I will, after the course, send you guys one that has the stack protector enabled as well. But stack protector is very easy to bypass when you have an arbitrary leak vulnerability. In the end, it's the steps that we did. But we disabled it to make it a bit easier for everyone. In this case, it's we will just overflow right now. Okay, let's keep it simple. So if you open this libnative lib.so, which is coming out of that library, you will see that there is in the export table, there's a print log. And when you can analyze it and find it, an interesting function, but in this case, we will just use print log. You can observe that this function does not need any arguments. So therefore, it's very easy to execute this one. You just make sure that PC points to this address because we don't have to set anything. So it should automatically execute this function for us. So how do we do that? You just use, in your debugger, you can use the print, right? As you remember, we discussed you can print against a function. So you can use that, do p print log, and that should give you the address of print log. Very simple. So remember, if you want an address of a function, you use p print log or the function name, or you can type in the whole thing like print, and then the function name that should give you this output. Now we also need to find the exact amount of bytes that override the PC value, right? We can send 1,000 bytes, or we can send 2,000 bytes, but eventually at some point in some value, this will override the LR value, which is on the stack, and that will be popped later into PC. For that, Geth has a nice feature that's called pattern create, that will create a large string for you. And this is a typical thing we use in exploit that, is that we create a random string and then add a piece of code into our exploit that can override. So we create a variable that contains that string and then send that to our target while the debugger is attached to it. That will trigger the buffer overflow. You can see the whole stack has been overwritten with those random values, right? And also we see that PC has been overwritten with a weird value called DAAC. This value can be again used. And you can also see, right, I'm saying that in my slide, that you can see that PC points to that address and it says it cannot disassemble from that address because it doesn't point to anything, right? That 63, 61, 61, 64, that address is not mapped, so it doesn't know what to do. It says, hey, I don't know what to do, what to execute here. Now we need to find the exact offset, so you can use that value that is now overwritten, the PC value, with again pattern command in Geth, and now you use pattern offset and give that value to it. And that should give you the correct of this correct amount of data that you need to use to overflow until you get to the PC value. So after 202, you can add 4 bytes, and that will be the 4 bytes that will override the PC register. You can add that into your code, and that should give you the, you can see that 42, 42. So we changed it right now. We know that 212 was the amount of byte to override it. We create a variable called PC. Now we add the overflow plus PC next to each other as a string, exploit string, and send it to the target. If you run that again in your debugger, you will observe that now you have overwritten 4242. Since 4242 address is mapped, it will show you that the execution got redirected there. But for now, it's very important. It's just important for you that you know the exact value and that you get control over PC. And then you can modify your exploit. And we'll do that in after that, because after you get this override address, now we can start adding the print log address in here. So we got the address of print log earlier, right? But since this system runs as a little endian, and that is little endian and big endian means the way the processor is interpreting the memory. If it starts from the most significant byte or the least significant byte to start interpreting the memory. So, or from right to left or from left to right, like Arabic or Western. Yeah. So that is the difference. And we reverse it because it's a little endian. So instead of passing this whole value, we just reverse it by adding it little by little, reversed into it. Let me see, because in the labs I have divided this, I guess, into multiple different. One second. Yeah. So we will do now. When we go back, we will do it until here. Okay. So I'm going to send it into the channel again, and then I will do it myself to show it. This is the lab. We will use pattern create to find the correct offset. So let me show that to you guys, how you exactly do that. So first we exploited the memory leak bug with the %x, but we also know if you send a lot of data to it, it will overwrite the PC value. That's the second bug in this application. And that happens a lot, right? There are multiple bugs that we chain together to achieve what we really want to do. So I need to do ADB connect. And much faster than yesterday, right? I'm starting up the application. I take my words back. Setting the sysroot. It has been brought to the front. It doesn't matter now in this case because now the memory leaking part has been done. We just need to flash the application. So, ADB. You don't have to do all this stuff because my machine got rebooted, right? I see someone new in the class, Jonathan. Hello, Jonathan Ford.
Yes.
Hi. You were in the call, right? Before or not?
Yes, it dropped out.
Ah, okay. Okay. Cool. That's 8.8.4.2 to kill it. Start the application back up again. Okay, we will attach our debugger to it. GDB server 5045 attached to our process PID of print example dot my native test. Like this, we have the debugger attached. Let's connect to it. And in my slides, I'm using pattern create. So pattern create. That will create this large string for me. I'll copy that over to my exploit. Now we'll create here a new string called overflow is, and then add that string in there. You will have it now. Now you can use s.send and send that to your target. Now come back to your debugger, continue the process, save your exploit, and do Python exploit leak. Connection refused. And that's because my machine started up again. Now it got open, and we send it. It should have been crashing the application. You saw that already, segmentation fault, and we are now identifying the value, the exact value that is the exact amount of data that we have to send to override. Therefore, we use pattern offset to send and give the value of PC. Look, if you want to get the distance to overwrite R7, you would use the distance here. So I will show that in a minute, but here. In this case, it's the distance is 200 to 12. And if you were exploiting and you would need to overwrite R7, we would have used pattern offset. That should give you another offset. So we know that, for example, if we knew that the stack cookie was there, then we would have now the value, the distance to the stack value, and add that to our string. But forget about that now. You just need to do this part, right? To find out the exact value. After you have the exact value, which is the same for all of you, we can now change this overflow to overflow is just junk data that we send to it until we overwrite that value. And that's 212. I created this extra value called PC, and that is called 4 times B, which is the which will be 42, 42, 42 when we send it. Now we'll call this exploit is overflow plus PC. And it's a little easy for you guys. It's sending it to that's in the Zoom chat. I will also send it in the Slack one. Or if anyone needs it, because I saw it's not in the slides. So I'll save this one. Now we know, look, now you crashed the application because you have overwritten. There's a segmentation fault. You can try continue whatever you want, but you crashed the application. So it's better to exit it. And if you search now for this application, you see it's not running anymore because it got crashed. We made it crash. So I will start it up again to verify if we have overwritten the PC value with the correct value. Attach my debugger to it. Now continuing the process and sending the exploit. We attach the debugger to see what value, is it correct, what we have put into our exploit. So just let it run and then observe what is going on. You saw there is a segmentation fault and we see we have overwritten PC exactly with the value that we want. Now we can redirect the execution anywhere we want. Because PC points to the next to be executed next to the value that the address of the instruction that is going to be executed in the next step of the processor. We now control that value, so we can say to the processor, you know what, you now jump to another place to execute. So we can redirect it. You guys can try this out, and in the meantime, I will be here to ask to answer questions. And I don't know who asked the question about. I can't remember it anymore, but someone asked about the post exploitation. Who was that? Let me see in the chat. Someone of you asked about post exploitation. But in the beginning, we discussed about the post exploitation, right? In the very beginning, I said, when you get the chance to get into an application, we will do that. You will get into a shell eventually, but your shell will be in a user ID of the app. So you are in the sandbox. That means you need to break out of it. That's the post exploitation step that you do. And what you do there is run several exploits that are for that specific phone. And in the case of Pegasus malware, to just name one, they use, for example, the from a root exploits. For the ones who don't know what from a root is, from a root has this one-click root in there. And yesterday we were looking at from a root, and from a root contains a list of exploits for multiple phones to root them, right? So if you pull them out or you convert from a root, because from a root has a library, and if you can drop that library there and execute from a root there, you will be able to get root. Just a simple one to explain how you would do post exploitation, for example, that will be able to run a certain exploit for you. But yeah, in the case of Pegasus, that was the case. So they just used from a root. Funny enough. It makes sense, right? It contains a set of exploits that do privilege escalation. I don't know the details of how much they have modified it, but in general, if the exploits work for the newer versions, most probably they used some other parts. So, as I explained, from a root contains multiple exploits in him. But if you analyze from a root yourself, you will see that from a root is an app, right? That you install on your mobile phone, and you click on it, and it will do one-click root for you. If you open this app APK file and you go to the lib folder, as we did, you will see that there is a lib folder that has an interface that called launch. If you get the correct input, if you know the correct values that you have to insert there, you can use from a root to let him do for you the rooting of the device, and then you will also escape the sandbox. And that's in the end, now you rooted the phone. But you know, I also explained that if you change some stuff in some of those system directories, you might get into a problem that the system won't boot up anymore because it's corrupted. And typically, what you do during post exploitation, they will add SU and a few other binaries into the application, right, or an implant, and that will modify the because you are writing some of those stuff in the system library, right, in the system directory, and that it will be checked by DM Verity when boot up. If those because it will hash it, right, makes sense. You will just hash the whole file system there. If it doesn't make sense, that means that it's like on Windows, for example. If you would, if you do a signature, if you do, for example, a cryptographic hashing on the whole directory, and you save that in the secure enclave or the trusted execution environment, right? There are those chips which contain where the developers or the vendor of a device can save keys in there or values that you can later check with DM Verity if they are correct or not. You will be able to identify that the file system have been modified. And on Windows, for example, where do system apps store user data then? Is there a reason we can't drop SU there? Where do system apps store their data? They are also run under the /system directory. I'm not an expert in post-exploitation part, by the way, so that's, let me put that up front. So here we show. Oh yeah, one thing, the system apps that you see here are just the installed ones, right? So the data is not there. Data is at data. I think it's system, yeah. And these are saved over here. Some of them are not here. But anyways, the data is not saved over in those directly over here. There's no modification that will be done in the system folder. As I said, right, the system itself is not, look, also our application, when we run it, it will be at data/app. And here, the data of the running app will be saved. So in the case of that as well, it will be over here that the apps will save their data. So you can go to com.sample. There will be files aware and also in the sandbox of the application. But system apps are a bit different than the normal apps. Okay, let's continue, or we cannot. I went into everything else. Sorry for that. But if I'm correct, you guys were able to do this. Anyone had an issue with doing that? Because now we will do the next phase, because now you were able to override it with the values you want. But we can now change that PC value to the address of print log. How do we do that? In your debugger, if it's still open, you can do p print log. That will get you the address of print log. You can now copy that address, go to your exploit, that's a comment, by the way, in Python. So I'll just reverse it, and I'm going to ask you guys what will be the problem if you do it in this way. Can anyone?
You switched it to little endian, but you still need to add one for the thumb mode, right?
Yes, that's one thing. And is there something else what might cause an issue if you do this in this way? Who was speaking just minutes ago, by the way? I couldn't see it.
It was Andy.
Hi, Andy. Hi. Yes, the +1 indeed. That's one thing, because it's this code executes in temp mode, and we will enter temp mode by adding +1 to it. I explained it at the beginning, but one thing that we are doing over here is hard coding this address. So for me, this address is different than for you. So in this case, we have not leaked the address where this library belongs to, and do not get. I need to explain one thing. I don't know if I've explained it, but if you bypass ASLR, you only bypass ASLR for a certain library. You did not bypass ASLR for the entire system. That's not true. You cannot move from that library and use that offset to move into an agented library that is also loaded into memory. That doesn't work, because the distances between the libraries are also randomized.
So you need to calculate the offset and the base of the library that contains print log. And
indeed, if you want to do that in that way, then you need to find again, you would do, for example, what we can do is this, right? If you would want to do it perfectly, then you would do this and find where it belongs to. We will find again this first 3 bytes, print this stack, and see if we can find an address which is in this range. And then again do the same calculations. Then we will have bypassed ASLR for this library also. So now we can call any function in that library. And this is the same trick everywhere. Makes sense, right? The only difference is that we cannot move from one library into another one with calculating, because the randomization between the libraries is there as well. Although I can tell you one thing, the guys from Project Zero have done a research, and they found out that the randomization between those things are not real. I cannot explain it in detail because I just read it, went through it, right? I understand that the part that the randomization was not good enough, and they were able to bypass without leaking anything, because they could calculate by constantly. never mind, I'm not even go into that. But the thing is, they were able to bypass it without leaking because the randomization was not good enough between the libraries. So with that, they would able to find out the distances between the libraries and automatically find the locations of other libraries. It's pretty cool techniques. Let's go back to the slide. Now, if you do this, right, and you add a +1 to it here, that's because we want to switch over to thumb mode. You can now run ADB logcat in another terminal. And if you run your exploit, you should see this in the logcat. So let me show that to you guys. We can quit this, no problem. Let's see if it runs. Yeah, let's kill it quickly. You don't have to kill it because the override will. Anyways, it got killed. Okay. No, we don't have to attach the debugger, by the way. So I will just not do it because we don't have to check it, right? We create our exploit, so now we can do ADB logcat and do grep 1. And if we run our exploit, if I have not made a mistake, it should take a little bit of time because of ADB logcat, or something went terribly wrong in my exploit. So as you see, we executed, we redirected the application to somewhere else, and we were able to execute another function within the binary. So this would also be almost the case in the WhatsApp one, but there you need to set a parameter. After this lab that we do, you will be also setting variables and call arbitrary functions in libc. So try this out. I'll send the lab 1. Did you guys do it already? I think some of you already did it, or not? I'm happy to hear that. So this time I won't forget to take the timer. I'm gonna take 10 minutes of timer, right? But if we are done quicker, just raise your hand there and leave it raised so we can see who's done it or not. Lindsay, you're amazing. You already done it. And Andy, you are also quite close. You are done already or not? No. Okay, let's see. Yeah, with some of you have already have experience in exploiting x86 64 or x86 processors, right? No worries, I won't tell anyone. So if you're good at that, that's nice. But in x86 or all the processor is the same, right? You try to get the control over the PC counter, the PC register, and in the x86 64 world, that is called the RIP or the EIP. And that's the same technique here. There is no difference, and it's with every system. I think if you open your wash machine and the processor in there will behave the same, right? And by the way, feel free to redirect that because you're done already. Feel free to redirect it to somewhere else just to try it out. Change it, go to your debugger and print another one, which doesn't require some input, just to call it, just for the fun of it, see what it does, what the system does. Typically in real world situation, you would also like to know to bring the application into the correct state back again, so that during an attack, it's not, nothing weird happens, for example. They will see if the application crashes and stuff, weird things happen that will get detected. So in some cases, you would like to build your exploit and return back into an original piece of code, or even restore the registers at their original state and then come back. That is a possible way you would do this. Oh, I see something here. Ashley, pop gadget libc. I'd say I have very honest experience. No, this has been very insightful. What are you doing? You already exploited. Whoops, copy too much. So what do you want to know, Ashley, about this part?
I was trying to say that I have had like somewhat basic experience, but I appear to have pasted quite too much. It was just something on my clipboard, I guess.
Oh, okay. So you have experience in x86, you mean, right?
I took a course in x64 a little bit, just like an online video course.
Oh, nice. And which course was that?
I can't remember the name, but it was from Pentester Academy.
Ah, okay, cool. And that was based on x86 Windows Linux, right? So,
x64 Linux, yeah.
x64, sorry, I always do that because in Dutch we say the opposite.
Oh, interesting.
Yeah, well, we use it the opposite. It's very weird. Yeah, that's pretty cool. It's almost the same sort of stuff, right? Only in the ROP gadgets that we will use there, you will see the difference. Did you also use ROP gadgets and stuff there?
For what I can remember, very little.
Yeah, because you have to bypass, or for x86 64, you will have to do that. It's almost the same as here. There you will have to set the RDI register, and what else? The RDI. I can remember from my head, but the first value is being done in RDI. I can't remember, but at least I know the first one is RDI that you have to set. So you will use a gadget again to pop into RDI and into the RIP. Okay, this part is done. Let's continue with the rest. Now we know how to execute, how to do one call, right? One function call. But if we want to do, if we want to call something with arguments, then we need to do some other techniques. That means we need to use a technique called, I'm lowering the hands quickly. We need to we need to use a technique called ROP chaining. As I said, ROP chaining is nothing more than chaining multiple pieces of code which are already loaded into memory by the application itself, and we'll reuse them together. So we can use gadgets, we can use so-called gadgets that can set register for us to values that we would like to. And if you look at the gadget that we see over here, right, that does a pop, and as you already learned in the previous class, the pop will set those values to the popping them one by one into those registers. So this will pop 4 values in there, but it also pops the next to be executing. So we can, after this is being executed, we will be able to redirect it because we again control PC over here. So we can place data on the stack and then execute our gadget to fill in our required registers, and then pop PC also from the stack and execute another call. And that's it. And if you do this multiple times after each other, that's called a ROP chain. If you do it once and execute a one function, that's called return to libc. In the past, it had no name. We were just doing this attacks. Before the return to libc came, we were doing that already, and later the thing got a name. Return to libc. But anyways, if you look at this operation, right, I already explained, when you do the pop, it will pop this first one into R0, and respectively doing that with the other ones. So since we also can pop a value again into PC, we can now execute another gadget. And little by little, achieve what we want to do. So if we want to execute a command, for example, we would like to obviously call system, right? And system requires a command, a pointer to a command. So it needs to point. I already explained that, and that's what we need to do. And it only requires one argument. Let's start simple. This one has only one argument, and that makes it easy to execute. So how do we do that? Since it requires the address that points to the systems, our command, we will need to get the address, and therefore we can use the stack address that we calculated to find the correct location on the stack to our arguments that we want to pass into. And that address will be placed as R0. That address is again pointing to this start, right? So if you execute this one gadget that says pop R0 and pop PC, what it will do, it will pop address of command into R0, which points to our real command. And that will pop PC, and we will put the address of system underneath it and redirect to system. That makes sense, right? We control it. Any questions about this? Just ask anything, no problem. I'll try to answer it. Okay. If you understand it, then there's no problem. I think it explains it there as well. And we can combine all the knowledge that we have, right, and execute the return to libc attack that we just saw. So we will use Wropper to dump gadgets. Now you know how to do it, right? So I will ask you guys to do it. Then look for a gadget that has a pop R0 PC in there. You can see this is the offset. And now we can use that offset since we are running this against libc and we have the base of libc. We can just add this offset to it. In the beginning, I discussed, right, these things on the left side are the offset. Now you see that in action. Now, how does our export string will look like? This is how it will look like. We have the overflowing of 212 bytes. Then we have a pop gadget, right? The first execution will be, so PC will be overwritten with our first gadget. That will then pop the address of command into R0 and into PC the address of system. Do you understand this concept that I'm explaining? If not, just let me know, okay, in between. So we can test this out, right, before we even execute anything. I have put the piece of code over here for you guys to test it out easily. So you can do it yourself and put the breakpoint in there. And I will continue the slides, but I'll send you guys the lab part also. So if you do this as it shows here, right? So we create a new variable called pop gadget, and I explained it to Andy just a minute ago before we really started. That now we can do libc base plus that offset, and we'll create a pointer to our pop gadget. And now we can add it here. And we use struct the pack to not do it manually, that reversing that we did into little endian, but there is this struct the pack function that will do that for us, change it into a little endian as a little endian for us. And now I do on purpose the system args as AAA BBB. Why? Because we want to see in the debugger the action. If you go and execute this command, right, you will see when you hit and you put a breakpoint into that gadget, And when that gadget gets hit, you don't even have to put the gadget because it will crash in the end, since 42 doesn't point to anything. But note one thing, that the stack now contains 4141 as we wanted, and 4242. So those were those values that we set for system arg and system. Now, when this pop will execute, first R0 will put this first one into R0. I explained already, and into PC. But since the processor already wants to check what he's going to execute, he already says, you know, after this, I will jump into 4242. So you know that will happen. Therefore, you know, you see my slides, so you should be able to use them without me helping you later. You can see it points to our gadget, and that's after execution. You will see PC points to whatever we want, and R0 also. So we set the register value. And now when we continue, you can see that happens. So can I ask you guys to do this part, to analyze it yourself, to understand what is going on? And then we will build the exploit and finish this exploit. And I'm going to do it on the screen also. We are almost done with this exploit. And we had a break actually at 1, but I suggest we continue a little bit until we finish this part. Oh, sorry, I sent it only to Andy now. Excellent. Here you go, guys. Execute from 102 till 111 so that you can see this in action yourself. In the meantime, I will do this myself to show it. So from here, you need to execute the robber to get the correct gadget. Let's go to robber. We were executing that one already. Here somewhere. Okay. I will go to my desktop. And on desktop, we had the GDB folder, right? The GDB sysroot folder that already has the folder in there. Lib. Now I can reuse dropper against it. Dropper, the file, and we want to look in libc. I'll execute it for everything, right? Just as a sample. Now I see here this gadget, which is the exact gadget that we would like to use. Copy this in. You guys can use the code. I think I had a piece of code there. Yeah. So you could copy the code in. I will do that also. In the end, remove this part out of it. Oh, you can look, guys, if you copy it in, look at my screen. If you copy it, you see that there is this little thing that has changed. So you'll see, I just noticed it. It has been changed. So you need to make it a double quote actually yourself. Just send it also to the chat. This is the correct thing you need to add to your code. So let's now run this. Start up a new application. You need to start a fresh one because it will calculate the addresses now. And for this, you need to have the correct calculated address. Now, okay, remote 5045 and continue the process without anything else. So now when I run it, oh, I also removed overflow. I had the same thing from you, right, yesterday. Remove the So I'm sending you guys the correct code, right? Here, if you add this part to it, I'll also send it in the Zoom chat. So this is the piece of code. So what we did is create a new variable and add it here. Oh, sorry. Again, there is a before you paste in anything, please wait. I'm sending the correct one over the chat to you guys. So this is the correct one that you need to use. So this is the correct one, okay? Because sorry guys, so but here is the correct code. Yeah, just don't copy the correct code part of it, right? It's from, if you copy it in, right, from Zoom or anything, do not copy this correct code. That doesn't belong there. Just copy this part in. Attachment debugger. Debugger is attached. I'll continue. I made a little mistake right in the code, so that's why we need to send it again. So now I'll send it. It got sent. Everything should be correct. We get a segmentation fault, and this is the end result that you will see. We overwritten with the correct values, and R0 is set to anything we want. Any questions about this part? Right, so give this a try. Well, if you're done, raise your hand so we can continue if needed. I'm going to take a timer so that we can. Nice. So let's give the other ones also a chance to finish. I send the code to you guys so you can add it into, just copy paste it in there. The idea is to understand what is going on. And we just pop the values that are on the stack into the register and into PC. That is what happened using this first gadget. you guys. The timer is going on, so I'll wait for the other ones to finish. Yes. Is anyone facing issue also with this system still? Are we still rebooting on machines and stuff? Also, you can try the same exercise on your phone, right? Install it on the phone and you can do the same stuff. Just make sure, you know, you're still stuck. Okay. What's going on now, Shatika? Where are you stuck now? Which your machine is getting stuck? Okay, nice. I'm sorry. I wish I could make it work for you. I thought that Praveen was busy with helping you actually. Oh, okay, sorry. I'm now answering Matt instead of Sophia. Because I spoke with Praveen and he was helping with the issue. I'm not able to get the AD, so yeah, he's still helping me. Okay, I will. I'm gonna, guys, give me a couple of seconds. I called rebooted the Android again. Yeah, please make sure you don't do wipe data, because if you do wipe data, it's gonna remove the app. That might be the issue there. Then, if I'm correct, because we did the installing part, right? You just go to CD. I think Praveen already is doing that. When you pulled when you did the update script, it created this app.apk, appdebug.apk in the temp folder, and that one you can reinstall again. That should work. Guys, we missed a break. Would you guys like to do a break before we continue? Or finish the last part and then go to break? Yeah, right. Let's do a break, because or else, you know, it's a long day. Our heads get fried. Yeah, yeah, I could use a reset law. Okay, let's do that. And then come back. Is 10 minutes okay? Cool. Then we'll come back in 10 minutes, yeah? All right, guys, see you in 10 minutes. Bye. All right, I see everyone is back, or these were the hands of that you finished the lab. Awesome. Cool. I see more hands getting raised. So let's continue, or we will not be able to finish everything. Okay. Let's at least make sure that we have one exploit that will fully work now. Then the other one will be, we can actually build that one a bit faster. So we control the, we did this part. We notice that we have overwritten. Now we know that we need to find the distance, right? I'll save that for you to speed up a little bit. So the distance between your arguments that will be available on the stack have an offset of plus 40 on the leak stack top. Okay, so if you copy this piece of code in there.
Sorry, Amit, are you sharing your?
We can't.
Oh, sorry. Oh, no. You gotta be kidding me, no? I'll come back. So we discussed about, we had the control over the PC value right now and the argument. So if we want to set the argument to point to our, for example, mkdir command that will create a directory hacking, for example, then we would need to have the address of that, where that string is. So how do we do that? We know that, you know, I'll spare you for now calculating again the distances, etc. But it's very simple. It's again, you dump the stack and find where the beginning of your argument, where your command starts, right? Because that will also be written on the stack. If you do x/100x, you will see your command there, and then you calculate the distance against the stack top, and you will see that it is 40 bytes further during the crash. Okay. Just for now, to keep it a bit simpler, I'm going to skip over one part, okay? Because this will show that we will have the calculated correctly. Because if you add 40 to the base or the top of the stack, which was 18, it ended up 18. That will point during the crash to the top of the stack. If you want to calculate this later yourself, do it, please. But for now, we lost a bit time, so I will skip over that part if you guys don't mind, you know, so that we will be able to build the exploit. So you will be able to add this in a minute. 1 second. The other part that we need to know is the address of system. You can use p system again for that. That will give you the address of system, right? The address of system is different on your system than mine. Again, we do again the same calculation by subtracting those two from each other, get the offset between them, and the offset is exactly this. This is the same calculation, but now we find the offset from the base to system. If you after that, since we know the distance from the base till the libc base, you can now add libc base plus that offset, and system is executing in dump mode, so you need to add +1 to it. And how do you see if system is executing in dump mode? It's fairly simple. When you're in your debugger, you do disassembling of it. I hope my debugger is running. So p system you can do to get the address first. You copy this address, you do vm map libc.so. You get this address again, right? We need to find the distance. It's always the same sort of calculation, right? So we find the distance between those two, and we subtract it from the top or the base of libc. That will give us that value. We know that from the base if we add to the base this value, that will bring us to system. This is simple calculation, nothing special about it. And I wanted to show you guys so if we do this as system, you will see that system is executing in 2 bytes. As you remember, 2 bytes long instructions are temp mode, in temp mode. So therefore, we know that we have to add a +1 to it. So that is what we do. And if we modify our exploit containing this part, and here I show that as well, you should be able to add this part to your code and having system in there. Now I'll continue to the next part. I want to make sure that we are not skipping an essential part. So what I did here in the beginning, this part of code can be used, right? So you can copy that into your code. So just copy this whole thing in. If you go to your exploit code, it's already there, but you know, if you copy it in, it makes it that we are all on the same, on the same page together. So if you add this part to your code, then you should be already in the same steps that I am. So please make sure you copy from slide number 113 this code into your exploit. I'm trying to speed up a little bit if you guys don't mind, or else we will not be able to do these other parts. If you have an issue with that one, then please let me know. You know, if you think we should go over this detailed explanation, then I will do that. But for now, this part is not that important. We are just calculating the beginning of the arguments, and that are at leak stack top plus 40 will bring us to the beginning of our, this will be the pointer of the system arguments that we are passing in. That will be placed into register R0 when we pop it, because we are placing it here, right? The way I also earlier explained how the string would look. This is how it looks. So first the overflow, then our first gadget, which is this one that does the pop. Second is a system argument, which points to the leak stack plus 40. So it moves, it has a pointer to the beginning of our arguments. And system system address and the system args we didn't fill in yet, and the system address did not add it in there as well. So we're going to add those in there as well quickly. Do you guys understand what we do here? So we set an argument, we set a variable to the beginning of our arguments that will be placed on the stack in a minute. And we have placeholders here, which we will modify in a minute. And we can modify the system args later with by removing the C times 30 times C. That is just a placeholder for our command. And system will be replaced by the address of system. So if you have this in your code, you can now calculate the distance, right? Or the distance between the base and the system function. And when you have done that, you should be able to add this new piece of code also into your code. So I will do that, and copy it in, so you can do that as well. And that is at slide 120. Please copy this piece of code. And what we are going to do is add this code to this part. just underneath the previous system, so you can remove that one as well. So let me send it in the chat to you guys. So this is the code for that. Again, there is a little mistake, little thing that is missing over there. And we need to reverse the address of system as well. So I'll do that. So that means you need to use this code. This is, so the last message that I sent contains the correct code. I'll send it in the chat as well, in the Zoom. This is the exact correct code. And what did we do here? What did we do here? We calculated before the libc base earlier. We calculated distance, but what I showed in my slide, right? Previous to this slide. So we got the address of system. We did a VM map on Lissa system. We did the same calculation that gave us the offset. Nothing special about that part. Now we added our code to it. So in slide 122 contains the correct piece of code. And if you guys can add that part, I will start explaining the toy box thing that we will use to get the reverse shell. So we will use a binary which is on every phone, on every Android phone, that's called Toybox. And Toybox, for some of you might know it. If you don't know it, this is the same as BusyBox. And what is BusyBox and Toybox? These are embedded, these are used most of the time used in embedded devices because it contains all the Unix utilities, file utilities, shell utilities, etc. So it's just one binary that contains a lot of commands in there, like wget, nc, more, cat, all that stuff. Because if you run a call only a kernel, you won't have that utilities there. Normally, when you have a laptop, right, when you have an Ubuntu or any other Unix system running, most of the time you have it already installed, all these Unix utilities. But on an embedded device, it's not, you don't have those. So therefore, we use Toybox or BusyBox. We don't use it. Android uses it. So Android has Toybox on it. We're going to skip this testing part because I was going to show how, if you do a normal NC and get a shell from your device, you'll see it will execute a command when you execute it on the device, but you won't get the data back. So therefore, we will create, we'll use a one-liner, which is used most of the times during, if you have done a lot of pen tests, you will recognize this command. And we are just using the same one. We will remove if there's an old F file on that sandbox. And you see, we are writing in the sandbox of the application because we have write access there. And we create a file, a file with mkey FIFO, and that will create a file with the first in, first out in there. And we can use now cut to cut anything that is being written into F and pipe that into system/bin sh and redirect the input and output to us, and pipe again the output into the file. So what we will get is actually that this file will redirect input and output to us. So if you test that out yourself, and I suggest you do this, okay, to test it out. And what you need to do, which is important, is to modify this IP address because it contains my IP address. So I'm going to show you guys this, and you need to verify that this works for you. So you go to your base machine, and you go in here, then clear it. And for the Windows users, we have another command. Praveen, can you send the command in the chat? Oh, sorry, I made a mistake here. Praveen will send a command that can be used if you are on a Windows machine, but because you need to set up a listener. So you can use LV. In some of, if you are on Linux, then you will probably need LVP. If you're on Mac, you can use LV and listen to the port 444. Then you will have a listener. We're going to test out if everything works before we use it in our exploit, because if we use it in the exploit and it doesn't work, then we need to debug your exploit. So it's better to check here already. Oh shit. So go into your shell, the device shell, execute that command. And when you go back in here, you should be in the shell, receive the reverse shell. So test this out, okay? The idea is that you go to my slide number 132, copy this command in, make sure on your host machine you set up a listener, or you use the command that Praveen just pasted into our Praveen, can you also send it in the chat, in the other chat, or did you already?
Slack, I already did it.
Okay, cool, thank you. So you can, on Windows, you can use that command, the SOCAT command, to set up a listener, and on Linux, on Mac, you can use the NCLV, or use any netcat if you have ever used it. You know, I'm pretty sure some of you have already used. Test this payload out from the doing ADB shell, from the device we are doing, from the emulator we are doing this, right? To make sure that your phone will send a reverse shell to your listener. And you should be able to execute commands. You will be greeted with this generic shell thing. Text. If you're done with this and you have verified it, please raise your hand. I don't know, Matthew, did you already done it? Because I saw your hands raised. So when you're done, raise your hand, then we know that you're done. We can continue with adding everything to our exploit. Then you will be able to get a reverse shell, because the exploit is pretty much done now.
-n, NC-LVNP.
Wait, I will just type it LVP 444. That should work for you.
If VNP, it should work.
Yeah, so in training, you can use the Praveen's command there. That should be working for you. It was not up from before. Oh, you were done with the exercise method, right? So getting a reverse shell worked for you. The test reverse shell. Oh, okay. Wow, no, really? Wow, that sucks actually that you have to do it there. I can do something else for you guys. For the ones who cannot copy in, 1 second, I'm going to go to paste bin and create a small paste bin for you guys, which contains that whole command. You can just copy it in then, yeah? Create new paste. So if you open this link in your if you open this link in your what is called in your emulate on a VM, you can go to Pastebin and see a lot of spam first, a lot of advertisement, but you'll see my pasted in command there. You can copy it from there. Should be more easy to copy. And now Anonymous will hack me. So if you're done, raise your hand and just let us know that you're done. Cool. I'm gonna do a quick. Just, I'm happy. I'm just happy I typed it up and it ran the first time. Yeah. It's like writing a lot of piece of code and then it compiles without a problem. I always get happy also. Yeah, you know, guys, we lost a little bit of time at the beginning of the course, right? With the bugs that we had with the installation of the app. So therefore, we missed a little bit of we lost a little bit time because the previous session we did, we were exactly done at 3 o'clock or 3 o'clock our time, 6 o'clock your time. So if you are able to receive the reverse shell, that means your payload is good enough. And after verifying your payload, I will wait for the other ones to be ready. And then we can move. And again, if you have an issue, just let me know right now. I can support. So here you need to use your base machine IP address, not your VM, not your emulator, the Ubuntu emulators. So do not use your Ubuntu VM's IP address. This is your base machine's IP address. We will redirect it back because the VM is running in NAT mode. So you cannot send the shell back there. So change the IP address to your base machine. For the ones who are ready, I would say change your system arguments now to that value. You can add a 0 byte to at the end of it. That's not really needed, but you can do that. There are 2 spaces in the copied command. I resolved those and changed the IP, but I'm still getting connection refused from the netcat in the VM. No, that's the point. So you can't. Andy, you are on a MacBook, right? So open a terminal in your MacBook.
Yeah,
then
I have the terminal running on the host with netcat, but then in the long copied command, there's a toybox netcat, and that's where I'm getting connection refused.
Okay, so you have this running, right? So let's just be sure with everything. So on, like me, on the MacBook, you have your shell running.
I got it. Thank you.
Ah, it's working.
There
what
was another space inside. Yeah, it's okay.
I think because of copying, right? Maybe
Yeah.
that happened. Yeah. Yeah, it sucks that happens. But copy that correct one, because now we're going to use that one. So let's move on, guys, to the next one. So since in my slides, you can see what we are doing after we verified that we are getting the reverse shell, we can now modify our code, change the system arguments, which now holds those C's in there. You can change it to hold this, your payload, add the 0 byte at the end. You can also add it manually, but add the 0 byte there. And set up a new listener, make sure the application starts up new, freshly, and run your exploit and enjoy your shell. Give that a try, guys. And so that it means you do from slide number 34 till slide number 38. And I'll send it into the chat. I have it here. Just in Toybox and getting your shell. I will do it on the screen. So we have my command. I executed my command earlier. Just this command. Oh, one footnote, because we executed manually the command. Just to be sure, you know, just do it all, and then we'll see if there's an issue. But I think you will come into an issue, but let's see that in a minute. So I'm adding it here. I'll just remove the C's there, adding my shellcode to the, or my command to this thing. And we can do system args, system args. Just this is what I did. I'll save my exploit. I will kill this application. We started back up again. There's no debugger. You don't need to attach the debugger to it. You can do it without the debugger because exploit is now complete. We debugged it already. So my listener is listening. And when you now send Python exploit leak, everything has been sent. And hopefully you should get a shell. And as you see, I didn't get a shell. There's a reason, because we executed manually and there is something going wrong. So go to your ADB shell and do cp/data /data .com.example.mynative test. In there, if you do ls, you will see that F file was there, right? Remove the F. So do ADB shell, go to this spot, remove the F there. Yeah, I'm going to post the whole Python script in a minute to everyone, so you will have it. So I removed that the F file, and if I run my exploit against the fresh one, it crashed already. So you can just right away start it up. if you have run your exploit against it, it has crashed. Oh, strangely enough, it didn't crash. Okay. Wow, that was funny, it didn't crash. Okay, now it started up again. If I'm correct, my listener is still, oh, yeah, so my listener is listening. And when I run the exploit now against it, it should be 100% that I get a shot without a problem. Yeah. So this is your first exploit. Make sure you remove the F file. After that, you can run whenever you want without a problem, because we did this manual execution, right? That messed it up a little bit, but if you run it, if you start up the application after that, because the exploit is now ready, and if you restart the app every single time, you should be able to get a shell without a problem. Yes, yes, indeed. The app is in Sandbox, but look, I'm going to show you the screen, Matthew, what's going on over here. That's why we explained the Sandbox. Yeah, you're right. You're in the Sandbox. I think, Matthew, you also asked about the post-exploitation, right? You were the one who asked about it. That was the other man. I did. Okay. So I just explained a couple of minutes ago. I don't know if you were here, but during post-exploitation, for example, in the Pegasus one, they also used Frama root, and Frama root contains a lot of exploits in there. We can look at one, for example. Here is posted one. It contains a lot of those configured exploits, root exploits. And we have analyzed the Pegasus malware, and we saw that in Pegasus they actually use Frama root's exploits. That's interesting. It makes sense that I told it earlier, but you typically, so if you now have Frama root's exploits and you would run it in your sandbox, you would escape your sandbox and you would root the phone. But yeah, and with the modern phones, right, they always say if you reboot your phone, then there is no, the attacker will need to exploit again. That's true most of the time, or not most of the time. That can be the case because they don't write the implant into the file system somewhere, you know, they, or else it will be, in some cases, in some phones, it will trigger the DM Verity. There are ways to stop that one. I don't know how that works at some of those companies, but during post-exploitation, the other thing that I explained in the beginning is now you can, in your sandbox, you can do service. So let me show it, right? So I got into this, I didn't run my exploit yet. So I started a fresh application and run the exploit now. Come back, we dropped into a shell, and you notice we cannot do anything. But if you type in service list, you should get a list of the services. So there are things in the sandbox that you can do. You can also go still to cd/data/data and then to your own sandbox. Example, my native test. And in here, you can actually check everything. And note one thing, everything is in the user ID of and the process that we are running. TS that my native. Note the process is also running under the same ID as all these files. And I told you guys that the lib folder is read-write is not writable because it's owned by root. Some of you who have experience in pen testing, red team, etc., you will know that after this stage, it's now time to do privilege escalation. There's not much difference in the way, but you don't do it manually, right? Usually what you do So make sure that your first stage exploit runs. The second stage payload will be loaded in. That will do the privilege escalation, escape the sandbox, and then when you have root access, you will pull in files that will give access to the remote attacker. For example, install a piece of software that will be able to do a lot of cool stuff. For example, listen to the microphone and take screenshots, check where the device is, where the location is, etc. So yeah, this is your sandbox. There is also another directory which you can access, and that's the apps cd/data/app. When you come in there, you cannot do ls, but there is a folder in there as well that is called example.mynative test -1. Oh. You can get in that folder, and you can do ls there as well. But note something, that everything is running under system. And I already explained the last, someone asked, hey, but how do those files write and run their own data? And that is here, you can see also. So these are the stuff that you can access. You're now in your sandbox, and the next thing would be or run a kernel exploit that will give you more privilege escalation. But in the next version of this course, we're going to do sandbox escapes and do privilege escalation. And we are planning to use in the for people who are joining at the advanced course later. But we will do that. So we will use a real world vulnerability on an app, and then on a real app, the real vulnerability on a real existing app, get access to the device remotely, do privilege escalation using sandbox escape or a kernel exploitation, and get full chain exploit. Did you guys get the reverse shell using the exploit? And let me share the exploit to you guys. Cool. Did you guys like it, or was it too much to process? It's quite similar, right, to other exploitation. It's just a computer. Mobile phone is also a computer. There are these limitations here and there, those little things that you need to know. Mine is crashing, but no shell. F file also isn't getting created. Oh, that's interesting. Okay, that's quite interesting. If the F file is not getting created, that means there is something wrong in your exploit. So let me send my exploit to you guys, right? And that one should work for everyone. If it doesn't work, that means you probably have still the old app installed. Okay, here it comes. I send it into the Zoom or the Slack channel. Can you guys copy it from there? Is it possible, or download it? And again, change the IP address. Make sure that you change the IP address. That's very important, or else it won't work, right? So here you go. Here is the IP address. If you want to change the port, you can change it as well. And please let me know when you're done by raising your hand again. Oh yeah, I also explained earlier that if you look at Frama root, I think I did it yesterday as well. If you open, because in the meantime, we are waiting till the other ones are ready. So I'm going to show you for the ones that want to see Frama root. This library. Oh, I removed it. Oh yeah, sorry. But when you open Frama root and this do APK, yes, you can add a null byte there. I know it's a bit confusing, right? Why do we have null bytes in there? But the vulnerability is in memcopy and not in a string copy. And if you have memcopy, then null bytes do not matter. So you can have many null bytes in there. That's why when you exploit, for example, a binary protocol or such a thing as that, again, there's no issue with null bytes. And in this case, there's memcopy, so there's no problem with null bytes. And we add the null byte in there because why? Since we want to add a null byte and make sure that when system is executing that parameters, system will need a null byte to make sure that that is the end of the command. Does it make sense, Lindsay?
Yeah, where is that null byte being added? Because I see you defining the system args, but
Oh, in my
in the-
exploit, you mean here? Yeah.
yeah,
this
because
one,
in
I
the
don't-
slides you append
Mhm.
on a null.
Yeah, I think well, the thing is you can also use it without that null byte because
Okay.
why? The reason is why I added that explicitly in that one because if you add this to the if this command has been written on when this command is written on the stack, the next address or the next after, for example, let me show it here on the screen. The stack contains also nulls, right? So by accident, and by the end, when this command is written, there will be a 0 here automatically, since the stack has the 0 there. So in that case, you don't need it, but adding it explicitly.
Okay. So when it's added explicitly, there'd be 2 nulls on the end, right? Is that just because Python is being nice and it knows that's a string because of the
No,
quotes?
it's
So
not
it'd be-
Python. No, it's not Python. When you examine, because we are writing it into the stack, right? So let me show we examined the stack earlier.
Yeah.
And when you look at the stack, one second, I hope I have it here still somewhere. Stack dump. Look, we can see here the stack as well, right? And if you see here, there are many values and there are also multiple nulls. And one of those, when we write it back, it contains already a null after it. So,
Okay, I see.
so it already has a null when it has nothing to do with us, but the way that it is already in the memory. But it's way more safer to add the 0 there yourself than relying on a 0 that is in already because there is a 0 after you have overwritten, right? Because if you examine the stack, you will see that it will end into a null. But if you do that later, you will see it yourself. You know, we will lose time if I open that as well. And I would like to give you the chance to quickly go over that more complex and executing shellcode if you guys don't, if you guys are okay with that. Okay, shall we continue? So, is there anyone who was not able to pop a shell correctly? Just open your microphone. That speaks a bit easier. If you were not able to get a shell,
Yeah,
for some reason-
copying the script out of the Slack channel, there was some kind of non-ASCII character in the script, and I looked at it in XXD and I don't see it. So I'm not quite sure why.
There,
that's not-
I opened it in Vim and there was a lot of angle bracket 200s in there from the copy paste. I think it's keeping some of the fancy formatting Slack gives it.
Yeah.
Okay.
I can paste it. I can again paste it into Pastebin if you want. Make it. I shared the link of Pastebin, so if you open that in your browser in the VM, you should be able to go there. There you should be able to copy it quite easily. So I'll send it in the chat. Look, Andy, if you click on that link and or copy this link into your VM.
Yeah, thank you. I think whoever mentioned the 200s in Vim is correct. I can delete those directly.
Ah, okay, perfect. But did the reverse shell work for you then, Andy? Because you had some issues with it, right? Were you able?
Yeah,
to
that's still not coming through for me. Copied and pasted straight out of Slack.
Who is talking now?
Lindsay.
Lindsay. So can you use you can see on my screen, I use the Pastebin. I copied it for you guys there.
That's just the payload, not the full exploit.
Oh, the full exploit. I can share it also over Pastebin, no problem.
Oh, yeah, thank you.
Yeah, right.
But yes, I did get the payload from that basement. Yeah, so
Okay,
I know
cool.
that it's not a typo there.
Awesome. Let's
And I did change my IP. I've quadruple checked that.
okay, no problem. Let's go to Pastebin and add the whole code over there. Let's see. You know what? I'm going to use the one that is just in my system that we used. Yeah, you know, exploit. Let's copy. Okay. You want me to add the 0 byte here explicitly just to make sure that everyone has the one that I did as well? Yeah, I'm adding it explicitly, but we know that in the end, when this is loaded into the memory, that by accident there are a few nulls over here in the memory itself. Therefore, this is not really necessary. I'll just remove it for now, just to make sure that the exploit really is working there as well before I make a mistake with a typo or anything. And you cannot copy it. So here you go. You should be able to copy this whole code from there into your. Do not forget to change the shell, the IP address there. And I'll send it in the Slack as well. Oh, Praveen. Oh, Praveen, you can also, you're right, you could share it. What? It's very cool. So we can use, I didn't know that. So Slack offers it also. So we can use the Slack link that Praveen actually shared. That would be very easy to use because let's see if wget works on it. What? So use the link that Praveen gave with the wget command here. Let's just verify it. No, the wget won't work because you need to be logged in.
download it. You can download it from the browser. So use the paste bin, copy it quickly.
Yeah, I think that I have the script correct, but when I run it, even with restarting the app and everything, I just get no response from the Python command and don't get anything on the Netcat on the host OS. And then if I Control C the Python because nothing's happened, I get a keyboard interrupt. It's still in the data equals s.receive 200, so it's still waiting for something back from the ADP. ADB.
I got those, but restarting the app fixed that. But the script is running for me, but I'm still not getting the shell coming through. And this is the one pulled down from Pastebin with the IP address replaced. There should be no other required changes, right? Just the IP.
It will definitely work.
Yeah,
Here,
okay.
Let me test
Huh.
the one that is here copied in, right?
Yeah, that's yeah.
Let's test it out just to be sure. So I'll copy this one in before, just to verify if there is no copy paste problem or anything, or any problem that happens. So if I receive the shell, it should be a problem, most probably with. Did you remove the F file? Can you check if the F file is in your CD? If you go to your
Yep.
device, is
The F file is still not made.
Ah, okay, then it's not executing. Are you sure you're running the correct app with us? Did you install the?
Yes. It's
That's
worked for everything up
surprising.
until exactly here. Everything else has been fine.
Everything worked, right? The offsets
Everything
were the
worked until
same.
here. Yeah.
Wow. Let's see. Let's do exploit.py, right? Here, copy it in. We have all those little things still there, but that should not matter that much. Now Python exploit.py. I have the listener up and running. Yeah. Running.
Yeah, my exploit also does not create the F file within that directory.
That should actually be the same with everyone and should work. Look. And it doesn't need,
Yeah.
I
I just watched you do that. That is exactly what I did, except I had to change the IP to match my
believe-
host. So
I
yeah.
believe.
Could it be could it be
Yeah.
because I'm using SOCAT?
No, actually.
Well, no,
this,
because the F file is not being created, so it's not even running.
Yeah, that's the weird thing. And if everything is exact, look, if you have the same app running as I am, and there is no look that the reverse shell is not coming, that can happen, but that the file is not creating, that it cannot happen. You know, the only thing that is a reason that file is not created there is that some of you might have a different version of the app. I believe you. Don't get me wrong. I totally believe that it is the thing, but it's almost we have the same setup running. The app is the same. The versions of the phone is the same, and the offsets. If you calculated the offsets, and they were also the same, because when you calculated the offsets, they were the same, right? No.
Yeah,
Yeah.
every other
Yeah.
every other thing has been the same. Even running the other versions of the exploit, I've gotten the correct response from the application and everything. It's running this Python exploit leak.py doesn't even get the welcome to the vulnerable app message.
Okay, but is there something else then? Can you try to do? Let's because I see here two different things right now. Both of you cannot run it, but for you, Andy, you cannot see even the output, right, coming here.
Yeah, Lindsay, do you see that output?
Yes, I am getting the output and the app crashes. Yeah, but I get everything on the screen
Okay,
from the script
for-
side. I see all of that, just the shell doesn't come through and the F file is not
Okay,
created.
for you, Lindsay, let's do something. Attach your debugger, put a breakpoint on system, right?
Okay.
Can you do that? You know how it works, right? So
Yeah, I can do
attach
that.
it, put a breakpoint to system,
and then run the exploit and check if system gets hit.
Right,
That
can do.
if we can verify that, we know that the exploit works, then that is the thing that we can look for you. And Andy, for you, something else is going on. So let's do something else for you. Can you restart the app yourself and then do an NC to it, like, you know, with the NC connect to it and see if you get greeted by the application. Because if you run the application manually like this, just for the verification, right, that everything is still running as it's supposed to be.
Yep. So I can run the app and then running the Netcat.
Yeah. Do you get greeted then? Because it should be. If it's not, if the Python script is not getting this thing, then this should also not work for you.
Correct. I do not get the welcome.
Okay. Can you do this for me? ADB forward again.
Yep. I just did that.
And then try to connect again. Hey, it's now also not connecting for me. For me, the app crashed or so. Hey, this is interesting. Now I'm also getting no response. This is the first time ever that I'm not getting a response from this app like this.
Glad we could help.
Okay, so I set a breakpoint on system and ran the exploit, and the breakpoint does not trigger. I get a segmentation fault, which the debugger catches.
Okay, then something is wrong, or you guys have a different VM installed, because it should hit the breakpoint. There's no option there. Is there anyone for who it worked actually? Did anyone run the exploit and did it work? Because yesterday we ran it, or 2 days again we ran it with a lot of people. I think almost everyone was able to pop the shell without a problem with the same exploits that we've written. So I guess there is a problem with order version or something is terribly wrong going somewhere. Does anyone have a running exploit for you right now? Did it
Mine
work?
was working, and then I just copied the full script down, and now I'm getting a leaked process stack. I copied it into a new file, so now I'm getting that on both the old and the new version for some reason. So I'm currently restarting my emulator like in the terminal.
Shall we do something all together? You know, since we have still some time, let's do something. Let's stop the machine just to make sure that everything is the same with everyone. Yeah, I killed my my system. I will use Android Studio to restart it up, but again, do not press the play button because that will reinstall the app, which you should not install. If you have pressed the play button in between those classes, then you have installed again the wrong app. I think some of you had a crashing instance, right? It crashed for some of you previously.
Yeah, it was really wonky for me
Yeah.
a few hours ago, but
Yeah, so
I haven't had any problems since this morning.
okay, so if you start this Android and the AVD manager, we will do cold boot all together. Can we do that?
Yeah.
Make sure, and we just to verify, you guys are all on API level 25, Android 7.1.1, the same as I have over here, right?
Yep.
Okay,
Yep.
Then there is no way I believe you guys, there's no thing. So I need to figure out why, because if the next time I give the course and this happens, then I need to also know what's going on. But it surprises me a little bit that this happens. This is Praveen, have you seen this? That this is happening?
No, but last batch, I didn't see this. I didn't face any kind of this issue, so much.
No.
We don't.
It's okay, but it can happen, right? So some things can happen. So
Going on.
it's not a problem. Let's see if after the booting it will work. Sorry, you were saying something? So I'll wait until mine is started up. It will take a little bit of time. And by the way, no problems, guys. If you have time, I have time. I will stay longer. It's not a problem for me. I was so hoping that you guys will pop the shell. For you guys and for all of us, right? To end with a nice feeling. But I think actually at least you got the shell, right? There must be some more people who...
Yes, I had it for a moment. I was able to follow along with you as you were moving through the directories and everything. So I was able to do that.
Cool, awesome. We will get it working for you guys as well, for the other ones. So I did a cold boot. So please do that. Do not use this play button. And if you have used this, please let me know now, because the exploit won't work if you have used this play button. I can recreate an exploit that will work, because look, some of the offsets will still work. And by the way, you can verify it with this. Look, does this address for you end in those zeros? This libc base. If you look at your output, does this end on those 3 zeros?
Mine does not.
Okay, then you have the wrong version of app. I'm 100% sure.
Okay, I installed it through the update script though.
Okay, but or you did in that's maybe in between somewhere. You have pressed this play button or something, because that reinstalled the
No.
app.
I didn't even open the Android Studio project this time. I reinstalled Android Studio overnight because I was getting weird behavior. So I didn't even open the project. I went straight into AVD, created a new device, fresh image, and cold booted it, and then ran the update scripts targeting it.
But yeah, look, the exploit is not able to calculate the base address, and that usually happens because there is a wrong version of app installed. The version is not correct, or the version of libc that you're running. For example, that while installing, there are different versions available. If in somewhere you have installed a different version of or the Android Studio, and this was the problem that we discussed earlier. If you have just one different version, so instead of having 7.1.1, you have 7.1 alone, that will already create an issue, because the version is not
Then they're
correct.
using different version.
What? Sorry, Praveen?
Let's say is using different version, and Andy, libc base is right.
Yeah, my libc base does end in 000.
Yep.
Okay, that ends for you 000, but were you able to get your reverse shell while testing it manually?
Yes,
That's what.
manually I could get the reverse shell.
Yes.
Okay, now for Andy, and did you guys now do the cold boot also?
It's still loading, but yeah.
Okay, let's wait until this boots up.
Yeah.
And let's wait until it boots up, and then we're gonna see if that F file is for some of you there or for some of you not, and then we can continue from there to see if.
Okay, so it just finished booting the emulator.
Yeah. So the SOCAT is also still running, right, on the side? On the base
Yes.
machine? Okay, then we can do ADB Connect. For me, that should now also work. 51, 6. Okay, first, we're gonna do this. We're gonna connect to the device and make sure that you are root. Go to the data/data, component example, my native test. Then do ls, see if you see or a weird file like this that I have over here of this file, and
No,
remove
just cache, code cache, and lib, which is a soft link to the ARM.
only those files are there, right, for you then?
Yeah.
Okay. So if you don't have this, then there is something wrong with the exploit. For sure, that's not running, and we're gonna verify that. No problem. We're gonna debug what's going on with you for you guys. But without a joke, guys, I know what I'm doing in this thing, and I'm pretty sure that there is a problem with the version. I'm 100% sure of that. That's why, and I heard someone has a 0 there. For you, there is another problem. So for you, if I'm correct, for you, when you go to this data folder /com .example, my native thing, you should see the F's there. Am I correct?
No, so I have the 000 libc base, and I do not have F or any other file in that. I have just the cache, code cache, and lib.
I have F.
You have F, right? I think you were also the one who said mine libc base ends at 0, right?
Yes, but no reverse shell.
No, but that's good because I'm now pretty sure that your version is correct. So for you, we know that. Now we're going to verify all together something else. So you can remove the last person who just spoke because I cannot see the chat constantly. If you can remove every F file there by using this, just to make sure that you remove it. And then go back and set up a new listener. And if you have restarted also like me with ADB thing, you need to make sure that forward again the TCP 6000, TCP 6000. And for the one who had that 0 there and removed the F file over there, you can now run the exploit, and I'm sure you will get the shell. And for the other persons, Andy and I think Lindsay, right? You both were not having the F file in the folder, right?
Correct.
Correct,
Okay.
yeah.
Let's do one thing together because and if I'm correct, both of you do not have the zeros there at the libc base, right?
No, I do
I
have
do not.
0 there.
Who has it and who doesn't?
Andy has it, and I believe Lindsay does not.
Okay, cool. Then for you, Andy, if we put the breakpoint, if we now attach the debugger, we will do that. Make sure first to forward the debugger port already. 5045 TCP 5045, because that is our where we will do the debugging. That we will do. Attach the debugger to it. 5045 attach the ID of my
Looks like the app needs to start.
So, session. Okay, we go into the things, set the breakpoint at system. So I will show that in the screen. Let's do it all together, okay? ADB shell. Some of you already did it now, I guess, by now. So I will start the application A and start content example and my native test / dot main activity. Let's attach our debugger to it. GDB server 5045 attach sample native test. Oh, sorry, with the PID of course. PID Or like this. I don't know what's going on when every single time when I know. Ah. Know what I'm gonna do this part. That my native. Okay, I'll now attach my debugger. Sorry, it took a bit longer for me. Let's attach the debugger. And when the debugger is done, let's go to our GDB. That's this root, boom. Desktop, GDB 7, like that, and get remote 5045. Okay, when you're done and setting your debugger, let's put a breakpoint at system and put it like this. Can you guys do that?
Starting the GDB right now.
Yeah, I'll wait, no problem. Set a breakpoint over there. Everyone who has an issue, please set a breakpoint at system. Lindsay, you already did it, right? For you, it doesn't hit the breakpoint.
Yes, it does not hit the breakpoint and it throws a segmentation fault. I
Yeah,
definitely have the wrong version of the app, so I'm reinstalling that now. But
Yeah,
it's
that-
taking
that-
its sweet time.
Yeah, no problem, but that must be the problem, or else you have a wrong version of VM. I believe you, if you say you have done it, but we need to check where the issue is.
Okay, so I set the breakpoint, and that system address does have the last 3 digits as yours. So I think that we're good there.
Yeah, that's good. That's all okay. So now let's continue the process, right? Let it continue. And then we're going to run the exploit against it. So let me exit this one and do Python exploit delete.
Okay, I get the welcome message, and it looks like it ran.
Okay, but now did it hit your breakpoint? That's important. Look, for me, it hit my breakpoint. You see?
Yes.
It
Yes,
hit your
it did.
breakpoint? Do you see this command over here, like I see it here?
Yep.
Okay, you should be, when you look, we're gonna verify everything. So you see this address over here? That is the one that should point to our string, right? We can examine that by doing x/s and then give that address to it. And you should see this command there.
Sorry, the address was from
The
R1,
address that you see at R0, yes.
R0.
Because we set R0, we make sure that the argument is correct to system. And if you have your breakpoint here and you see this output, then there is no way that this exploit won't work. And there is something else wrong, and that is because your base machine is not receiving the shell.
Okay, so if I XS, oh no, sorry, I dereferenced. Hold on.
Yeah, so you can do x/s to print this as a string,
Yeah.
and give the address of your
So-
R0.
It does have that full message, but then there's a bunch of random data at the end of this.
Yes, okay, that's perfect. This is the situation that we earlier discussed. For me, that worked, and for you, that won't work because on the stack, there is no 0 there. So to make this work, right? And this is only for you and for Ash, Lindsay, this is not the case, right? But for you, Lindsay, I'm pretty sure you have the wrong version. That must be. There is no.
Mhm.
That it's almost. We do this many times, so there is no option that. Okay, but let's have a look at this thing. Now, what you can do, let's do something. Let's modify your exploit.
So in my Python script, I should just add a string of /x00 after system args, right?
Indeed, yes.
Okay.
Yeah, and that will make sure that then after that, you should get into a shell without a problem. But only if you modify the IP address correctly and you know that you tested out your
the string before, and you got the shell, and that worked. At that time.
Yeah.
If that worked, and you copy the same payload in there, and now you can again debug it by attaching the debugger to it. Now there should be no weird characters after it. The only difference that I can see with the other groups that we did is that if we copied it in from Pastebin or from other sources, right? Or something got copied, that can be a problem, but for the rest it's all the same. So for me now, when I run the expert, I'm dropped into the shell. But in the meantime, while you guys try, because the thing is we are not able to, let's see what's going on. I see here who sent this, and training, okay. Yes, and when you do print of the R0 M training, when you do examine, what do you see then? So when you do x/I, x/s, I mean, and then this, you should see the whole string, the payload string. It should be visible. Do you see some weird stuff also behind it?
What's the command again?
Yeah, I sent it in the chat actually. x/, so you can see it here on my screen as well. x/s, and then the address of your R0 value.
So mine is working now. I have the reverse shell on the host.
Yes, yes, and
Thank you.
let's see. Sometimes I can see the. Yes, you also have that problem. Yes. Hey, this is actually quite funny to see because we were just discussing about it, and adding that 0 makes it safe. So for you also, my apologies. I think there it went wrong. You need to add the 0. So look at the code. Look at my screen, please. Every single one of you. Add the 0 byte at the end of your exploit code. So I added here simply to made it explicit by adding 0 byte. So I'll copy it in. You can just copy it into your thing, and then when you restart a fresh application and run your exploit, you should be able to run it. You should be getting a shot. And sorry for the others that you had to wait. I'm really sorry. After setting I rebooted the app. Now I have the reverse shell. Awesome, cool. I'm so happy that you guys got the reverse shell. But I would not be able to sleep actually. Yeah, seriously, without a joke. I mean, that would be very sad. Working 2 days so hard all together and not getting a shell. Oh my God.
There we go. I got it. Yes. Yeah, so I reinstalled the app through ADB and now it works. Cool. Yeah, it was the wrong version. All right, we're good.
Told you.
Yeah, you did. The calculated libc is a giveaway. Lessons learned.
Yeah, but it happens, you know, we have this stuff sometimes when we do, before the training started, you guys won't imagine what type of issues we, you know, we did a few times this training before we came to Black Hat, right? And everything was working fine and everything was going fine until we had to create this VM and everything more so that it worked. We bumped into some problems with updating the machine while some of you got already the PDF. My apologies for some of the things that happened, but this is our first session at Black Hat, right? So I hope you guys can understand it a little. Okay, let's continue. If you guys want, we can still continue a little bit. You would like to, or we can even actually, if you guys want,
take another day altogether and do the last part of the course. I'm okay with that.
I'm happy to continue, but I know it's 3 a.m. for you, so.
I don't care, actually. It's okay. I just yesterday I had the jet lag, but that jet lag is over now. So now I'm in your time zone. So we can continue. Let's. I went to Las Vegas a couple of times. I had no jet lag, but this time I had jet lag from sleeping at home. So okay. Now I think we can pretty quickly go over this last part. We can try it. Well, the only part is the ROP chain is a little bit complicated, but I'll skip over some parts that are not important. First of all, we need to check if the stack is executable, and that is not executable. You can see that here just as a proof. You can run it yourself, but just believe me, it's not executable. It will not be. So it has this read-write protection on it. And to disable the protection of this system, and this on every Linux machine is the same, and this Android device is nothing but a Linux device with some little own things there. So to change the protection of the page, we can use mprotect, and this mprotect needs 3 arguments. If you read the whole article, you will see that it will require a few things that are important. First of all, the address needs to be the base of that page that you want to change. The length doesn't matter. You just use 400 bytes, for example, the length, and that's okay. Then you can change the protection to read-write executable, and for that you need to use the value of 7. You can look at the manual yourself, but it's using AND of multiple values, and that's normal in C programming, C++ programming, right? But have a look at in your own time, because we have less time to have a look at it. Now, if you disassemble mprotect, you can notice that it executes in ARM mode. When you again do the calculation, right? It's the same process. You do the calculation. We need the pointer to that function. We can again set the new variables there. So what I suggest you do is copy your code that you have over here. So let me exit this one quickly. No. Exploit. So I will copy it. You can also do it with me. CP exploit leak. Copy that as exploit stack. So we can reuse that one. And then you can open exploit stack.py. We can start removing a few things because we don't need that. For example, we don't need those system arguments. We don't need system args, and also not that system arg thing that we earlier used. Remove those. Now you can add the other part, because here you can see the system that we calculated. Copy from our slides this piece in the, you can calculate it yourself, but by this time you should know how to calculate it, right? You subtract it, you get the offset, you subtract the pointer of mprotect that you can get by doing print mprotect, and then subtracting it from libc base, that will give you the offset, the distance between them. And now, since we already have libc base, we can add the offset to libc base, get to mprotect. But the difference is we don't add the +1, because we saw in the previous slide that it was executing in ARM mode and not in thumb mode. You remember why, right? Because we saw in the disassembly it was 4-byte long execution and not 2 bytes long. So here you could see that actually it increments with 4 bytes. Every instruction was 4-byte long. Now, coming back to here, we can again use ROP gadget, and something interesting is over here, because can I ask you guys, without looking at the slides, please, anyone to the screen and tell me which gadgets we could use to do this? Because we need to set 0, we need to set 1, and we need to set the value of R2.
Most of the time you would think, okay, let's do pop R0. Yes.
Is it the
Emily?
FA24 one?
Oh yeah, how are you going to tell me that? This one you mean?
Yeah.
FA24? Yeah, it is one of them that we are going to use. But
I
there's
was
a
looking at the
problem.
one beneath it.
Yes, that one also.
C78, yeah.
Yeah, so not totally correct both of it, but let's look at it. So we want to change R0, right? So we can change R0. Normally you would think, okay, let's use this one, let's use this one, or use only this one. So it will set R2, R1 and R2, and then later use this one. But there's a problem. You can see over here, this 2 multiplication will be added into R3. So there's no problem in this instruction that will execute. So this, when we land into this address, it will start executing this part, then this line, then this line. But as you can see here, R1 gets modified. So in here, we don't have anything with R1 to do that will get modified. But eventually LR will branch into LR. So this will only set the value of R2. But we need to make sure that if we build this whole ROP gadget, that we take in consideration that it will pop a junk value in there. Don't worry if you don't get it. It sounds a bit complicated, but what we will do, we will first use this gadget that will set R0 without any problem, then link PC to this one that will set R2. We don't care what happens with R1 at this stage. We just add some junk value, it will get modified, you know, and so R3 will be subtracted. If you are very smart, you can actually make sure that it works by setting the value and at a certain, I don't know if it works, so don't try it right now. But in the end, we are modifying R2. We know that R2 is not getting modified with this extra code that happens. And we branch into LR, so we control the next gadget. After that, we can execute R1 and modify R1 back to a value that we want. That's it. With that, we will have our gadgets ready that can execute. I'm going to skip the debugging part, right? Because I had this in the slides so that you guys can debug, because debugging is essential in exploit dev, right? You saw it just minutes ago. We had to debug quickly. And that's normal that happens. And I'm pretty sure that if you now restart the application again and run the exploit, it will continuously run without a problem. Just make sure you restart the application freshly. So what is happening after this, if we set these gadgets, right? So you can copy them in already. I'll do that also. Copy these pieces of all these gadgets in. Again, we are using libc base, right? Because these gadgets come out of libc base. Copy them in. You can remove this gadget here or leave it. It's the same as the one. So this is how your exploit should look like right now. Or oh, wait a second, I have the wrong one open. So many exploits right now. Okay. I thought I saved the exploit together with you guys.
This one, the stack.
This one, right?
Yeah.
Oh yeah, sorry. Yeah. So here, no, I'm a bit surprised because I had this address of mprotect also in here. If I'm correct, you guys already added mprotect here also, right? I missed that. So this mprotect one needs to be added as well. So you should have this. I'll copy it in, right? So you can copy it just into your code. It should be underneath overflow and in between this gadget. Or this printing of the, I'm sending it into this chat, also to the Zoom again.
Sorry, what does the second line there do? mprotect gets assigned to mprotect.
Yeah, this one here, you mean?
Yeah.
I'm just showing, I did that on purpose to show.
Oh,
the
to
difference.
show not adding
Yeah,
one.
yeah,
with
not the
Armor.
one,
Okay.
or else, you know, or else it might not be explicitly visible for people. So that's why I could have also added here, right, +1 and the other one not a +1. Yeah, I chose to do it in this way.
Okay.
To be explicit. So this is saved. We have our gadgets ready. And what you usually do is put the breakpoint in the gadgets, right? What we can do, right? Set the breakpoint to speed up a little bit, set the breakpoint at only one of those gadgets. But let's first continue with the slides and then I will show you what's going on. So we have our gadgets ready. And what do those gadgets do? We will need to align the stack in a way, because now we need to feed in the values that we want to feed in there. And the first execution will be our first gadget that will chain into our second one. And you remember, right, that popped R1, R2, and LR. So we need to put those three values there. The first one is just junk. You can put anything there because that we don't care that get modified with any value. And then LR2 will be popped with our, remember, R2 is this is the third argument in mprotect. The first one is the address. So therefore we use the stack address, the stack base address as the first argument. The third argument in here, so that's the confusion a little bit, because normally you would have set R1 first and then R2, but we are now doing it because of the limitations in the gadget. Because if you would have executed the other gadget first, then it would have modified R1, and then if you execute this one, then it will modify R1 again. That's not what we want, right? Sorry?
Oh, sorry, I'm not.
You're not on mute, we can hear you. So when you execute the next one, it will be branching into LR. And in the end, we want to jump into our shellcode, right? That's what the goal is. So this is how the complex drop chain will look like. And this is how, in the end, your string will look like. And why is that like that? So we have an overflow, the first gadget, then the first value, because it's popping 2, popping, it's a pop 0 that will, now we can choose the value that we want to put there. And then the second gadget that we want to execute, the address of the second gadget. The second gadget requires 3 of them. The first one is R1's value. Second one is R2's value. And the third one is again linking to our last gadget, which again uses R1 value and then branch into mprotect and call into our look. Why I'm saying this is if you execute it normally like this, you will bump into a problem. And that I'm going to show on the screens. And we're going to skip this step because here I was going to show it in the debugger how it works. We can look at it in the screen. So you can set the breakpoints to them, to those gadgets, and see them in action. You'll see the execution happening step by step. Step by step, you will see the execution of every gadget. Since you put breakpoints on them, you can see them step by step executed. I'm going to show that to you guys. Then you can see all your stack values have been written correctly. You see those gadgets are also there, right? The addresses of those gadgets. And as you saw on the picture, it is exactly aligned as in the picture. The first value, which is 444, will be placed in R0. Then the second gadget will be popped into PC and be executed. The junk value that is over here, we don't care, that will be popped in R1. And then this one be in R2. And the second gadget will be executed. And this gadget will pop in R1, the 555. And the next gadget will be, the PC will point to mprotect and disable the protection. Now I put placeholders here just to show everyone how it looks in the stack. If you, this is how it should look like. And if you copy this piece of code in there, then you should be able to debug with using the next slide. With using, look, we are using VM map to get the libc base, because in our code we have a variable that does that automatically for us. But if you want to break to put the breakpoint on your gadgets, you will use the VM map base plus that offset, as we do in our code. You will set 3 breakpoints. I'm going to show it on the screen to you guys, actually, so that you can see that happening. Now, when you execute your gadgets one by one, and therefore I said to you guys this, let me open it like this, sorry. So if you guys do this, for example, later, when you come back to my slides, this is very interactive slides, to be honest, because now you can one by one execute. You don't even need a debugger, because this is doing it for you. So we can see that all these gadgets get executed and all these values are being set. Now every value has been set as we wanted, 444, 555, 666. We just need to replace them with the correct values. And the first argument needs to be the stack base. And we know that the stack, when we earlier checked, our stack base had the stack top ends at 18, right? Maybe you have seen it already in the output of the exploit. But the stack top is not the same as the stack base. It's a different thing. So here you can see the stack top, right? You see it ends on 18. And to get to the base, we need to subtract the 18 away from it. And that is what we will do here. We will put the first value that will pop in R0 as the stack base. Then change this value to 0.7, which will be the 7 that will make the base read-write executable. When you set some value there, I used 4010. I suggest you do the same if we do not want to bump into a problem. When you execute this code, you will see that the page gets, the stack will get read-write executable. Now, there is one little problem if you execute this whole chain, and you will notice that while doing it. So we, first of all, add these variables in there. I'm going to share the full exploit with you guys, but make it a bit easier. But basically, what we are adding the lead stack top, we want to get the address of the shellcode, right? Because if you land into the shellcode itself, it will not execute. For example, the address of the stack is a different thing than getting into the stack and executing. So we want to get the address of the start of our shellcode, and we know that it is 5C far away. Again, just by examining the stack, you can find the distance. You can add that to your stack top, and that will give you the beginning of the shellcode address. Now, this shellcode you can replace with the previous shellcode you generated as day one, and your new gadgets there. And you can replace those. Here we are doing again debugging. During the class, we would have debugged it to see, are we hitting our shellcode, yes or no? We put a breakpoint at our last gadget. And when you execute it, your last gadget will be hit. But there is one little problem, because if you remember, in one of our gadgets, we set the value of LR, right? Do you remember the second gadget that we executed in our code? Look at this one. I hope you guys can still follow it, by the way. So
Yeah,
this gadget that you see here creates also an issue. which you have to compensate for, because what it does, it sets LR, and LR is not PC, right? It has a special functionality. If you set LR, that means that whenever a function returns, that it will branch into LR, and that's exactly what happened. Because when we call mprotect to disable the protection, mprotect will try to branch back to LR because it needs to return, right? It will be popping LR into PC or branch into LR by himself. You can see that in the slides happening. Look, mprotect will in the end branch into LR. And where does LR point to? To our previous gadget. So what do we need to do? It's quite simple, right? We need to compensate for that. So you can see in the slide that that will happen. So what we will do is add an extra piece of code to it with junk value over there. And then, because it will execute again this pop R1 and PC again, right? That gadget that we set there will be executed again. Therefore, we put some junk value that will be popped into R1, and we can put the address of our shellcode. This will point to the beginning of this shellcode on the stack, and therefore start executing our shellcode. So let's do it a bit easier altogether. You guys don't mind, right? Or else it's going to be, if we are going to do the debugging stuff, I'm pretty sure it will be 7 o'clock here in the morning when I'm done with that. And also for you guys, it will be done at the evening. So to spare that, I'm going to share with you guys the exploit, and we can execute it. But is it understandable what we did or not? Because I think the understanding is more important than running just an exploit, right? Okay, then let me see if we can. In the end, you will get a shell, right? So let me share the exploit code with you guys. Where do you want me to share it? I can send it in the Slack group also, but also in the other. Please modify the shellcode in there. That's very important. You need to modify the shellcode to your shellcode. Lindsay, did you reinstall the app, by the way? And were you able to pop a shell now? Yeah, right?
Yes, I did, and it worked fine. Yep.
Cool. And for all of you, right? Every single time you run it, it should get you again into this shell. Also for you, Ashley, because you had this issue that it didn't work anymore.
Yes, mine's fine now.
Awesome. So I shared the exploit code with you guys. If you guys want, I can run it for myself here so you can see it in action.
Yeah, yes, please. Can you demonstrate?
Yes, of course. Let's do that. I would more than love to show that. Let's see now. Back. I'm going to show you guys a bit in detail. Let's remove everything I've copied. It's just the same code, nothing different. Everything is the same. The only thing is I added this part, my own shellcode there. And what I'm going to do is I'm going to put a breakpoint at this gadget to show you guys this stuff in action. So let's start the app again. Let me kill it quickly.
Did you guys learn some new stuff, or were you able to learn some new things from the course?
Very,
Oh
very
yeah,
much
this
so.
was fantastic. Yeah.
Yes,
Thank-
absolutely.
Thank you very much. Please, guys, please fill in the forms for us because that's very important. Very, very important. If you can just be honest, you know, if you didn't like it, also just
One thing I'll say that's been nice is that you know, I've been able to hear where everyone else is at, and we've been able to troubleshoot what everyone else is running into.
Mhm.
Whereas if we were in a class, I don't think we'd be able to exchange that information as quickly.
Oh yeah, so now everyone could listen together, right? That's what you mean. And while we troubleshoot. Is that correct?
Right.
Awesome. And is there anything you guys think I would be a good idea to do it differently? For example, remove parts out of it or add more of it?
No, I think the content was great. I think there were just a couple like wrinkles with copy and pasting some of the stuff and having scripts. Maybe if there was like a answer section at the end of the book, you know, so we could do the work ourselves. But if we needed to get to the you know, level X solution at some point, to have that on the machine ahead of time to copy and paste.
Totally agree with you. We were busy with creating a lab manual that contains all these lab exercises. And then while we were busy with the slides, we thought, you know, everything is already in the slide. So if you go through that, but I agree, we should have an extra thing. But I wonder one thing actually is that at the beginning we started very slow, right, with basic stuff. Was that going too slow, for example? Or maybe do 4-day run, a lot of content for 2 days. Yeah, indeed. Yeah, that's true.
I thought the beginning was good though, because it really set a foundation. Like it wasn't just go read about this on your own and hopefully you understand it.
Yeah.
You walked through a lot of the foundational pieces that let what we're doing now actually make sense, as opposed to just you know, the middle is left as an exercise to the reader, figure it out on your own.
Yeah,
Yeah, I
Thank you
agree
very
with
much.
that.
Thank you. Very nice feedback from you guys. But is there anything you would say, hey, that part could have done better, for example, if we got already?
I agree with fitting it into a 4-day rather than cramming it into a 2-day. I mean, I certainly enjoyed it. Yeah, it's just a lot of go, go, go. But again, like if you came in here knowing nothing, then I mean, it's, you know.
Yeah, it's hard actually. That's why we want to start with that foundation.
Did you guys have this listed as a beginner, intermediate, advanced class? I can't remember from the listing.
Yeah, it's beginner actually. We added as a beginner there.
Okay.
Yeah, but you know, what is a beginner, right? That in this, this is pretty advanced material, right? We want to explain it in the basic way, but how far basic can we go with this? It is kind of, it will get more and more difficult if you go more into exploitation.
Right.
So
I mean, yeah, like this is it. Like this is the beginning.
yeah, this is the beginning indeed. Yeah, more when we go further, yeah, it's constantly solving problems, etc., debugging. So yeah, I think for the 4 days course, indeed, I agree with you guys. 4 days course would be nice, and then adding all these kernel bypassing, escaping the sandbox, and maybe before the training starts, send material to people to read about doing the ADB shell stuff themselves, practice that. And then when we join the class, everyone should have a foundation already. And then we dive into.
Yeah, I think there are a lot of landmines, like starting the app in the emulator from the wrong button, or like just certain things where there are things we don't know. And if we do it, it messes up. And you've been really helpful in helping us diagnose those problems. And that probably cost us some time as well. So if those can be called out a little bit earlier in the course material to say, don't do this because it'll mess you up for later.
Yes, indeed. You're totally right. And the thing is that we didn't know that actually. That's the funny thing. We didn't know that that was today. You know, yesterday I think, or today I can't. I'm a bit confused with the days nowadays. Now, but
Day before yesterday, Umut.
what?
Day before yesterday.
Day before yesterday. No, I mean, but what I wanted to say is that this issue with the reinstalling the app and that the weird things that we saw today, we hadn't seen them. Also, not in the previous class, so it was kind of funny.
Because we faced this is like all every issue looks like weird for today actually. We didn't face this issue last batch.
Okay, I was doing also something here to show it. So let's do the dev remote. Oh, it's not.
I am going to need to hop off, but I just wanted to say thank you for the fantastic course. I learned a lot, and I'm going to need to go through these slides and make sure I digest it all.
Thank you. So please feel free in the chat to ask anything or contact me after the course as well. And like I said, we love to do this stuff. So if you're just free at an evening and you want to do this stuff, feel free to contact. You know, we since COVID, we are doing with all over the world with a lot of people doing live together hacking things. You know, researching things.
Yeah, 100%. That sounds awesome.
Would be very cool to have more people. Cool. Then we'll see you. I'm going to do this last debugging part and show it, and then we can call it a day, I guess. Thank you very much for joining, by the way. See you.
Yeah, thank you. Cheers. Have
See
a
you.
good morning, evening, whatever your time zone is.
Yeah, it's
All right,
now
cheers.
13. Yeah. See you. Bye. So I'm gonna do VM map, right? Because we want to put a breakpoint at the address in our gadget that we have over here, and that's the nano exploit
Stack.
Yeah. Stack. So, does making the stack trigger any safety features? Not, but you know, Zimperium, the EDR system from Zimperium, will detect this weird kind of stuff. I don't know the internals of Zimperium, but I know they are able to detect a lot of attacks. So that is, if you're interested in using something that is detecting even advanced, I think they are one of the few ones that could attack new type of attacks from Pegasus. You know, the stuff that's being used by NSO. They are the ones that were able to detect it. So that's kind of funny, you know, two Israeli companies, one is attacking, the other one is detecting. I mean, it is normal, you know, in Israel, you have a lot of tech companies. I also worked for one Israeli company before. I can tell you that there are some talented people working at Israeli tech companies. So I will run my exploit, or no, first we'll get this offset right here. We want to put a breakpoint over that one. Since we have our debugging running and we have the libc base, we can set the breakpoint ourselves, which I'm also showing in the slides. So libc base plus this will set the breakpoint. You can check it out, right? So you can do instruction and see if this is correct by using all the things that we have learned previously. So if we do that, you will see that is the pop instruction, the last one. So now I will also continue the process, save this, and run this exploit against our target. And if everything goes well, we should hit our, but we did not hit our breakpoint. It's funny. Oh, I run the wrong exploit.
Yes.
No. No. Let's see.
So feel free to leave, by the way, if you need to go or anything. I'm just showing this as an extra to you guys. And if you want to know more about any slide or anything, you want to do it later together with us or with me, I'm like I said, don't feel weird of asking it, because like I said, I love to do this. I'll do it just for fun. Now let's do again the VM map. We had the breakpoint already here, so I should be able to put the breakpoint here. Now I'll continue the process. Now I run the real exploit stack. That should trigger the last gadget, right? So we should trigger it. We don't have to debug everything. You see, we hit our breakpoint. You can see that some values have been set already. This is the base. You see the stack base. If we get this address and we do VM map against it, you can see that this is the stack base. Hey, it's not the base. Either way, it doesn't matter. It's gonna change the address to executable somehow. Okay, but anyways, let's do it because it still works. And when we pop the last one, you see it's going to branch into you can use step I to step into, that will execute one line. Now we can see 410 is the one, is R1. This is the protection level. This is exactly what we want, right? You can see this points to the stack, which contains all these 4141s. Oh, now I remember. We are we chose the piece of memory that points to our code to make that executable, but either way, it doesn't matter. So if we continue this, I will continue. Let me also put a listener on it and continue the process. Should get this shower. Okay, we hit the second breakpoint, like I said, because we are after mprotect, we are hitting our second one, and you can see, you remember, you guys, what the return value is going to be put in. So mprotect executed, the return value gets saved into R0, and this means it returned with the code 0. And if I'm correct, if we just copy this address of the stack and do VM map, you should see that the stack got read write executable. Yes. Now, when you continue, we saw that the new process was executed, and it could not set a breakpoint, but you can see system/bin was executed as a new process. And continue. For some reason, it got executed, but the shell did not come through properly. And we know that this was an issue. We did that on purpose to ask you guys later to execute another piece of shell code. So this was it. You can see everything actually executes, even the executable stack got executed. The bind shell code will also work. You can replace your shellcode with another shellcode. I will send the full working exploit that has a shellcode in there that I'll send.
I have shared the blind shell, Amit.
Yeah.
In Slack.
Okay, I'm gonna leave that one for as it is. I think for that part it is complete. If you guys are we still in? Guys, you would like to listen to the rest of the training?
How much more do you have? I feel guilty keeping.
No, you don't have to feel guilty at all. I'm happy that someone is wanting to listen. Actually, you know what I'm scared of when I'm sometimes telling this stuff is that not everyone is it's a lot of debugging and stuff. Not everyone is into that stuff always. So that was it. You received a shell in the end. We made the stack executable, so you can execute anything on the stack, and that's quite something. because that should not be the case at modern systems, right? And this is how you bypass the data execution prevention, or the NX, the not writable or executable protection on this type of modern systems. But we were able to disable it by using blockchains. In new versions, very new versions of systems, you will have control flow integrity, which will not allow you to do this type of blockchains. So what do you do then? You just need to make sure that you have control over an argument, over one register, and that you can branch into that register. So then you will load the address of system into that register and then branch into that register, and that will make sure that the control flow integrity will not be detecting that you are jumping, because you're doing a dynamic jump and it cannot check the dynamic jumps for control flow. There is also a concept with the shadow stacks that is part of the control flow integrity. But I think for today, all that stuff is a bit too much. But I want to go over this part because before we end, I can go quickly over this. So if you have a heap overflow, in the past we had dlmalloc. That's an old version of malloc, and malloc is being used to allocate. It's an allocator, memory allocator for the heap. Not going into all of it, but when you do malloc in C, you will get a piece of memory, and that's called a chunk. And within that chunk, you have a metadata in front of it. And when you override that metadata, you can actually manipulate the malloc implementation to read or write or free a memory that should not be freed. And automatically that will be overwritten maybe by the attacker's controlled object. This type of trick we will do on the heap. And with JUmalloc, there's a little problem, because in the past with dlmalloc, you would know that every single time that you create a new, or you do a malloc, you would know that it will come next to it. So that would happen. But what happened with this type of allocators is that when you free a block in between, and you do that a couple of times, you will have those little spaces in between, and blocks of memory will have a lot of unused memory in between. So therefore, in the modern operating systems, you will have a thread safe also, because these implementations were, the dlmalloc was not thread safe. In JLmalloc, it is thread safe. It uses, without going into details, it is a thread safe version of the malloc. You can also maybe remember that old Android phones were quite slow, right? And that's also the reason for it, partly the reason of it. Now they use JUmalloc, which is thread safe. So you have to understand that for every allocation that happened, if you do a malloc, and malloc happens a lot, if you have written C, you will know that malloc is a normal operation, right? And if you have to put a lock on malloc every single time, that makes the system very slow. They fix that in JUmalloc. The only thing that you have to know within JUmalloc is that you have bins that will hold the pointer to all specific sized objects. And there's a whole detail about it, and I suggest that you go to NSO's page. Of course, NSO, right? NSO has a nice research page about it, and it contains very technical detail about it. And also the guys from Census Lab, I add the links to it. To the pages, so you can read this on your own time. I highly suggest it. What I did for you guys is install the tools for you, so later on you could use them. The shadow tool is on your system. So remember, in the past you could override this structure and then manipulate the allocator to do something else for you. Now, and this will have create a read, write, what, where situation. So you will have, as an attacker, you can write in 4 bytes into a piece of memory. So earlier someone asked, hey, what is that address in front of that smprintf? You saw the plot address there. And now, and that is a table, right? A GOT table, global offset table, and you can override the pointer that is in there. When you override the pointer and that function gets hit, like smprintf or any other function that you, for example, you have a table and there is a list of trampolines that jump into the real calls. If you override that table, for example, for printf, you change the address, then if printf get hits into the application, then your code will be executed. That's the trick that happens there. And for JEmalloc, you just have to keep in mind, because this is called also, for the people who come from Windows, this is called the low fragmented heap, because it makes sure that the heap, the allocator, keeps the small sized objects, it will place into under each other, next to each other. The other ones will be placed somewhere else. But like in the past, if you did a malloc or you ask for a new memory from the application or from the remote host, that would cause it to align it next to each other always. And in this case, that doesn't happen because they prevent the fragmentation stuff that happens, or the little gaps in between that prevents this, because all the same sized objects will be replaced. So you have these things called bins that contain the same sized memory blocks can be placed in that. This goes very complex, right? I cannot explain this in a very short time, but keep in mind that when you do heap overflows, you will need to be able to see the heap. And for heap overflows, there's one thing very important that there are 3 ways to exploit those heap overflows, and heap overflows are kind of, sometimes people see them as difficult, but they don't have to be difficult. You just have to keep in mind that you're overwriting a piece of memory. Again, the buffer thing that we discussed earlier, if there is 2 buffers that are mallocing a piece of memory, and there's a string copy, there's this ls being copied over here, and if the user controls the other data, it can copy the data. Again, the same principle. A system can execute. The attacker controls data. If the code was looking something like this, right? This is very, but this stuff happened. Then we have the agented, so you can override those metadata, right? In JEmalloc, you can actually override the run headers that also contain metadata that can be abused. It will just read the NSO article and you will be able to see what how to do that. The chunk headers as well, you can corrupt them. What is interesting to know also for use after freeze, for example, here we see 2 objects from the same objects, actually A and B. It is some object, it doesn't matter what it is. And there's a pointer which we have as an attacker. In a minute, I will explain how you can hold such a pointer, for example. But see this situation. If we make sure that one piece gets freed, but we keep a pointer to that piece of memory as the object, right? You can see the free on the left side here, in here, that's freed bay. But later in the code, we are still using bay to execute some function, for example. But if we, as an attacker, spray the whole heap with a fake object with the same size, because we can see the size and we know that JEmalloc will be replacing it in the same bin at that with the same size, we can actually make sure that it lands always at that location. Since we control the fake object, we can also now point the v pointer to another call instead of the sum function to system, for example. Now, how do we spray the heap? That's very interesting, right? This type of stuff you do typically in browsers, but there are also other techniques. Because, for example, if you would do this on an SSH, for example, there's an SSH problem, and you know that there is a use after free, and you hold the pointer of an object by connecting to it, for example. What you can do is send multiple connection requests to it, and that will automatically spray the heap for you with all those objects, right? So that is how we would do a heap spraying in a way that that normally would not work, for example, right? Because in JavaScript, creating objects and then spraying the heap is very obvious, right? You create the JavaScript, and within the JavaScript, you just copy multiple data and then make sure that it gets spraying the whole memory. that was easy in the past to do. But now, if you would like to do for another type of application, you need to find other methods. For example, make use of the functionality of the application by multiple times connecting to it, but not closing the connection. That will keep the memory. If you, for the heap rooming, that is different, right? So what do you do? So first of all, we can remove, for example, if in the previous example, you saw that one object got freed, but we still kept the object pointer. If you start spraying, then you will see that we will get our controlled object there. You see, here is a gap, and that is typically what will happen, and that is what JEmalloc is trying to prevent, that we don't have this pieces of block of memory that will not be able to allocate to anything anymore and not be used. That makes the system, the memory will, you know, if you use this in the kernel and you do it wrongly, you can imagine that your system will be very slow. Do you guys understand, or am I talking? If it's not understandable, just let me know. Also,
Definitely struggling with this one.
yeah, that's okay. You know, this is which part?
Just back around the heap spraying. So the use after free makes sense.
Yeah.
The heap spraying, obviously, it's a trade-off between trying to minimize fragmentation and optimize performance, and then you introduce security risks. But just the actual exploitation of the heap spray.
No, the heap spray is not an exploitation method. So keep that in mind. Heap grooming also not. People think that usually, but what we do is, this is a way to deliver our payload in a correct way, is to make sure that everything gets aligned, that the memory gets aligned, that we want it to be aligned.
Okay.
Because we just spray the heap as much as we can so that we can replace that object with attacker controlled object. Because if you, for example, even if you hold this pointer, you don't spray, your object that you create might come here or there. You know, it will be not at the location as in the past, that it will always come to the next one, for example. That doesn't happen anymore. Therefore, the spraying works very fine. Also, when you spray a lot of memory, the addresses become predictable. Because if you spray a whole bunch of memory, in the end, you will see that, for example, 42, 42, 42 will be mapped automatically. Because it makes sense, right? There are pieces of memory that will be available after that. But, you know, in JavaScript, yes?
Oh, sorry. So is heap spraying just kind of like a reconnaissance method for finding an exploit, like an exploitable memory address, or?
No, also not. So look, when we do heap spraying, we make sure that our object is getting sprayed everywhere. And there are two ways that why we do that. One, or we have a use after free situation where we hold a pointer still to this block, and when we spray, we have this, or we have an object that is here, for example, which is vulnerable for a buffer overflow that will overwrite into these other objects. So what we will do, we will make sure that this object is placed here and start spraying the whole heap, and then make sure that this overflow gets triggered, and we control that one. So we can now trigger and get PC control over PC. That's the thing. But look, now the tricky things come, and here the exploitation stuff. How do we exploit? Because the stack there, if you want to do a pop or anything, that won't work anymore, because the stack is somewhere else and the heap is somewhere else. So therefore, this is an exploitation technique. This is more of also part of the exploitation techniques, but it's not, it's more exploit delivery technique. It's not that you will directly, it's also not really true, but usually we don't see this part as an exploitation itself. And this heap grooming is a different thing than the heap spraying. During the heap grooming, what we do is we delete on purposely. So we spray and then start deleting little by little. And we do that on purpose to create gaps everywhere. And then make sure, this is also called heap massaging or heap feng shui. There are multiple names for it. But when you just remove little by little objects, and then the attacker makes sure, well, with massaging and heap grooming, etc.,
you place objects you make sure that the application place objects. You just manipulate the application by spraying and doing all this kind of stuff. I invite you guys to my advanced course. So come there and we can do this all together. But without a joke, in the end, you will do stack pivoting technique, and that is essential to do heap exploitation. There are techniques also not to do it. And look at this. You can use one gadget, because if you override PC, you will be able to execute one gadget, okay? Because the stack, you don't control it. You cannot do these pops and stuff and branch into another gadget, etc. That won't work. So we need to find a way to change the value of SP so that it points to another piece of memory, because the stack is just a conceptual thing. It's a conceptual piece of, it's a piece of memory that operates like any other memory, but we call it the stack. If you point the stack pointer to the heap, then all these pop instructions will work there. And that's exactly what we do. We search for one gadget that will move, for example, R4, which we control. You saw, right? During the overflow, we had more registers that we controlled. You saw, for example, I think R7 or so we controlled as well with a value. I calculated also the offset with pattern create, if you remember, that had a different value. So if you can find the gadget that is moving this value into SP, then this situation will happen. And when that happens, and you are controlling this, now you can build your ROP gadget here. And that will now, and then you will do the same trick, disable and with and protect the protection of the heap, and start executing code for anything else that you would like to execute. On x86 or 64-bit machines, not the ARM machine, you can also use one gadgets, the so-called one gadgets, and one gadget contains already a piece of one gadget, literally one gadget that executes into execute system/bin itself. You have those, and there's a tool called one gadget. One gadget, there it is. One gadget, best tool for finding one. So if you can control PC value, and this won't work. This tool doesn't work for ARM, but on other architectures it works. You can search for this type of stuff in the memory, and it will find it. I have done it myself. AR64. What? That's pretty cool. So you could use it now. It dumps a gadget for you that if you point PC to that gadget, it will automatically execute /bin/sh. But this won't work on Android, right? You have this /system/sh. I haven't tried the new ARM one, but anyways, that works as well. So how do you find these stack pivots? You do that again with using the wrapper, and you can find those here. For example, here is one, and eventually it is also branching back. So you can, it's the same, but the stack pivot is an important factor there. And that brings me to the end. Why? What is a nice article to look at? I add more articles here, but this one in particular is very interesting to read. This one is also going to win a Pawnee Award, I believe so, it will win it. But this is the article to look at. The new modern exploitation techniques and everything that are in here. You see that he's also adding this. By the way, I didn't know that he had this in there. I had it myself in there as well. And this is a different image, you can see that. But this is one thing that you need to read if you are interested in this type of attacks against mobile phones. So I highly advise you read this if this is seriously the idea, if you're serious in this stuff. You can see, I think I showed it already, but here they get access to Chrome renderer by out-of-bound access in V8. So they send a malicious link. They do later a mojo call to Chrome privilege process,
There's a use after free there. They do this binder call, as I explained earlier, right, to escape the sandbox to the Android system service process that will eventually call the Qualcomm GPU driver. This is also one that has been exploited by oh, that's here actually, sorry.
Google.
By Google Project Zero. They show an extensive article on where they exploit this GPU vulnerability. So yeah, you can see here also how he does stuff. I seriously advise you to read this because this is one of the coolest articles I have been reading. I'm not totally done with it also. So it's worth studying this. The cool part is this contains all the new type of techniques that you would use, you know, because it's very, very nice. And that brings us to the end. Wow, the Black Hat ended. So that was it for today, guys. Is there anything you would like to know or anything that I missed and you would like to hear now?
No, Amit, thank you so much. This was really incredible.
Thank you very much. Thank you. You guys were incredible also. Thank you very much for that.
And Praveen, thank you for your help as well.
Thank you so much.
So
Yes, thank you both for your patience throughout the whole thing. It was truly insightful and very informational. I'm looking
Thank you.
forward to looking into this more. I mean, I'm actually about to trade in my Android phone, or I was anticipating on trading in my Android phone for a new one, but I might just keep my current one to start doing this stuff. So thank you guys.
What type of phone you have now?
It's
Or
a Samsung Galaxy S10e.
Yeah, these are nice to work on. I also have a few here lying. I usually also work on those, but it can be a pain to boot them sometimes. So yeah, that's a bit of the thing. Thank you very much. I really, really appreciate the nice words and the interaction with everyone. So thanks again. And hopefully we'll see each other another time, and maybe once in real life in a conference or something. Please stay in touch over Zoom call. Oh, not Zoom call, over the chat with
Slack.
Slack. Yeah. So thank you. Have a nice day and have a nice evening. And please fill in the form for us. That's very important. All right. See you. Have a
Will
good
do.
day.
Thank you so much.
Thank you.
Thanks, everyone.
Cheers. Bye. Bye.